also learn lessons from the past. Ineffective regulatory instruments and adverse effects, like barriers to innovation, can be avoided if we look at the past experience of environmental regulation across the globe. So let me tell you about some lessons that we can learn from past experience. The first one comes from the US experience of environmental laws, which showed us that the limited command and control, that is the unilateral imposition of norms by governments, and best available technology strategies, that is the unilateral imposition of the use of one precise technology by a government, don't work. Why? Because they do not push regulators to innovate and to compete in developing the most cost-efficient ways to surpass climate objectives, for example. And that's why we saw the emergence of a concept called co-regulation, where the determination of the means to comply with regulatory objectives or social objectives are delegated to the regulators who know better the technology and who can compete between them to develop the most cost-efficient ways to reach these objectives, or even to surpass them if they are incentivized to do so. Second lesson is that there is no one-size-fits-all solution. Some argue in the AI sphere that we should let actors self-regulate. What the experience of nuclear safety regulation shows us, for example, is that self-regulation can work only if the interests of all actors are aligned. In the nuclear safety regulation, you can think of the general public, the nuclear operator, and the governments. Each have the same interest in preventing nuclear accidents, both to prevent the harm to the environment, but also because one single nuclear accident in the world can lead to the end of the entire nuclear industry. So everyone has the same interest in controlling each other and advance nuclear safety. This interest alignment, it is not the case with AI, where we have a lot of competing interests. The third lesson comes from the successive environmental laws and emissions cap in the automobile sector, for example. It showed us that environmental regulations can be built gradually, can be responsive to scientific evidence and consensus. So experimentality and graduality are important characteristics of a good regulation. And finally, we can learn a lot on the consequences of deregulation from the experience of the financial sector. The financial sector has been marked by cycles of regulation. No regulation in the 20th century, very strict regulation after the 1929 crisis, then deregulation in the 90s after the end of the Cold War, which eventually led to the 2008 subprime crisis, after which we saw the re-emergence of prudential regulation that we know as of today. So in markets characterized by systemic risks, deregulation seems to lead to crisis. And the AI market is a market with systemic risks because AI can be used in a wide variety of applications and basically across all sectors. So all of this has to do with AI and sustainability. It starts to be common knowledge that AI companies should take environmental costs into account. You may have seen charts like that. This is a modelization done by Schneider Electric, which modelized different scenarios of electricity use by AI. The truth is you can find dozens of such simulations. No one is reliable, but they at least give an idea of the tendency. We also have our own problem with data centers, and even in France, with the example in Marseille, with data centers that led to problems in terms of monopolization of drinkable resources, biodiversity harm because it used cooling techniques called river cooling, and also it is a very good illustration of what's called the conflict of electricity use. Because when you authorize a data center to connect to the grid, maybe you put it in priority in front of other public interest projects. And in the case of Marseille, data centers have been prioritized over, for example, the electrifications of the harbor case, which is key to allow electric boats to come to Marseille. So there is also a problem of conflicting use of electricity. And this, I won't dive into the other environmental impacts because I think other speakers after me will do that way better than me. We have the problem of rebound effect, we have a problem in terms of material needs, and a lot of stuff that we don't even, we can't even measure. Yet, current regulation falls very short in addressing these environmental impacts. For example, the European AI Act only provides for documentation obligation of the computational resources needed for the development phase and only for certain type of AI systems, namely high-risk AI systems that are, for example, systems used in critical infrastructures and general-purpose AI systems and models, basically LLMs. Only a documentation obligation and focus on the development phase, so now it ignores completely operational emissions, water consumptions, or material needs, for example. So the sustainability in AI problem is what we can call a wicked problem. This is a term coined in complexity economics to define problems very difficult or impossible to solve due to their incomplete, changing natures. It also defines problems for which potential solutions can be even worse than the problem itself. So very complex problem. And indeed, the AI market is marked by complexity characteristics. The first one is that it features many interacting agents with conflicting interests. You have the AI providers, data centers company, energy providers, grid operators, governments, citizens, users, for example. Each of them have conflicting interests and also conflicting interests depending on where they are on the globe. The second characteristic that the AI market feature is fundamental uncertainty, because you have fundamental uncertainty on the dynamics of innovation, for example. You can't forecast the adoption rate of AI. You can't predict the scalability of the solution. You can't forecast the technological developments as the field is evolving so fast. The third characteristic is that the existing governance infrastructures have a very limited effectiveness in addressing such problems, such environmental problems. And think of the ineffectivity of international environmental law, for example, from which Donald Trump just withdrew. And finally, all of these aspects are also interdependent and interact with each other, which add to the uncertainty over this problem. So basically, information is lacking, expected values are not reliable, and dynamics are continuously changing. That makes all traditional instruments to inform policymaking completely inefficient, like cost-benefit analysis, because we don't have expected value that are reliable. But at the same time, as the economy is path-dependent, as I told you, a laissez-faire approach could lead us to jeopardize our capacity to live a world where technology is compatible with planetary limits to future generations. So we can't do nothing at the same time. Then we need to find a way to co-regulate with market actors to find a sustainable path toward in AI. Considering the wicked nature of the AI and sustainability problem, there is no point in attempting for me to say this is precisely what regulatory instrument we should put in place in all countries. Our role as legal scholars is to inform policymakers and lawmakers on what is legally feasible, that is to say, what are the options on the table, what are the foreseeable consequences of each option, what lessons can be learned from the past, and what are the criteria one should take into consideration when choosing a regulatory instrument. That is why the purpose of my research is to build a regulatory toolbox. This is something used in other sectors like telecommunications, for example, where public authorities have a wide variety of powers at their disposal so that they can conduct targeted and temporary interventions depending on the context and on market dynamics. That allows for a very more flexible approach to a regulation, and this is more compatible with a fast-paced environment like artificial intelligence. So the regulatory options range from supply side, so-called technology push measures that aims at encouraging the adoption and the integration of sustainable practices into the AI design, to demand side, so market pull measures, which goal is to empower AI users and buyers to take sustainability criteria in their choices. So examples of technology push measures involves, for example, the use of ex-ante environmental impact assessment for the biggest model, sustainability by design requirements that do not have to be imposed by the government, but they can also be defined by the actors themselves and through voluntary codes of conduct or voluntary adherence to norms, for example. Also incentive to open source AI, which encourage the mutualization of compute capacity, which is something that we want. And examples of demand-side measures include, for example, transparency requirements, because these allow AI users and consumers to make informed choices when they are choosing an AI to buy or when they are choosing which AI systems to use. Transparency, sustainability requirements in public procurement or ecological bonuses. And the idea is to create a green AI market that can drive then the adoption of sustainable technologies. So by this talk, to conclude, I hope to have you convinced of three main things. The first one is that regulation is not about restricting behaviors and innovation. Not all innovation is a synonym of progress. Regulation can be a tool to ensure meaningful progress. Sustainable AI regulation is not about flogging AI developers. It is about promoting the sustainable uses. Second, facing fundamental uncertainty, it is not relevant to rely on expected values of future benefits to base any policymaking decision in the short term, including a decision not to do anything. Third, there is value in having multidisciplinary discussions on regulation issues between regulation scholars, computer scientists, environmental scientists, psychologists, economists, sociologists, basically all disciplines, because all of them contribute to a co-regulated world. And I'll finish on that. Interdisciplinarity, in my opinion, will be key in finding the appropriate solution and ensure a sustainable future for AI. Thank you.
Thank you very much, Thomas, for this talk. So we have 5 minutes to take 2 questions, if we have some questions. About regulation. Question there.
Thanks. A very interesting talk, and I very much agree with you about the benefits of regulation rather than the problems. But could you expand on what you mean by co-regulation and how that works across disciplines? Thanks.
Yes. Vocabulary check. When I talk about regulation, sometimes my students or people that come from other disciplines and that are not familiar with regulation do not share my understanding of regulation. That's why I want to precise that before answering your question, because it is very linked to the idea of co-regulation. Sometimes people think that regulation is legislation. Okay. My view of regulation, which is now getting more popular in the field, in the legal field, but also in the design and computer science, is that regulation is all the action that people do and that can have effect on others. That means that engineers are considered as co-regulator because their design choices contribute to regulating social phenomena. So we need, once you acknowledge that, when you are building legislation, your objective should be to leverage market forces and to incentivize people to change the way they design things because they are the one co-regulating. So we need to find ways to incentivize them to do choices that contribute to the regulation, because it is not just a top-down approach, but it acts in the two ways. So if our goal is to reach sustainable AI, we need a bottom-up approach from engineers to integrate the sustainable practices in the design, and also action from the government to incentivize this type of sustainable practices. So that's what I meant by co-regulation.
Thank you. We have time, one more question here. Front row. Microphones are arriving. This here.
Do you believe that this documentation only of the AI Act is the only reason why big tech allowed it to pass?
Can you repeat the end of your question? I'm not sure.
It's only documentation that needs to be produced. Do you think this is why big tech, GAFAM, why they allowed it to pass and their lobbying?
It's way more complex than that, because it's a huge and complex text. So we can't say that this is because it's only a documentation obligation on the sustainability question that this is why the text passed. But of course, doing something more stringent would have led to more opposition from technology companies if they're, because it gives them more, it generates more compliance costs and so on. So obviously, having something more stringent would have raised more opposition. And to be honest, in the process of the legislative process, the European Parliament version was very more stringent on environmental regulation, and it faced so much opposition that it has been watered down throughout the process. But it is a democratic process with a certain influence from the private sectors. So yes.
Okay, thank you very much, Thomas, and thank you. So we call the next speaker, Ricardo Vinuesta. He's associate professor at KTH in Sweden and the lead faculty at the KTH Climate Action Center in Stockholm. So he studied mechanical engineering at the Polytechnical University of Valencia in Spain and received his PhD in mechanical and aerospace engineering from the Illinois Institute of Technology in Chicago. So Ricardo has received, among others, an ERC Considerator grant, the TSFP Kasagi Award, the MST Emerging Leader Award, the Goran Grafson Award for Young Researcher, and IIT Outstanding Young Alumni Award, the Sares Young Researcher Award, and leads several Horizon Europe projects. And is also a member of the Young Academy of Science of Spain. Ricardo, the floor is yours.
Thank you very much for the introduction and for the invitation to be here. It's a great pleasure to share with you our work on AI and sustainability, and I think it's a great follow-up to the previous excellent presentation. So some of the initiatives that I'm going to be talking about today have to do with the Sustainable Development Goals. Of course, I don't have to introduce too much the SDG agenda to this audience, just to highlight that this is a common blueprint for prosperity for the whole planet, which involves 17 big goals and 169 targets, which are basically sub-goals within these larger ones. So something that we wanted to do was to kind of assess whether artificial intelligence can help positively or negatively the achievement of the SDG agenda. And as we know, the SDG agenda involves a very broad range of topics, from ending poverty to climate impacts, but also economical and societal aspects, right? So it's very broad. It's a very broad set of goals. And the idea is that we wanted to really go at the target level. So we wanted to study whether AI can really impact positively or negatively each of the 169 targets, and this requires a quite big effort in terms of the team. We had to put together a very broad multidisciplinary team spanning all the range of topics that we had to really work with. So this was published in Nature Communications in 2020, so a bit more than 5 years ago, and we realized that many of the conclusions that we had there were holding true even nowadays, and some of the things that we predicted in terms of the impact of AI on everybody's societies and lives were kind of true. But of course, some of the actual analysis and predictions will have to be updated with current data. But I think most of these results still hold quite true nowadays. So what we did was to put together this team. So we had 10 people, 5 men, 5 women from all over the world. We had experts in machine learning, experts in interaction design, experts in economy, in law, in ethics. We also had experienced people in biodiversity. So we really, this was like a 2-year process of workshops, interactions, discussions to really be able to put together a quite comprehensive analysis of each of the targets. And we are very lucky to have, for instance, Virginia Dignum, who is been very active in AI ethics at the European level, and also Max Tegmark from MIT, who has also been very active in AI sustainability and basically the future of AI. So we're very lucky to have a very complete team and a very broad discussion. And the first thing that we did was to split the 17 goals into 3 main categories: the society, the environment, and the economy. This is a reasonably standard classification in the Stockholm Resilience Center, also by the UN, but this will allow us to have a quite, holistic view of these impacts in terms of positives and negatives. So we first divided all these SDGs into these 3 categories, and what we wanted to do was to really go to the target level. So we followed the following process. We have, for a particular SDG, in this case SDG 1, we would have typically a couple of experts who would do a first pass through the literature. This is research articles, research projects, and even also deployed AI applications, trying to find evidence of whether AI can act as an enabler or an inhibitor for that particular target of the SDGs. So in this example, we have for target 1.1 that both AI can be an enabler and an inhibitor. This is quite common, that AI can act as both. It can help certain things, but it can also hinder the achievement of other aspects within that target. And in this particular case, both Sami and Simone were the experts who made the first assessment of this target. And what we did was to also have an expert elicitation process. So we had, in this case, Yolanda and myself would be the experts, and we tried to have experts with good knowledge on the topic being studied, while the reviewers would have complementary knowledge. So maybe they would not be very experienced in that particular SDG or that particular topic, but we wanted to have a bit of variety, being able to bring in some different perspectives. So there was a discussion process through workshops and interaction to try to poke holes, kind of like a red team sort of thing. So trying to poke holes in the original argumentation and the original assessment made by the first experts, right? So and this is a very complete Excel file. So you can see for each of the 169 targets, first of all, the assessment of positive or negative effect. Second, you can see a reasoning. So there is a paragraph here of why we make that assessment. And third, what we have is references. So we have 3-4 references for each of the 169 targets, so quite comprehensive work. And after there was convergence in this expert elicitation process, then we would report both the positives and negatives. This data set is online, so you can access and go into all the details, all the intricate connections, if you're more interested in all the evaluations that we made. I'm going to focus today on a few examples to highlight. So let's look at some of the results. What we found is that 79% of the targets can be positively affected by AI, whereas 35% can be negatively affected. So this shows, in principle, a positive message. There is good potential. We can really do a lot of good if we can leverage AI in the right way. But of course, we should not undermine the negatives, and this connects also with the previous talk. Only one target being negatively affected can have cascading events and cascading interactions that can lead to unexpected consequences. This is because the SDG agenda is a highly interconnected system with synergies and trade-offs between all the targets, and I'll be talking about that in a few minutes. Therefore, one should be very aware of the negatives because of those cascading effects. If we go into the 3 groups I talked about before, the most positive group is actually the environment, where 93% of the targets can be positively affected by AI, while the society exhibits the biggest threats. So 38% of the targets in the society can be negatively affected by AI in a way that we have actually seen years after 2020 with the pandemic, with the war in Russia, with many, many things that we're talking about every day. So this is important to keep in mind for the big picture. If we go into more detail, we can actually see these 2 figures. On the left, I'm reporting positive effects of AI on each of the targets, and on the right, negative effects of AI. We're going to focus for now on the light color outside. About the darker one, I'll be showing it later. And what you can see in these 2 wheels is for each of the SDGs, SDGs 1, 2, and 3, which are grouped into the 3 areas, society, environment, and economy. This number is the percentage of targets that are positively or negatively affected by AI. So on the left, you can see that, for example, SDG 3 on health has 69% of the targets being positively affected by AI, and 8% of the targets can be negatively affected by AI. So this is an assessment that we made at that time. Again, if you go to the Excel, you can see all the details, all the connections, and all the argumentation, but this is kind of like the big picture, the overall ideas that we can actually find. Now, you will tell me, sure, but not all the references are the same. Not all the evidence is equally strong. So that's why we did this extra analysis where we took all the references, and again, this is 3-4 references times 169 targets. This was quite some study and consensus to be able to classify them into 4 main categories, A, B, C, and D. So the A type of reference is the strongest one. So this is a type of a study that can be easily generalized, that can really, is based on strong methods and that can really be implemented, and that has a weighting factor of 1. So basically, a target affected positively by an A reference counts as 1. And it goes down B, C, and D all the way to the lowest, which is the D type of reference, which has a weighting factor of just 0.25, where here what we say is that these are very speculative references. So perhaps there is a connection, but it's not very clear how that method is reproducible or how can it be implemented in practice. So this would give us basically a weighting factor of 0.25. So just 1/4 of a target would be counted when a D type of reference is documented, basically. So this classification into types of reference material gives us the darker color inside the circles. So you can actually see that by definition, the darker area is going to be smaller or equal than the light one because the weighting factors go up to 1. So we basically attenuate the effect of the references that are less strong, basically. And here one can do something quite interesting. If you compare the reduction from the light color to the dark one, so how much impact reduction happens when I take into account the strength of the evidence, then you can actually find research gaps, right? Because there is evidence that there is an effect, but you can't really point out how strong because of the weak evidence. And we found 2 interesting things. If you look at the right panel, the negatives, you see that the reduction in the environment and the society is very significant. So in a way, the negative effects of AI on the environment and the society have not been sufficiently explored. There's a lot of evidence, but it's maybe not strong enough. So that was a research gap that we identified at the time. And if you look on the left, the biggest research gap is on the economy. So the positive effects of AI, you can see it actually over here that I'm reducing from this light color to this dark one over here. The positive effects of AI on the economy have also not been sufficiently investigated, right? There is evidence, but it's not strong enough. That's another research gap that we identified at the time. So this is important with, and the timing is actually interesting with all the discussion that we have about productivity and loss of jobs and so on. So really, those positive effects need to be investigated in further detail. Let's look at some examples. And again, I'm going to give some high-level examples, just not to spend 3 hours going through the 169 targets. In the Excel, you can see all the details. Overall, the positive effects are through new technologies that are enabled through AI. So one example of this would be on SDG 1, on no poverty. So for example, this is work done at Stanford quite some years ago, 9 years ago, I think, where what they did was to really use satellite images, analyze them through computer vision tools to identify regions of poverty, right? So this is a clear example of how AI enables to do something that really can have a positive impact in terms of SDG 1. And the negatives are typically through increased inequalities or unequal access to the technology. So a typical example would be on SDG 10 on reduced inequalities, where if the future heavily relies on AI, as it appears to be the case, and not everybody has the same type of access to AI, then we're going to exacerbate existing inequalities and obviously have a quite negative effect on SDG 10 on reducing inequalities. So I would say that being a bit generic because there's a lot of nuances, but the positives are typically through new technologies that are possible. The negatives are typically through unequal access or inequalities, which goes hand in hand also with the environmental impact of this technology, which I'm going to talk about as well. So that's a little bit the general idea. We also explored, and this is another article in Transportation Engineering. This was a year later where we did a workshop at KTH, gathering a lot of experts. Max Tegmark came to also talk about this. And we focus on the indicator levels and also on the gender aspect, where there's two types of gender gaps in AI technology. One is in the data, one is in the workforce, right? So, of course, in terms of the data, there is a clear problem when you're using these methods for medical applications or many other areas. And in terms of the workforce, there is a strong bias of the people who are also developing these technologies. So you need all the perspectives, you need all the inclusion and diversity to be able to develop algorithms that gather all the perspectives. So this was also that we discussed quite a bit in terms of SDG 5. And here you can see some key examples as well. There is quite some potential in SDG 7 in terms of clean energy and SDG 13 in terms of climate action. But here I would like to highlight, and again, this is an estimate from 5 years ago, so probably if we would have to do this today, things would change, right? But 5 years ago, the idea is that the usage of data centers in terms of electricity, it was 1% of the total consumption, and it was projected that by 2030, this could go up to 20% of the total global demand. And now we are in times of high uncertainty. This could go much higher, so one should really be aware of how to handle this. And I mean, at the end of the day, there's all the debate of the environmental impact of AI. But of course, one can always be smart in the way that you're training models. You can introduce inductive biases. You should use approaches like transfer learning. And most of all, one should be aware of the environmental impact of AI when running a model, when trying to train and perform inference on a model. So I come from the high-performance community. And in the high-performance computing, every time that you do a simulation, you get a bill with the economical cost of the simulation and the CO2 impact of that simulation. So I always tell my students that before running a job on 16,000 processors, 32,000 processors, look at the bill, but not at the economical one. Look at the CO2 impact, because there's a lot of good that can be done just by changing the mindset of people developing these models, right? If you know what's going to be the impact of that simulation of that particular model, perhaps you're going to think twice before sending the job to the big cluster, right? So I think there is this important change of mindset that is very much needed, actually. So this is about environmental impacts. I want to also provide a few examples in terms of SDG 9, innovation and industry. There's quite some ideas in terms of new opportunities enabled by AI. We can optimize electricity usage for many applications, better models for bank performance, smart cities, and also being able to smartly split tasks into simpler modules that can be distributed more efficiently. But of course, some of the negatives have to do also with the uneven access to AI, right? So there could be loss of jobs due to lack of qualification, and of course we could have a quite unintended impact on the global south if the access to AI is hindered in certain areas, right? So there is great potential. We should really be aware of all the problems with the uneven access of AI. Also, in terms of SDG 4 for quality education, there is quite some potential to steer and adapt the curricula to students, gathering data, being able to monitor, being able to dynamically adjust to the students' needs. But of course, this comes again with a very specialized qualification for the teachers, which can be a problem to be able to really harness all the potential. And at the same time, there is the possibility that there could be biases introduced by the countries that are developing this technology. So the local needs of communities in certain areas in the global south, in certain culturally special regions, you're going to lose those characteristics if you're trying to develop global AI technology for education. And that's also something that needs to be captured by the models. So this is something to keep in mind as well. In general, and this is something that has to do with the SDG 10 on inequalities and 16 on the stable institutions, the political polarization that we have seen over these past years, is exacerbated by AI. So there is a big potential to polarize societies, and that's something that is happening. I would also say one of the strongest conclusions of our article was that regulatory oversight needs to be preceded by regulatory insight. So one needs to involve experts, one needs to involve people who know what AI can and can't do before regulating, and really have a global debate, and mostly, and more importantly, including everybody in this dialogue, because AI was going to impact everybody's lives in 2020 and is impacting everybody's lives nowadays, right? So there is really a strong need to involve everybody on this. We also did some work in terms of digital contract tracing during COVID. Here I want to highlight, we put together a socio-technical framework that was also quite much needed. Here I want to highlight that it's usually the governance and the transparency when implementing these apps that can be key. And this is a good example for what happened with technology. So this is another study where we talk about these things in data-driven methods for health. And I want to also highlight these interactions, right, between the technology, the society, and the governments. In this diagram, the thicker arrows indicate faster change. And we can see clearly, and this is something that we are seeing, even, again, this was done 5 years ago, right? But with LLMs and DeepSeek, OpenAI, this is even more true, right? I mean, the technology grows very fast in creating new needs for the individuals. The individuals lag behind the technology, and the governments are way behind in terms of regulation, need for standards, need for really being able to catch up with what's happening from the technology point of view. So this interplay between these three agents is really key if we want to really understand what's happening and what's going to happen in the months to come. I guess the time scale that we're talking about is not years anymore, it's months. This is something that we also wrote some time ago about interpretability in nature machine intelligence. So we really highlighted the need to develop interpretable models if you want to impact the SDGs positively. Going back to the example of the computer vision to analyze satellite patterns to detect poverty, if you develop an interpretable model, and there's quite some work now on inductive biases and symbolic regression to try to come up with equations that can reproduce the performance of the models, then if you can, instead of having a black box, you have an equation that predicts the per capita consumption in terms of amount of light in the night in the pictures, in terms of distance to the road, to a main city, in terms of the number of roads. If you can come up with such a model, then not only you can predict the consumption, you can also predict its dynamics. And then you can anticipate and create coordinated actions to have a better impact on the SDG that you're trying to tackle. So interpretability is key. And I want to also highlight, before I finish, a couple of things that we're working on now with LLMs. So what we're doing now, and this is together with the UN and with Google Research, is basically trying to identify synergies and trade-offs within the SDGs. And this is something that has been done by experts many times, but we're interested in the hidden connections. I mean, there are obvious connections between the SDGs. If you affect the amount of water because you want to preserve certain species, life underwater, you might have a negative impact on SDG 1 and 2, for instance. So there are obvious connections, but I'm interested in the hidden ones, because those hidden connections is what's going to allow you to eventually, and I can show you a little bit of what we're doing, make optimal policy decisions. If I want to optimize the achievement of SDG 13, I need to first connect all the documents, all the policy, all the projects, all the research articles with SDGs. I want to create this matrix of positive and negative synergies and trade-offs, and I want to eventually, through optimization, create optimal policy decisions, right? So we're at the stage of being able to establish those synergies and trade-offs efficiently. And this is work that we have under review in Nature currently. These are some results that we obtained, so you can see synergies and trade-offs among all the SDGs. Again, if I want to optimize, I want to have the global picture. If I want to invest in SDG 13, I want to see that there are going to be negative effects on the society. So this is something that we are really working very hard on. And we're using different LLMs. I mean, we have been using Gemini, GPT, Llama, and now also we start to use DeepSeek. So we really try to do the cross-comparison of performance among all the models. And this is something that we also talked about when there was this was in Nature Climate Change, when there was the discussion about the moratorium for pausing AI. Our view there, that was a commentary piece, was that one should not stop technology development, because at the end of the day, the solution to a lot of the regulatory problems will also come from technology itself, from the development of AI itself. So it should not be about stopping, it should be about improving regulation, it should be about engaging public and private sectors and together really pushing forward in terms of AI as one solution to the environmental problem. And this is also one last piece of work that we are doing. We have the SDG agenda up to 2030. There is also the planetary boundaries, which is put together by the Stockholm Resilience Center. And the planetary boundaries are basically a bunch of measurable quantities that should not be passed through certain thresholds to ensure prosperity in the planet. We are unfortunately quite in the red in several of those planetary boundaries. What we want to do with generative AI is to obtain a consolidated agenda incorporating the SDGs and the planetary boundaries. So the more environmental aspects in the planetary boundaries, the more societal, the more economical, in such a way that we can have a streamlined, consolidated agenda beyond 2030 to take into account all these things. And there's a lot of synergies and trade-offs between both agendas. So that's the type of stuff that we want to really identify in an unbiased and objective way. And that's all I have for today. These are some of my conclusions. At the end of the day, our main idea is to really redefine the future agendas for sustainability and help make optimal policy decisions using AI and using generative methods. I'll be happy to take your questions.
Okay, thank you very much, Ricardo. Nice. So we have time for some questions. Okay, question here. Microphone is arriving. Here, we have questions. Okay.
Thank you very much for the very useful lecture. You referred very much to your article 2020, but you know AI is moving extremely quickly. So in a sense, what you said today, was it strictly based on your article 2020, or has it incorporated recent developments, which some of them have been really spectacular?
Yeah, that's an excellent point. The quantitative data is from 2020, so the actual numbers, but the discussion and the conclusions, I mean, is taking into account current developments. And I mean, of course, some things need to be fine-tuned, but most of the conclusions still hold today, yes.
We have a question here again.
Thank you for the talk, really interesting.
Thank
I
you.
was wondering to what extent you include the magnitude of the effect in the study, because the graph seems to show the number of targets it could help, but you could imagine that having a dramatically negative effect on one target would actually outweigh the benefit of small benefits on a dozen others. So the big green area may be a bit misleading in that way.
Yeah, that's an excellent point, and that's what motivated what we are doing now with LLMs, basically, and other optimization methods. So it's not so much of a purely literature survey of what could be the effects, but rather a detailed twin for policy development. That's what we are trying to do. So with this technology that we have now, we can then quantify not just the connections, but the strength of the connection, no? Which would be the thickness of those areas and interconnections between SDGs that I was showing before. So that's what we are doing now.
Okay. No more questions. No regret. So thank you very much, Ricardo.
Thank you.
Thank you. Thank you. So now I call next speaker is David Rolnick. So Lynn, unfortunately, was scheduled, but she's sick. So David Rolnick is working with her, and he is assistant professor at Canada CIFAR, AI chair in the School of Computer Science at McGill University and Mila, Quebec, AI Institute. He's also co-founder and chair of Climate Change AI and serve as a scientific co-director of sustainability in the digital age and co-lead the Global Climate Center on AI and Biodiversity Change. So David received his PhD in applied mathematics from MIT. He's an AI 250 fellows and a former NSF Mathematical Science Postdoc Research Fellow and Graduate Research Fellow and Fulbright Scholar, and was named of the MIT Technology Review 2021 list of the 35 innovators under 35. So David.
Thank you so much. Can you hear me okay? Awesome. Thank you so much for including me. In place of Lynn, I will do my best to hold up the place that Lynn had to vacate. There are a lot of different things that the speakers have already touched on related to AI and climate change. And I'm going to try to synergize some of them and debunk some misconceptions. There is a lot of news on AI and climate now. And it really falls into two main camps, generally speaking. One is AI is going to solve climate change. The other side is AI is going to use all the energy in the world. And oftentimes, these are placed in conflict. Something that looks like this. AI can help solve climate change, but it uses a lot of energy. I hope by the end of this talk, you will disagree strongly with this question, with this statement. There are several things wrong with this. Let's dissect, first of all, how AI is helping solve climate change. which is true. And then we're going to dissect how AI is using a lot of energy, but then we're going to look at a bunch of other things. So first of all, how is AI helping to solve climate change? We've analyzed this extensively at Climate Change AI, which is the nonprofit that I lead together with Lynn Koch. And I'm not going to go into all the different ways that AI and machine learning can help tackle climate change. There are numerous applications across all these different sectors, from electricity systems to buildings and cities to agriculture, forestry, and other land use. And there are so many specific ways that AI and machine learning are being integrated already into existing tools for tackling the climate crisis. Some overall themes that we see: first of all, improving operational efficiency, taking complicated automated systems like heating and cooling systems in buildings, helping them run more efficiently, taking the manufacture of steel and cement, which together contribute about 15% of global greenhouse gas emissions. So we're seeing these AI systems in everything from smart thermostats to the systems that are being integrated in factories right now. Gathering information, taking big unstructured data sets and turning them into useful information to guide policy, to guide other kinds of decisions. So for example, here you can see systems that are being used leveraging AI to track biodiversity. That's also the case with systems that are being used with satellite imagery to track carbon stock, monitor deforestation, monitor the effects of climate change like flooding in real time, etc. Forecasting, taking time series data. The UK's National Grid, for example, has introduced AI systems for predicting the supply and demand of electricity that cut the error rate in half for predictions of how much energy needed to be produced at a given point in time in order to meet demand. This enables huge savings in electricity production. Speeding up simulations. We have very good models of how the climate is changing, but they are very slow. They can take months to run, even on supercomputers. And AI can help speed up models of climate and weather and make them be more granular and more relevant to local decision makers. And then accelerating scientific discovery itself. We need a lot of innovations in order to accelerate the energy transition. And AI is being used to suggest new materials in areas like batteries and photovoltaics, like perovskites. These are some of the many ways in which AI is being used to help tackle the climate crisis. I'm going to go into some particular examples later on, but I want to first tackle the other side of this, what's presented as the other side. AI can help tackle climate change, but it has huge energy consumption. It does have huge energy consumption. These are graphs of projected energy consumption by AI algorithms starting a few years before the present day, all the way up to way in the future. There's some disagreement, but you can see all the curves are going way up, and they're going way up to places that are actually a pretty significant fraction of global electricity production right now, certainly electricity production in low-income countries, and even in places like the US. So there is a problem here. I'm not going to fully talk about this graph and what contributes to it and what we can do about some of the pieces here. I know that Sasha is going to be speaking a bunch about these different aspects, both in her talk after this and in her keynote. But I can touch on some of the different ways that these energy costs appear. They appear from operational emissions at the stage of development of AI systems, which happen relatively infrequently but take a lot of energy. Then when you're training a system, which they typically get retrained periodically if they're under deployment. So that happens sometimes, and it also uses a lot of energy, not quite as much as development. And then when you're running the system, so if you ask ChatGPT a question, that happens a lot, and the energy per run is less. But because these sort of counteract each other, each of these components is significant. And then there's the embodied emissions as well. Production of hardware takes a lot of energy. Mining that, transporting the materials, and then when you need to dispose of them, that requires energy too, and it generates emissions directly. So all of these things, all of these aspects of computation in AI have significant costs. And as that curve goes up, all of these components are getting more intense. It's a big issue. So why do I think that this framing is wrong? Well, because it's posed as a trade-off. We can get the benefits, but we have to have these harms. And I don't think we need to accept that. This trade-off framing assumes that AI is one thing. And in actuality, AI is a menagerie of different algorithms. It's the equivalent of elephants, and it's the equivalent of little tiny insects. Maybe the elephants are ChatGPT, DeepSeek, Midjourney, big Gen AI algorithms. They're constantly in the news. Maybe the bees are UNets, ResNets, LSTMs, physics-informed neural networks, interpretable machine learning, a lot of different tools from deep learning and from classical machine learning and classical AI that are much, much smaller and have sometimes literally a billionth as much energy usage. And there are a few things that I want to stress with this analogy. First of all, there is a huge difference in size. AI means lots of different things. But second, an elephant isn't just a big bee. They're different things. These Gen AI algorithms, like ChatGPT and Midjourney, they're designed to generate text, images, video generally. These other algorithms are designed to do different things: classify, optimize, predict. On the left-hand side, you've got algorithms that often have extremely broad goals and extremely large data sets. Maybe the entire internet is basically the training data for one of these elephant models. And on the right-hand side, you've got algorithms that have generally much narrower scope and much narrower data. They might still be what's called foundation models, but they're not trying to do literally all the things in the world. And then here's the kicker. The algorithms on the left are not actually the algorithms that are being used in all of those applications before. If you want to benefit climate change, none of those applications rely on these elephant algorithms. Just because generating text, images, and video is not, generally speaking, what is necessary. Now, there are some applications. Those examples that I gave were not those applications, and I'm not trying to say that there aren't reasons why you might use ChatGPT in helping tackle climate change. There are certainly some. But in the vast majority of cases across sectors, what's needed are these smaller, more focused models. And so, I mean, I'm sort of saying you can have your cake and eat it too. Let's look at the overall, if you look at the overall space of what is useful, high computation AI is only useful sometimes. So if you think about this menagerie of AI algorithms, all the different use cases across society, this is what I would like to see. I would like to see some specific cases where we need elephants. And most of the cases, we're going to need bees. And if we try to use AI in all the different ways that it can be useful, that means using the right tool for the job. This is what I see often being discussed. Let's use LLMs, or big generative AI algorithms, for everything. And this doesn't work, not because just the algorithms are using a lot of energy, but because they're the wrong tool for the job. If you're a farmer and you want to pollinate your crops, not to push the metaphor too much, you don't want elephants, you want bees. And I'm seeing people trying to throw LLMs and other large generative models at everything. Sometimes they're useful, in many cases they're not. I'm seeing people saying, okay, to solve the problem of large energy usage, let's make LLMs smaller. If you want to pollinate your crops, you don't want smaller elephants, you want bees. Smaller LLMs are still doing the same things. And to be clear, I'm not talking about problems with LLMs like hallucinations or fabrications. They're just they're not designed to do these particular things. We'll get into some examples. But I'm seeing this a lot. I'm also seeing, let's integrate LLMs with sort of particular things that we like in a specific use case. So maybe this looks like this. Let's make the elephants more like bees. The bees are fine. So I think that this is where I would like to see transformation in the way in which we think about how AI and energy usage and climate are interrelated. Thinking about this not being a trade-off between we get the positive impacts or we have these great applications. We can, to some extent, have both by being selective and choosing the right tool for the job, which doesn't mean always no LLMs, but it means like we pick what we need. And so let's go into some more details here. Here's an example from my own group's work on AI for remote sensing. And one of the applications which motivated us here, because we work with partners like NASA Harvest and the European Space Agency's World Serial Program, which are responsible for mapping crops for governments around the world. And if you want to go from something like this to something like this, which is, you can't really see it, but this is a map produced for the government of Togo so they could create policies to help farmers. And so it's a map of all the crops in Togo. And if you want to create that, you need scalable remote sensing algorithms. And so how do you do this? Well, you don't ask ChatGPT. And that's not just because it's big. It is big, and the agencies that are using these algorithms, they don't have anywhere near this amount of computational power. Like if you ask them to be running a large generative AI algorithm, they couldn't do it. And operating this on the scale of the world is just not scalable, even for OpenAI servers. But that's actually not the reason why you wouldn't want to use it. It's because ChatGPT just wouldn't be able to solve this problem. There are actually standard approaches from computer vision, like vision transformers, which are designed on to do tasks like classifying images in ImageNet. And those are also quite big, not nearly as big as LLMs, like maybe 100 million or 1 billion parameters instead of 1 trillion parameters. But those are actually not the best tool for the job. The best tool for the job, we found, is an algorithm that we developed called Presto, which has about 1,000 trainable parameters instead of 1 trillion. And again, this is not better because it's smaller, though it is also better because it's smaller and more scalable. It's also just better. Like numbers-wise, it does a better job of mapping the crops. And we'll see why in a moment. But this is the case in a lot of situations where if you design a tool for a specific task, this is the right tool for the job because you can build in the problem you're trying to solve. But I'm getting a little ahead of myself. This turns out to be best not just for mapping crops, but also for assessing fuel moisture, which is important in assessing risk from wildfires, in tracking trees, and in measuring algal blooms, which are made worse by climate change. So how does this work? How do you get 1,000 parameters to do better than 1 billion parameters? Well, it's because you use the structure of the remote sensing data. And in this case, the vision transformers were designed to work with natural images, which means like images on the internet, like ImageNet. And if you use the structure of remote sensing data, you can take advantage of the fact that there are many different sensors coming from a satellite, there are many different points in time, and you can use what's called self-supervised learning to take that data, the structure of the data, and use it to learn better. In this case, you can eliminate certain time points and eliminate certain sensors and use the other ones to predict that. This is what's called a masked autoencoding framework, and we do it in a particular structured way. And here, we are able to basically use unlabeled data, which exists everywhere in the world, as its own labels. And what happens in practice, then, is that you have these pre-learned data representations that you're then able to use to learn a new task from a small amount of labeled data. So you can then go out and learn from a small data set how to predict crop type or classify different kinds of trees. And this is why you end up with an algorithm that is able to outperform all these other algorithms because it was designed specifically to do this thing. Okay, let's take a look at another example. Very quickly, in power grid optimization, there's this problem called ACOPF, AC optimal power flow. This is the mathematical formulation of the problem. For the computer scientists in the room, this is a non-convex optimization problem, which means this is hard. You can't solve it fast. And what happens in practice is because you can't solve it fast, grid operators simplify the problem, they actually linearize it, and they solve an an incorrect version of the problem, which means that you end up wasting power. And it's particularly a problem if you have solar and wind power. You waste even more power. So if you want to reduce power wastage, you want to solve this problem exactly. But it's hard to do. You might think, why don't I just throw a neural network at it? And this doesn't work, naively. Basically because you would be trading off between optimizing for lower power consumption and satisfying the physics of the power grid. So a naive AI algorithm ends up violating power flow constraints, which means that the entire grid might break, and people die if the grid breaks. So nobody would ever use a standard AI algorithm in this case because it runs the risk of violating the constraints of the engineered system. So we designed a way that makes it possible to satisfy the engineering of the system, to not violate physics. And this uses a technique called implicit differentiation to backpropagate through these constraints. This is for the computer scientists in the room. The upshot is that this solves this problem orders of magnitude faster than traditional methods without violating constraints. So it's safe to use on a power grid, and it's orders of magnitude faster. Again, it's orders of magnitude faster not just than AI algorithms. It's orders of magnitude faster than the algorithms that are used to solve this problem, not using AI. So if we're talking about like computational power, this is saving computational power significantly. Okay, so we've seen a bunch of different examples here. And what I want you to take away from this is that AI can be designed for problem-specific goals. Oftentimes, there is the perception that to innovate in AI, we need to build bigger, more general systems. And don't get me wrong, sometimes that's useful. But there's really a frontier in AI for application-driven innovation, for taking new AI breakthroughs in directions that are needed by users to meet to the challenges of real-world tasks, to meet application-specific evaluation metrics. Like, instead of just considering accuracy, maybe you also consider, did it violate physics? Or how computationally costly is this? Not necessarily from an energy consumption perspective, but also from a user perspective. Like, the user might want something that's more scalable. But this depends upon the particular setting. And then to solve these problems, you also have to build in domain knowledge. You have to integrate whatever knowledge you have of the particular problem. Oftentimes, these really big AI algorithms, they work less well because they're not actually taking into account the structure of remote sensing data or something like that. Because they're trying to have a one-size-fits-all approach. And oftentimes, a one-size-fits-all approach means that you don't fit any of the problems. Or at least you don't fit them really well. So, and then the final way in which I want to beat this question over the head with lots of different counter-arguments. The final thing I want to say is, this is a mischaracterization of trade-offs, also because it's really not just energy use that's making climate change worse. If you think about all the different ways that AI is affecting the climate, it's not just like AI has positive applications and uses a lot of energy. AI is also strongly affecting the climate in negative ways, in addition to positive ones. AI is used in fossil fuel exploration and extraction to give up to a 5% production boost, estimated $500 billion in additional profit for the industry already. AI is hugely changing consumption patterns because basically all online advertising relies on AI now. And this is not always linked to increased consumption, but it is in areas like fast fashion. Fashion is the third biggest contributor to climate change after construction and agriculture. And fast fashion is driven by online advertising. It's driven by AI. And then there are these really complicated effects. Like, people talk about self-driving cars a lot as a sort of flagship application of AI. They're probably going to make climate change worse. And the reason is because it's expected that self-driving cars will lead people to drive more by reducing the barrier to driving. Now, it is true that a self-driving car drives slightly more efficiently than a person, so it uses less energy. That is counteracted by making it easier for people to drive. Rebound effect, an example of a rebound effect. But it's interesting here to consider that the same technology can be used in different ways. Like, you can use self-driving technology for buses or for trucks, and that can have different implications for climate change. So I basically want to leave you with here the point that it matters how you develop a particular technology. There are lots of different ways to do that. And I'm not trying to say we shouldn't be building self-driving cars. But I am trying to say we should think about all applications of AI when we think about sustainability and climate. We should think about that as one factor in what we incentivize, because if we are technologists, we're choosing what we build and how we deploy those technologies. We're choosing whether to use self-driving technology for cars or for buses. If we're policymakers, we're choosing what to incentivize with governmental incentive structures. Don't ban uses of AI in the oil and gas industry, but maybe if we're incentivizing AI development, we could consider high-risk technologies. They could, in the EU AI Act, have included high risk from the perspective of environmental costs. I would love to see that. I would love to see a way that environmental costs for an AI system are being captured as one of the things that you can use to assess how good that AI system is, how much we want to prioritize it. Because all applications of AI can be shaped with climate change in mind. And not just by making the algorithms smaller, by thinking about how we're using those algorithms. So, takeaways. High computation, AI, is sometimes useful, but in climate-relevant applications, and really across societally beneficial applications, it's only useful sometimes. If we're thinking about our menagerie of different AI algorithms, we don't always want to be using the big generative AI systems from an impact perspective, as well as from an energy perspective. AI can be designed for problem-specific goals. That's very much for the computer scientists in the room. If we are building new AI systems, we don't just want to build general-purpose systems. Those can be useful sometimes. But thinking in terms of designing for user needs, it actually leads to a lot of interesting innovations in AI, as well as a lot of impactful innovations. And then finally, all applications of AI can be thought of with climate change in mind. AI for good isn't just about adding new good applications. If you're interested in more resources on this, I would point you to all the resources that we have at Climate Change AI. We have reports designed for the policy audience as well as for the research audience, and ways to connect with an international community of folks at this intersection of AI and climate change, coming from lots of different fields and lots of different sectors and perspectives. We also have events. The next one will be coming up for a more AI academic audience at the International Conference on Learning Representations, ICLEAR, in Singapore in a couple of months. We have pretty regular events bringing together different parts of the community, and you can stay tuned with developments via our website and newsletter. Thank you very much, and I look forward to a couple of questions.
So thank you very much. So we have time for some questions. Here, on the first row, we have a question.
Hi, thank you very much for your talk. I pretty agree with you, what you said, and my biggest question is, do we really need the elephants at some point? Are they useful to develop the small bees or birds, maybe something in between? Or we can just concentrate on the bees?
It's definitely true that a lot of the elephants are white elephants. They are maybe the point at which we're devoting trillions of dollars as a society to building something without being fully sure of why we're building it. I think that maybe it behooves us to think about, do we need as much of these elephants? There are definitely situations where you want elephants. And again, not to push the metaphor too much. But I think that there's a problem when we think about generative AI tools, in that people confuse solving a problem with presenting the solution. And I think this is the big reason why people are using generative AI tools or turning to generative AI tools. It's because if you put something on a plate in a really nicely presented way, that is useful, but it's not the same as making the thing that you're presenting. And I think that people sometimes confuse like optimizing an electrical grid, which is a computational problem and requires specialized tools, with presenting that information in a way that is user-friendly. And if you want a chatbot, you want it to present something to you in a user-friendly way, but you don't want it to solve the problem because it's not designed to solve the problem. And fundamentally, I think we need to think hard as a society. We need like smart AI tools that can solve problems, and that's not the same as AI tools that can present those solutions to us in a user-friendly way. So yes, there are some uses of large-scale generative AI, but I think that they are very much on the presentation side and on the content parsing side, not on the side of actually solving the critical problems. From a technical perspective, that's not what they're designed to do.
Thank you very much.
There's another question, I think, 2 seats down.
I had a very similar question, but I don't think you answered that question. So I'll ask it again, which
Please.
is, so the elephants are good at coding. No, okay, but
No. They can be useful tools in coding.
So are they therefore not? And I'm not saying that I thought your argument was very good, but if we want to make lots and lots of bees, like millions of bees all around the world, local applications, etc., we need lots and lots of people who are able to develop those bees, and they can be supported by the large language models.
So using a bee doesn't mean that you need to develop it yourself, right? Like in the case of that Presto algorithm, we built the bee so that the public agencies didn't have to, and they can use it for their specific needs. It's not really a situation where everyone builds their own algorithm. I'm certainly not suggesting that. I'm more suggesting that instead of designing a GPT for power grids, you design something else for power grids. And sure, there are ways in which adapting code is something that generative AI algorithms can be useful in doing. But I would caution against anybody doing that who doesn't already know how to code. Anybody who's used a Copilot tool knows that the kinds of subtle errors that come up can only be dealt with by somebody who already knows some amount of coding. And it's like, you know, it's like any other translation system. You shouldn't trust it with something that's mission critical. And with code, you can get a lot of subtle errors that you don't really recognize. So again, I would say the answer to this is teach more people how to code and let them use Copilot tools as one form of assistive technology. But I don't think that that is the answer either. There's a question, if we have time for it, a couple of rows up.
So one more, last question.
Oh.
Thank you very much. Do you think that a solution to reduce consumption of LLMs will be to make like a hub in which the user input the question and then there is a bee that will be answering?
Yeah, that's actually that's a really promising area where you can sort of get directed to a particular solver based upon what you need. Right now, we don't have tools that are being designed to do that, but I would love to have generative AI tools be used as what they properly are, interfaces. They're interfaces, they're not fundamentally problem solvers. And if they are interfaces to bees, that would alleviate a lot of my concerns. It would also mean that you have to use them less, right? Because fundamentally, they're being used to do their job and not being used in a million other places as well.
Okay, so I'm afraid I will use my privilege of being chair to ask you a question. Oh. One more question, last question, okay. You know, as a dyslexic person, I'm very happy to use LLM to help me to write.
Cool.
But I know they are very inefficient. But I think they are very efficient partly because of the hardware we are using now to run them. Or LLMs they are using a very efficient hardware. So what is your view over the evolution of hardware? Are we expecting some breakthrough or improvement that may help to solve the problem?
So I'm not a hardware expert. I would I would pass that question maybe along to Sasha to talk about it in her talk. But I think that I think that the bulk of the savings is going to come from thinking about what kinds of algorithms we want to use where and what are the best tools for the job. In situations where we do want LLMs to be helping with writing, which is, they're very useful tools in certain cases, I think that there are ways to make algorithms more effective, efficient, and hardware more efficient. But again, I wouldn't look to that as being the primary savings, because most of the savings, I think, comes from having fewer elephants, not from making the elephants smaller. Or, yeah, you know, I don't know what the metaphor, how the metaphor works with hardware. Sasha, I'll hand it over to you.
Thank you very much.
Thank you.
Thank you again. Okay, but before Sasha, we have Anne Noé. Anne Noé is a full professor of computer science at the Vrije University in Brussels, where she heads the AI lab. Her main research interest is reinforcement learning, so including multi-agent reinforcement learning and multi-criteria reinforcement learning. She strongly believes in the interplay between theory and application. So her team developed novel algorithms which were tested in domains such as smart grid communication networks, mechatronics, and scheduling problems. So Anne, the floor is yours.
Okay, so also very happy to be here and to be able to maybe put a bit of sustainable AI in a historical perspective. So I thought of taking a different angle, and then maybe also explain you where maybe these bees can come from, or why these bees have been a bit disappeared a bit over time, and I think I agree with the previous speaker fully that we need more of these bees. But let me first start with some history of AI, because I still think it's important to then explain where the techniques came from, and maybe also why they got a bit forgotten and we should bring them back. So actually we also saw this mentioned in the keynote, opening keynote of this event. So this is a fragment from a proposal that was sent in '56 to organize actually a kind of summer school. And that was the first time where the term AI was more formalized, and then later on it has been used. But what you can see is it was studying whether indeed intelligence could in principle be made, described so precise that it could be executed by a machine. So here you have to think about some formalism like logic, because we are in '56. Yeah? Another important statement you see there is in order to, and to allow to improve themselves. So there was also already a notion of learning included, but I will come back to that as well. Another important part of this statement was that the initial focus was on problems reserved for humans. So you can translate this into problems for which you have to study, like medicine or repairing a car, things like this. So you can just learn this from experience, or mathematics. That is something that is taught to you, that we give this knowledge from generation to generation. It's not just by looking at data, and that would not be so efficient. Maybe also interesting to mention, typically McCartney and Minsky, or like most well-known people in AI, and less associated with AI, is Claude Shannon, because we know him from information theory, but it's no coincidence that one of the large language models is actually called Claude. But I will not go into that connection here in this talk. But he did play also an important role in large language models. So how did people think back then to AI? The idea was, we have some problem in the real world. We want to map it into a representation that can be understood by a computer. We can do inference, we can come to new conclusions, and then map back these conclusions to the real world. And it's no surprise, or it was no coincidence that the first successes were like in board games, because like chess, because if you have a situation of a board game, it's easy to translate the situation of the board game into some representation that can then be processed by a machine. So there is no doubt how the board looks like, and there's no discussion on this. We can encode it, and after this encoding, we can think about what are all the possible next moves. That's also easy to describe and to deal with in a computer. And then this typically leads to what we call a search tree. And a search tree is really something fundamental if you think about AI problems. So it basically gives you all the possible moves you can do. Of course, it doesn't tell you which move is a good one. That's where the AI comes in. That's why the search, how the search comes in. And there's different ways to deal with this. We can do heuristic search, or we can even use reinforcement learning to learn us what is a good way to search in this tree for the next move we should play. But once we decided on this move, we can link it back and execute it in the real world. Sorry, and this is a surprisingly very general paradigm. So I already mentioned like medicine. Well, we can also model knowledge of medicine into something like a search tree. So if you come and see a doctor, you tell the doctor which symptoms you have, what is your problem, and then the doctor will actually search in this big search tree for what possibly causes the problem, but also how your problem can be treated. So here you see a very small part of such a search tree, and actually what you see on the slide is one of the most famous textbook expert systems called MyThing. So it is based on rules like this. So these rules encode knowledge of medical doctors. And by connecting the different rules where one antecedent becomes a conclusion of the other one, you actually get such a search tree. Also important is that you see the number 0.4, because not everything in medicine is, unlike the chess game, is something which holds for sure. There's also some uncertainty that we can deal with. So these reasoning methods also took these uncertainties into account. And then the rules were also translated into a more human understandable format. This is still syntactic sugar, and that also connects to the previous talk, but I will come back to that a bit later. So you can argue, of course, for a computer scientist, we can as well read the rule in a kind of Lisp-like style, but there's a kind of translation that we can do to make it more human readable, and this is what you see below. So this is all about human knowledge. But we can also deal with mathematics in the same way. So my next example is an example from a system built by Tom Mitchell already in the 80s. And today we are surprised that DeepSeek can solve mathematical problems. Well, already in the 80s, we had systems to help us with mathematical problems. And they actually were dealt with in the same way as I was showing here in this micing example, so with this medical expertise, because if you have to solve an integral, an indefinite integral in this case, well, you can apply a number of operators. Here you see 7 of them. There's, of course, more. And the challenge is to apply them in the right order. So it's also kind of searching in a search tree, and a more skilled person will know when to apply which rule, or to give it a higher priority of being applied first, because probably it will lead faster to the solution. Yeah? So for example, the second rule is integration by parts. And, well, if you're still into solving integrals, you will know there's typical situations when you have a cosine or a sinus in your formula, and that it's typical candidate to apply to solve your integral. But you also see learning by experimentation, acquiring, refinement, problem-solving heuristics. So also at that time, people were thinking about, okay, how can we apply machine learning techniques? And in this case, it were what is called version spaces, so a very symbolic approach to learn when to apply which rule, or at least to give it a higher priority, a higher success rate, that it would be the good one to apply next. Today, we also hear a lot about using reinforcement learning, and together with LLMs to train LLMs, and that was also in DeepSeek used. But again, this is not a new concept. So this is, for example, a paper in '97 where reinforcement learning was used to learn how to use this search tree in a more efficient way, which steps to rewrite your integral would be more likely to lead you faster to the solution. Similar to what we have today, using reinforcement learning in such a context is actually, let's say, rather efficient because the reward is well defined. You either solve the integral or you don't solve it, so it's a very binary feedback signal that is given to the system, and that allows, of course, to learn efficiently. We cannot always do that, but if you have a very clear reward signal, it, of course, helps for the training. And that brings me to the very dominant approach of the 80s, which was called expert systems. So there you see the rule base to the right top corner. So the rule base was fed by expertise from the expert. Very often there was also a support tool that allow you to talk to the expert and translate it into a set of rules. There was also tools that could help you in this. Then the inference engine, this is how you traverse basically the search tree. And it turns out that people are using different prototypical strategies. So in the past, we were talking about forward chaining, backward chaining, blackboard systems, that were examples of typical reasoning methods if you want to solve such a problem. And this was also encoded in these inference engines. Also very important is explainable system. So there's a lot of complaints that AI systems cannot explain themselves. Well, in expert systems at that time, you could not deploy an expert system if it would not have such an interface to explain its reasoning. And that was basically the chain of rules that were being applied, sometimes also reasons why, and then confidence levels, and so on. So these systems were not hallucinating. If the confidence was getting too low, it would just say, I cannot solve your problem. And then the user-friendly interface, and that connects also to the previous talk. I was mentioning, and there was a kind of syntactic sugar that was used at the time. So the interface looked like natural language-like, but of course it was not a very advanced way of communicating with the system. As a user, you still had to know quite well which format you could use. And here, these LLMs, but then small ones for a specific domain could be useful. Yeah? In the black box, you also see what was called an expert system shell. So there were standard architectures in which you could feed the rules, and then you had your expert system for a specific domain. A bit later, because getting information or knowledge from an expert can be rather tedious. It is an effort you have to do. There was this second generation of expert systems, and that was already allowing machine learning to come in the sense that if you would present a case to an expert system and the conclusion would be, I don't know how to solve the problem, you could enter extra rules, or it could also learn new rules or generalize from existing rules. So I mentioned repairing a car, so if you would have a problem with the right light in your car at front or the left one, well, your car is symmetrical or mainly, it wouldn't matter whether it's left or right, so you could generalize the rules, things like this. So people were gradually including machine learning, but mainly symbolic ways of doing machine learning. And this is a bit movements we have seen in AI. I don't claim these are exact figures, it's just to give you an impression. So we see a very big dominance of symbolic AI up till the 80s, where the neural networks, the simple, shallow neural networks became more successful. These are still the small bees from the previous talk. And then you see another interesting thing happening, and this is the gray zone that is coming in, statistical techniques, statistical machine learning, and yeah, something like support vector machines, for example, Bayesian networks. And some colleagues would argue, especially like for support vector machines, yeah, is this really AI? I would say, yeah, it's still if we take the broader definition of AI and we include machine learning, then I think it definitely has its place. And it's also no coincidence that suddenly this wave occurred because it coincides with more and more data becoming available. Yeah? So we actually saw a shift from doing more effort in modeling knowledge to extracting insights in the data. You could call it knowledge, but you can also call it patterns. So this has actually led to very important discussions. So within the field, there has always been a tendency between, let's say, the two big camps, so the symbolic and the sub-symbolic people, and actually in a big AI conference, AAAI, in '88, there has been legendary discussions in the community about what is the best way to go. Now, if we bring it to sustainability, which is the topic, of course, of this session, well, if it comes to energy consumption, we have already seen quite some plots. They're all different, but the main trend is the larger the models, the more energy they consume. So we have the elephants to the right and the bees to the left, if I can use the analogy of the previous speaker. But if it comes to human effort, yeah, then it looks different. Yeah? If you build an expert system or a more knowledge-based system, well, you have to get to this knowledge. There's more interaction that you need with the experts. So it is more knowledge intensive than the pure data-driven approach. But I would always recommend you, if you just get data and you don't know what the data is about, then it's not a good practice. So if I'm invited to, for example, a company to help them with a potential machine learning problem, I want to discuss the data. I want to see how the data is currently used to better understand the data, because that makes me much more in a better position to decide how or which algorithm I should apply. If it comes to human interaction, then in the past we had mainly syntactic sugar kind of interactions with the systems, and now we have this big end-to-end LLMs. So the experience you have in terms of conversation is, of course, increased with these LLMs. But that doesn't mean that we cannot use small LLMs to interact and to solve or to improve the syntactic sugar situation we had in the past. If it comes to validation, we can get, again, another picture. It swaps again. Expert systems or knowledge-based systems more in general, and they apply formal reasoning. And they can generate explanations, so you can get justifications for the conclusions that are being drawn. So I would say they're better compared to LLMs or other big neural networks that we have today, where we mainly have to rely on experimental validation. Of course, what we can also do is and to take the output of a big, deep neural network and to synthesize it into a smaller model of which we can maybe prove something. That's also research that is being done. We, for example, did research on using deep reinforcement learning techniques, where we then distill the policy into a more discretized model. Also the environment in which the reinforcement learner was trained is synthesized together simultaneously to be able to do formal verification of the policy that was being generated by the deep reinforcement learner. But if you just look at the deep thing itself, then you can only rely on experimental validation. And then the scope, was also already mentioned in the previous talk. The more knowledge-intensive systems typically have a smaller scope, and the other systems or more general purpose, like these LLMs that we have today. So it seems that we have to choose somewhere. But the good news is that we can also combine different of these algorithms, different of these paradigms, to solve sub-problems. And then we come to what is called today hybrid AI. But again, this is not new. There's a whole tradition, actually, in hybrid AI. So it's not something we just find out now. And to show this is, for example, a picture of Dagstuhl, neurosymbolic learning and reasoning. And so that's like 10 years ago. And there's a whole research community working on these combinations of symbolic representations and reasoning. And then, for example, small neural networks to ground a concept. But even that is not that new. Then I like to show a picture of a fuzzy system. Fuzzy sets were actually born or invented in '65, so already a long time ago. And they were actually already examples of these neural fuzzy or neurosymbolic systems, where we had a symbolic layer that helped for interpretability. And also these fuzzy sets were grounded and the grounding problem is a real problem in AI, but that was done in a very elegant way, if you ask me, in fuzzy set theory. And here you see an example of something like a fuzzy control scheme, but there was other domains to which we could apply this. So we don't need to choose either doing big LLMs and bigger models or smaller models. We can also combine different paradigms into a hybrid solution. Yeah? And it also helps to reuse components. And that's something we should also try to do, especially if we care about the planet. And I also want to conclude, maybe I have some a little bit more time, yeah, with one example. So, because AI is often associated with like something that can predict, but there's a whole community also within AI, and that is looking at multi-agent systems. Yesterday, we also heard the connection with economics. Well, actually, multi-agent systems are strongly linked to concepts of economics and game theory. And this is just one example of a project that we have done a long time ago. So now it's more about, I'm switching here to the viewpoint of how can AI also help to reduce energy consumption. So this is a project we have done about 10 years ago, because in Belgium we thought the incentives for people to install solar panels was really mismanaged. So it was creating all kinds of undesirable side effects. So we thought about, okay, what could be a good incentive mechanism to incentivize people to install solar panels, to trade energy, but at the same time not take the risk of overloading the grid, because that leads again to other problems. So the idea was to come up with a mechanism where a prosumer, so somebody who has solar panels, is being rewarded for green energy that is fed in the grid, but only when it was useful energy. So that means when it was being used within the local community. Because if you think about smart grids, it's a very local thing. So typically you have something, at least in Belgium, something like 60 to 120 houses connected through one, what is called DSO. So this is like one community. So prosumers were only rewarded for useful green energy, meaning that the energy was being used locally. If you don't have solar panels, well, then you can buy this green energy, and that was through a kind of virtual coin, which we called energy coin. Yeah? So you can only buy green energy with energy coins when green energy is available. Yeah? But that gave the right incentives for people to only put green energy on the grid when it is expected to be used by consumers, and consumers would also shift their consuming patterns to when the energy is being available. This energy coin is something that was traded for euros on a global market, and this is how the different local markets could be connected to make sure that the prices of green energy were equal amongst the different communities. We did then also simulations, so that's in a nutshell and the main properties of the incentive mechanism. And what we then also did is to, how can we now validate this incentive mechanism? And then we did multi-agent simulations. So that means that we are simulating prototypical households. So you can get prototypical households by looking at the real data and doing a kind of clustering, and then to compose all kinds of possible communities and see how well the incentive mechanism was performing. We compared it to, that's the chart you see on the left-hand side, we compared it to other trading mechanisms, and we saw that it was much more efficient in terms of energy trading. And what you see at the right-hand side is, of course, you have to run simulations in a diverse set of possible situations, meaning you can have communities with, where fewer people have solar panels, fewer houses, or where more houses have solar panels. And that's what you see on this chart. So we simulated this whole spectrum from only consumers to only producers. What we also saw is that it has a long-term incentive. So if you would be a house in a community where there's fewer solar panels, and that would be also an incentive to install solar panels on your roof, if anyhow possible, because there's still room for trading the green energy. So this was a mix of multi-agent simulation, machine learning, so for example, cluster profiles, using reinforcement learning with the idea that people would start to optimize their energy consumption. So that was a system that was using very different paradigms to actually come to a global solution, and with the idea that it also helps environment because it deals with green energy in a more efficient way. And I will stop with this example, and I'm happy to take questions.
Thank you very much, Anne. So do we have any question related? So we have a question here. First row.
Hello, thank you very much for the presentation. You talk about these, if I understand correctly, during your presentation, you mentioned that many things that we now consider to be the next thing in AI aren't in fact that new and have been done for decades now, but we make as if they're a new thing. And I think to that point, sometimes I get the idea that some of my, for example, my fellow classmates, I'm in an engineering school, they jump onto these new things in AI like LLMs and transformers, and they don't, neither them nor I do actually know what came before. And it sometimes feel like we've, when I look at what was done before, we don't really have that knowledge, or that historic knowledge of what was done in AI before. And so my question to that is, it's a bit specific. So do you think that in order to maybe help students who want to learn AI, to have that historical background, we should learn stuff that was done before? Like, for example, should we give classes to students, give Lisp classes to students? For example, should now students who want to learn AI learn Lisp? Because I do think that it's kind of a lost language, right? If I talk to most of my classmates, I'm not even sure most of them know what Lisp is. Yeah. They all think it's Python or something else. So do you think that it should be taught?
Yes, I think definitely it should be taught. Of course, I don't mean that we should only stick to old good AI, as it is sometimes called. But we have to revisit these algorithms. And knowing the history, I think it's in any discipline something that is very important. So I'm now teaching in the Bachelor AI, Roots of AI, with the idea of teaching this very where are the seeds planted? So I mentioned Claude Shannon. He had a paper in '84, which is very relevant for understanding how can we get these performant LLMs by just doing a next word prediction. So I think it's an eye-opener, and knowing the history of a discipline is always a good thing, to my opinion.
Thank you very much.
Thank you. Do we have any more other question? The audience? So maybe, thank you very much, Anne, again. And so now, last but not least, I call our last speaker for the session, Sasha Luccioni. So Sasha is a leading scientist at the nexus of artificial intelligence, ethics, and sustainability, with a PhD in artificial intelligence, a decade of research and industry expertise. She is a climate lead at Hugging Face, a founding member of Climate Change AI, and a board member of Women in Machine Learning. So Sasha is passionate about catalyzing impactful change, organizing events, and serving as a mentor to underrepresented minorities within the AI community.
Thank you.
So this year you were recognized by Time magazine, 100 most influential people in AI and by Business Insider on the 2024 AI Power List.
Yes, 2024 was the year of lists for me. Thank you very much.
Okay, go ahead.
So I know you're all pretty much looking forward to lunch at this point, so I will try to keep it brief. And also, I'm very much appreciating the order of speakers today, because Thomas started it very down to earth, and then I think that we have been increasingly broadening the scope and broadening the reflection and the critique and in terms of history. And well, I'm going to broaden it even more and talk about ethics and sustainability and why they're connected. So I think we're going to go to get a bird's eye view of the whole space together. So just as an introduction, I mean, some of the work you've heard today, but other work you've heard in previous academic conferences, maybe you've heard some AI ethics work. Typically, ethics and sustainability don't really cross paths. Essentially, ethical principles, fairness, bias, things like that, don't talk about environmental impacts. They typically focus on, figuring out whether facial recognition is racist or sexist. And conversely, work around AI's carbon footprint estimation, like my own, I totally put myself in this bucket, doesn't talk about justice, doesn't talk about equality, doesn't talk about who can afford to train large language models. We tend to talk about how much energy they use and how many carbon emissions they emit. So these are really two separate communities with different conferences, different journals, and via my work at Hugging Face, I've realized that there's actually a lot of overlap between the two, and it's worth considering them together. And so the main thesis of my presentation that I'll keep revisiting all along is that we need to make a more deliberate connection between AI ethics and sustainability, so that if we're studying ethics, ethical ramifications, we need to also think about impacts on the environment. So I'll start also with the Sustainable Development Goals that Ricardo talked about. And essentially, as he said, sustainable development, I mean, formally speaking, it was defined in the Brundtland Report. This particular definition comes from the Brundtland Report in 1987 that talks about development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So this is really like the core definition of sustainability. And then we have the UN SDGs that were inspired by this definition, and the SDGs have inspired AI for good work. So it's really interesting if you trace it back, you can really go back this idea of sustainability in the SDGs. And in terms of sustainable development work, there's different kinds of factors that are talked about, different kinds of threads of the communication. So there's green AI, frugal AI. It's really funny, here more in France, they talk about frugal AI. It's not a thing in North America, as far as I know. There's efficient AI, AI for climate, computational sustainability, lots of people working at different sides of the problem, different issues that they're trying to tackle, right? And there's no single forum. Also, what's interesting is that people who are working on kind of hardware optimization, like the question that came up recently, tend to not go to climate change AI events, because it's not the same kind of group of people, it's not the same forums, and this is actually why conferences, summits like this one are so important, because you have people who are stepping out of their comfort zone a little bit and meeting people from policy, from academia, right, and talking about transversal topics. And in any case, this work tends to talk about things like very specific aspects, right? Carbon footprint estimation, energy efficiency, optimization. But how that fits together into a puzzle is kind of overlooked. It's not something that people typically talk about. And so in terms of the research that exists, essentially the first paper that came out on AI and carbon footprint estimation was Strubel et al. In 2019. It became kind of the first flag planted in the ground about how many tons of carbon are emitted when training a large language model. So they estimated that with a full neural architecture search, so essentially a full exploration of the different possibilities of how the language model is set up, so not just the training, but really like the whole experimentation, they estimated 626,000 pounds of CO2. And since then, other people like myself, like the bottom table is from a paper I did in 2023, we've been working to get more information, to get more nuance, to get more analyses of different aspects of the architecture and the training procedure. But we haven't talked about things like who are large language models benefiting? Who are the people training them? Who are the people using them, right? And how the carbon footprint of this field of specifically, especially in large language models, it's text, right? How that's been rising with regards to computer vision, which has been rising probably less significantly. So essentially, this has been kind of like the discussion in my circles anyway. And last year I decided, actually no, 2 years ago, 2023, I decided to broaden the scope a bit because someone came up to me and they're like, well, you guys keep focusing on this tiny little bit of the problem, but what about the life cycle? What about the life cycle of AI? And that really kept me up at night because I was like, well, what do you mean life cycle of AI? Because if you talk about life cycle of a pair of jeans or a t-shirt, then you can really do cradle to the grave, right? How the cotton is picked, how the threads are made, how the cotton fabric is woven, then you have the actual manufacturing process, et cetera, then the wear, then the disposal. Like it's more concrete, but how about a life cycle of an AI model? And so essentially we tried to do this in the paper about the Bloom large language model, and for some of the steps, we just don't have any numbers. So what is the end of life of an AI model, right? That's more of a metaphysical question, maybe to philosopher friends, but we focused on equipment manufacturing, model training, and model deployment. And that was already 2 steps beyond what most studies focused on before, which was mostly only training. And what we found is that if we consider these other steps, we can estimate that the carbon footprint of Bloom, the model we were looking at, actually doubled. So any kind of numbers that we had before, the ones I showed you on the previous plot, could probably be multiplied by 2 if we look at life cycle analysis. But of course, even this life cycle analysis, cradle to the grave perspective, it doesn't recognize ethics. It doesn't recognize inequalities and in the field of AI. So for example, as I said, where the models are coming from. And also, as David mentioned, the indirect effects, right? What if you train a model very efficiently and then you use it to do oil and gas exploration? How do you compare those 2 things? Which brings me to my main point here about connecting the dots between AI ethics and sustainability. And I want to start with a quote from an iconic paper, came out in 2021, and if you haven't read it, you should. It's called Stochastic Parrots, and it was about large language models, and it was really the first paper that opened the eyes of many in the AI community about the fact that, yes, these models have huge promise, huge benefits, but also come with big risks. And so a quote from this paper that I like to cite, is it fair that the residents of the Maldives, likely to be underwater by 2100, or the 800,000 people in Sudan affected by drastic floods, pay the environmental price of training and deploying ever larger English language models, even when similar large-scale models aren't being produced for Tibetan or Sudanese Arabic? And this really begs the question, right? Who is benefiting from the technologies? Who is paying the price? What's the planetary price? And what's the social price? And I would like to add that how do we even know the extent of these broader impacts unless we're evaluating them, and unless we're holistically evaluating them and transparently communicating them? Which brings me to my 4 dots that I'd like to talk about today. Representativity, evaluation, transparency, and equity. So essentially in the conversations I've been having with my colleagues at Hugging Face, with colleagues at at conferences, I feel like these are themes that keep coming up, and people sometimes use different words for them, but it's actually like something that sometimes you're having a conversation and you're like, well, we just talked about this, a couple of days ago, but in a completely different context. So let's start. Oh yeah, and I haven't come up with these myself. Lots of critical scholars have already came up with these in the past. So starting with representativity, what's interesting when you think to the origins of AI up to the 50s, 1956, AI really functions on the basis that data is representative, right? You take a data set and you want to solve a task, you're like, this data represents the task that I want to solve. It represents the reality of the context. And there's this myth, I call it a myth, of generalizability. So if you get as much data as possible from the internet and without consent, you can use that data to train a model that will be general purpose, that will be a general purpose technology. And the more data you have, the higher your chances are of creating truly general purpose foundation models, right? And this myth persists. And actually, when you think about it, and this came to me when I was listening to a talk about AI bias, when we talk about bias, we talk about the fact that the model is making flawed assumptions about the reality of the world based on flawed data, on data that doesn't generalize to the world. So for example, there's a really iconic ProPublica report about the fact that AI is used in the criminal justice system in the US, and essentially that race is disproportionately used in order to predict essentially the potential for future criminality. And so if a white prisoner and a black prisoner have very similar backgrounds, but they have different racial characteristics, the black prisoner will be penalized. And so this week talk about AI bias, right? But essentially when you think about it, it's because in reality, it's not because someone is black that they have higher chances of committing a crime, right? And this comes down to representativity. And so when we think about the data used for training AI models, there's a couple of iconic data sets that come to mind. David mentioned one of them, ImageNet. And actually the size of data has been growing sharply. As Anne mentioned before, and I still remember this, when you had to solve a problem, you would actually look at your data, right? You would come and you would do data analysis, and it would take a couple of weeks or even a month, and that was fine, and that was part of the process. Well, nowadays we talk about data sets that are too large to document. And because we're talking about terabytes of data, both during the creation of the data set and after the fact. So we don't even know what's in these data sets. And the bottom plot is from a paper I wrote with Gaël Barroco and Meredith Whitaker, and we plotted essentially training data sizes of popular data sets used for training AI models, and nowadays they're bigger than the amount of people on the planet at this point. And essentially, what does this data represent? And so essentially there's been research that's shown that neither image nor text data sets are actually representative, whatever you want that to mean, but they represent a select set of communities and of populations. And so for example, there's some really great work about text corpora. So there's a documentation article about C4, which is a common text corpus, and that showed that essentially it has so much stuff in there that you wouldn't want to have in data sets, but it also has a lot of copyrighted content, a lot of adult content, et cetera, et cetera. So this is what we're putting in our language models. David and I did a study about ImageNet, which is shown on top, and what we showed was that in the categories of ImageNet, which is this really iconic image data set that's used for training AI models, training and evaluating AI models, what we showed is that when we consulted with experts in biology, that some of the categories were up to 98% incorrect because they were created by people who didn't know what a black-footed ferret was, right? And essentially, these are the data sets that are considered perfect and gold standard and been used for 10 years or more in order to train and deploy AI models. And so this whole idea of data and representativity is flawed at the basis, because what is even a representative data set of all possible contexts, right? And then when it comes to representativity, you have to think about evaluation. And what are you evaluating? And David alluded to this as well. He said, essentially, if we're only measuring accuracy, then we're ignoring all sorts of other components that are really important, different metrics that are important. And I mean, this can be summed up as you can't improve what you can't measure. And I truly believe in this. And yet, the main leaderboards that are used in AI in order to track progress, like papers with code, only focus on accuracy or F1 score or precision, but they don't talk about other criteria. And we're not even tracking these other criteria. All we have are these crescendo data points that, oh yeah, models are getting better, right? But what are the data what's the data that we're using for evaluating these models, and how are they getting better? Because, for example, if the 2% improvement in accuracy on ImageNet has come at a cost of 1 million hours of GPU compute, right? Like, what are we plotting over time? Are we plotting the true costs or just the perceived benefits? And so there's all sorts of real-world constraints. And when you talk to people who are using AI in the real world, they're like, you can't just put a Llama 400 billion parameter model in production, even if you think or know that it's the best model, because there are real-world constraints. Things like efficiency, of course, and money, because you have to pay for compute. Things like robustness, right? How well does your model do with regards to real-world data? Because, of course, you know, if you have a chatbot that's talking to people in real life, the data is not going to be like the data that you use to evaluate your model initially. You have things like fairness, right? That comes back to the equation. And the data quality as well. Like, often if you want to deploy something in production, you have to make sure that the data that was used to train the model is similar to the data that is going to come. But if you don't have access to that data, how do you make that comparison? And so essentially there are all these criteria, all these metrics that we're not even tracking at this point. And so in terms of efficiency particularly, I'm presenting a project that I've been working on for the last year around energy score ratings for AI models. And so the goal here, I think Energy Score in the US is called Energy Star, but the idea is to do evaluating efficiency and ranking and comparing energy consumption for different models for the same set of tasks, essentially. So as David said, you know, there's bees and there's elephants, but it doesn't make sense to compare a model that's doing, I don't know, molecular modeling with a model that is doing image generation, right? And so once you define some tasks, you can also compare models in terms of energy efficiency and rank them in a relative way. Not saying, well, a bee is more efficient than an elephant, but just saying, well, this elephant is a little bit, this cheetah is a little bit faster than this elephant. The metaphor is going to stay, David, I think. So anyway, so essentially this project, hopefully, I'm not saying that we have all the right data sets and all the right tasks, because of course, if you're doing object detection on a self-driving car, then it makes sense to define a benchmark for that car, the hardware that it has, and the task that it's doing. But at least you can start talking about energy consumption as part of the discussion and not only performance. And in terms of transparency, actually, Anne said it really well. Current modern AI systems are not inherently transparent and interpretable. It's actually pretty shocking when you think about it, because these models that are so complex that you can't even, like, if you want to talk to like a non-specialist and describe how they work, like really nuts and bolts how a transformer makes a prediction or generates a token, that's like really, really difficult. And then when they say, well, how do we like pinpoint where something went wrong, you can't do that. You can't do like meaningful, you know, reverse engineering, right? And so this is really an issue, especially as we see these systems going off into the real world. And so as well, and I've worked a lot with folks working on reproducibility. So we actually organized a machine learning reproducibility challenge for a couple of years running. And essentially what we asked people to do is take a published paper, take something that was accepted to ICLR in Europe's ICML and try to reproduce it, try to replicate the results. And in something like over 90% of the cases, they couldn't. There was not enough details in scientific publications in order to replicate results. And even if the code was available and the data was available and, you know, all the details were available, there was always something missing, a random seed, or, you know, some optimization parameter that the authors failed to mention, because we're not good as a community of communicating about our research to each other. And so it's actually pretty wild if you think about it, because that means that how do we really meaningfully build upon each other's research if we can't even replicate it, if we can't even validate these findings? And so essentially in terms of scientificality, the fact of the matter is that we're relying on things that are not made to be interpretable, that not made to be replicable, and that, you know, if you build a house with a shaky foundation, then the rest of the house can also break. And if you talk about sustainability, something that, you know, I kind of tell myself, or I truly believe this actually, is that if we can replicate each other's work, it comes with a sustainability benefit, so we don't have to keep reproducing the same things, right? And part of the reason why I came to work at Hugging Face when I had offers from other places was I truly believe that, you know, a hub for sharing AI models has a sustainability benefit because, you know, you don't have to start from scratch. You can adapt models that already exist. And so for me, like the hippie in me was like, reduce, reuse, recycle, and then essentially went to work at Hugging Face. And so I think that transparency, the more information we give, the more scientifically you know, replicable our work is, then also comes with benefits for sustainability. And so, for example, in AI ethics, now we have data sheets and model cards, which are both used to understand models and data sets, what they're useful for, how they were trained, et cetera, et cetera. And what's interesting is that until I came to Hugging Face, carbon footprint estimation was not part of model cards because it wasn't considered an ethical thing. It wasn't considered like, you know, fairness and bias and whatnot and data sourcing because it wasn't the same category of people. So we added that category to the model cards, for example, but there's still so few data points. Like last time I checked, I think we have like 1 million models or something, and a couple, like dozen have carbon footprint estimation in their model cards. So, you know, despite the fact that I added this 3 years ago, we still haven't seen added transparency in terms of model cards. And now the final point I want to make is about equity. It's really interesting when you think about it. Like I still remember a time where you can train a model on your laptop on, you know, not even like just a CPU and you know, compete, right? You could compete with state-of-the-art models, for example, at natural language processing conferences, at AI conferences. You didn't need access to compute. You didn't need access to GPUs. And nowadays, that's becoming harder and harder. And so that really comes with an equity angle because modern AI research and practice, the cost in terms of computer hardware is growing, which people have showed, and that means that, you know, the percentage of people who can afford that cost is shrinking. And not only hardware costs, not only electricity or GPUs, but also human costs, right? How do you pay, and how much does an average AI engineer in San Francisco earn? Well, more than, you know, somebody with I don't know, somebody in Cairo or in I don't know, Malaysia can pay, right? Because the concentration of wealth is also becoming quite apparent. And also the digital divide in AI is increasing. Like when you talk to people from the UN, they talk about digital divide as something that has been present for decades now. Like with this, the plot, for example, the figure is how many cell phones per 100 people populations have. And so, for example, North America, Europe, et cetera, have almost 100 cell phones for 100 people. But that number goes down as you go to continents like Africa and Asia. And, you know, okay, cell phones are not necessarily proxy for AI, but it helps to have some kind of device when you want to talk to ChatGPT, right? And so the digital divide in AI is also growing. And for example, if you want the latest and greatest, you need the newest cell phone. If you want Apple Intelligence, you need iPhone 16 and plus, right? That means that this is creating a gap with people who can afford that and people who can't. And so, and yet when we talk about AI systems, we don't talk about justice and power. We don't talk about benefit, right? We talk about, for example, fairness, representativity, or carbon footprint. And so going back to this paper we wrote with Gael and Meredith about bigger isn't always better. And it was this really fun paper to read because in terms of money, in terms of environmental cost, in terms of ethics, they're all actually linked. And we showed this by the fact that the financial capital required to participate in cutting-edge, state-of-the-art AI research is increasing significantly. Now it's becoming more and more expensive just to practice AI. Because of GPUs, because of the time required, and also the cost of inference as well is rising because these models are more expensive. And it was really interesting because I've never thought about this before, but Meredith brought it up because she said, well, you know, who's providing this like AI-specific compute, GPUs, right? Like Microsoft, Google, and who's training the big AI models that apparently are the good ones? Microsoft, Google, et cetera, right? And so it's like kind of like, if you convince people that the biggest model is the best model, then they also get more money from deploying that model and people using that model. And so that's something I had never thought about before. And I was like, yeah, it's true that, you know, if you say that the 400 billion parameter model is better than the 12 billion parameter model, then people are going to pay more to use it. And so there's really this question of money and affordance that's very closely linked to sustainability. And so we see these market concentration, we see it in GPUs, for example, that are getting more and more expensive. So that's also an issue that has links between ethics and sustainability. And we're starting to see this a little bit in headlines. So for example, Taiwan had a drought a couple of years ago, and essentially the government stopped farmers from planting crops in order to use that water for fabs, for making microprocessors, GPUs, and other chips in Taiwan. And so, you know, it was really a question of, okay, we only have water for one of the two, so they went with profit. We're having CEOs of big tech companies saying that AI depends on an energy breakthrough, but where that breakthrough is going to come from and when it's going to come. In the meantime, the energy is mostly non-renewable, and that's kind of a given while we wait for this energy breakthrough to arrive. And also rare earth elements. If this is something that interests you, there's a book about cobalt. Cobalt blue, I think it's called, red. And it's about how cobalt, the metal that's used for so many of our devices, is mined. And child labor, modern day slavery, it's all part of it. And yet we continue upgrading to the latest devices. So as a conclusion, there's multiple facets of AI technologies that have to be taken into consideration, and the more I talk to people in this field, the more I realize that it does help to have multiple perspectives. And also for me, now you can't have an ethical conversation, a conversation around AI ethics without talking about sustainability, and vice versa. You can't talk about rising environmental costs without thinking about the ethical implications. And so integrating the two is not only beneficial, but really necessary if you want to continue the conversation. And what's interesting is at the same time as the Brundtland report came out, there was also Edward Barbier, who proposed 3 pillars for sustainable development that people talk about a lot less, actually, than the Brundtland report: environmental stewardship, social equity, and environmental viability. So his proposal was that you can't be sustainable unless you have all 3. And so even if you're great for the planet, but you can't maximize social equity, well, then you're not sustainable, overly broadly speaking. And so for me, I think that if we center the discussion around these 3 pillars, we can also take into account capitalism, because sadly we live in a capitalistic society, but also sustainability and also social equity without trying to optimize for one or the other. Thank you.
So thank you very much for this presentation.
We don't need to do questions if I think people are hungry. People can just come see me.
But we have a last address
yes, exactly.
Before we leave now.
If you have questions, you can come see me at lunch.
So I have a question regarding hardware.
Yes, the hardware question.
That's the hardware question.
I didn't talk about this. I will talk about this during my keynote at 1:30. But I think that what we're seeing right now is somewhat of a Jevons paradox. Essentially, hardware is becoming more efficient, but we're using it more. And so essentially, it's something that we've seen with electricity, something we've seen with coal, for example. Just the fact that we can use something more efficiently doesn't mean that the overall impacts go down. And actually, strangely, they're going up. So hopefully you'll watch my talk at 1:30.
Okay, thank you very much. So now I leave the floor to Juliette Fropier on the behalf of the Minister of Ecological Transition. We'll make a final comment and address.
Hi everyone, I'll be super quick because I know you all want to go to lunch. I just wanted to conclude by making a link between research and public policy. So my name is Juliette Fropier, I'm the AI lead at the French Ministry of Environment. And I want to end this great presentation by all the great researchers that you saw today by reminding what is our end goal here and the end game with these presentations. So we want to act in the public interest of our society, and the IPCC researchers have all told us that for this we need to ensure an inclusive ecological transition. And well, this is the end game. AI is not the end game. It's not why we're here today. It's really ecological transition, but AI is the tool, because achieving the ecological transition is not an easy task, and we need all the tools that are at our disposal. So in all sectors, we can see that AI can help us optimize our resources and get a better knowledge of the climate change. And the researchers before me have shown how it can be used for the SDGs, for the Sustainable Development Goals. In France, we believe that using AI for the ecological transition has to be done on the ground with local authorities, and we have funded 12 projects with local authorities to really use AI for optimizing their resources, their reduced water leakages, or optimize the energy consumption of the public buildings. But we also talked about the necessity, yes, to have a better knowledge of all the resource and energy consumption of AI, because we need to make sure that the cost-benefit analysis is positive here. Thomas Le Goff, in his presentation, talked about electric cars. We had to do some work in the beginning about electric cars to make sure that it was really going in the right way for the ecological transition. For AI, it's the same. We need the data and we need the science to make sure that the cost-benefit analysis of AI is going to be positive. So for wider adoption, we need the facts, we need the science, and we need the transparency. And I'm also going to make a quick link with the 2 days of the AI Action Summit that are going to take place on the 10th and the 11th, where all the leaders are going to meet, CEOs, heads of governments, and heads of states. And it's a great thing that for the first time, the environmental sustainability of AI will be a key topic of this AI Action Summit, with announcements that will be made. And we hope that this AI Action Summit will be a stepping stone for increased international collaboration on the environmental sustainability of AI. I'm not going to be any longer. Thank you very much to all the researchers, and I leave the floor to the next address.
One, two, perfect. That was me. I'd like to welcome up on stage now the French Minister responsible for higher education and research, Philippe Baptiste. Welcome.
Thank you very much. Honorable guests, esteemed researchers, ladies and gentlemen, dear friends, I'm very pleased and honored to be here with you today for the second and unfortunately the last day of the scientific days of the Summit for Action on Artificial Intelligence. I am very pleased to be here. As some of you might know, I used to be a researcher in computer science, and I used to teach in this same room some decade ago, and I'm very happy to come back here in this place. You still have an afternoon ahead of you to explore, in particular, the impact of AI on our shared world, and I have no doubt that you will make the most of it. It's a privilege to stand before such a distinguished gathering of minds, united by a shared ambition to shape the future of AI. When I look at the program of these 2 scientific days, when I see the extraordinary concentration of expertise gathered here, I cannot help but feel excited. When I see you all, I'm certain of it, we will rise together the challenge of artificial intelligence. I speak of a challenge, and indeed, it's one. AI is a revolution, one that really inspires both fear of the unknown and tremendous hope for the future. I'm not telling you anything new when I say that the stakes are huge. You are just as aware as I am of the colossal investments being made in AI infrastructure by both public and private actors. The scale of investment has skyrocketed. Not long ago, AI funding was counted in millions. Today, we are talking about tens of billions. And this exponential growth highlights not only the promise of AI, but also the urgency of ensuring that research remains at the forefront, guiding this technological revolution. And I am not only referring to what Alphabet, Meta, or Microsoft invest in a single year. At the other end of the economic chain, AI-related stock values are also skyrocketing, with markets following trends so complex that even AI itself, I'm not sure, can really understand, the rationale behind it. But AI represents an immense economic challenge. And above all, I believe that AI really is a research challenge. It's no coincidence that these scientific days open the Summit for Action on Artificial Intelligence. It's a clear signal that research is essential in this field. I'm not saying this simply because in the face of the vast sum involved, it might seem easier to return to the fundamental research. I say it really because I'm convinced of it, because the long history of AI, from its origin in the 50s with Alan Turing and the Dartmouth workshop to ChatGPT today and DeepSeek, it really shows us that at the heart, at the very core of AI, we do have research. And we are not, at the end of the day, we are not only optimizing current systems. I mean, there are new breakthroughs that are really underway, that are being done today in your research labs. And it's very, very important to invest today in research. Buying vast computing power is important, but it will not be enough. We must continue research efforts across all areas of AI. Learning models, such of course as reinforcement learning, which still remains too slow. Agent-based AI, which will be crucial for robotics and raise profound questions about security, system robustness, and trust. Continuous learning, which is essential for developing dynamic application. Cybersecurity, a crucial challenge for states, businesses, and individuals alike, where AI is both a source of new solutions and also of unprecedented risks. And finally, let me mention AI efficiency. It's a key issue if we are to develop AI while reducing the consumption of resources that we know are finite. And finally, AI reliability, which confronts us to the mysteries of AI as a black box. And this has, this means that we need to really work on explainability, understanding the rationale behind, and things like that, which are very complex. In all these areas and many others, research, especially fundamental research, has a vital role to play. And sometimes, often, I believe solutions will emerge from places we least expect. It's typical for research. This is why we must maintain our commitment to an ambitious AI research. AI is an extraordinary, almost limitless field of research, and you are all the proof of that. But if we must tackle the AI revolution, it's also because doing so is absolutely essential to remain at the forefront in other scientific domains. This is what AI for science really means. As you well know, AI acts now as an accelerator of scientific discovery in many, many fields. Do I have to remind you that at the last Nobel Prize ceremony, AI was everywhere, far beyond its traditional role in mathematics. Let me mention a couple of applications. In healthcare, its impact is undeniable. This past Tuesday, February the 4th, marked World Cancer Day, and I can tell you that researchers, for example, at Gustave Roussy Institute, a global leader in cancer research, are increasingly relying on AI, and their progress is making real-life difference for patients. In biology, protein structure prediction is a major breakthrough, enhancing our understanding of biological process and leading to better diagnostic and treatments. In chemistry, AI is driving discoveries of new materials and molecules. In climate science, AI plays an increasing role in predicting and understanding the impact of climate change, and by coupling traditional numerical models with learning. In astronomy, and some of you might know my deep attachment to space science, AI helps identifying key elements within the vast noise of the cosmos. And finally, AI is even transforming fields we do not immediately associate with it. In fact, AI is not only reshaping science, it's redefining what is possible today. Just this week, a papyrus scroll burned during the eruption of the Mount Vesuvius 2,000 years ago was deciphered thanks to a combination of X-rays and AI-driven analysis. It's just an amazing and incredible moment. Please forgive me, I will just take another example. Well, which is perhaps a very French example, but let me take, for example, the Notre-Dame de Paris example. If you have not visited Notre-Dame yet, as rebuilt, well, it's not too far away from here, and I strongly advise you to take a couple of hours to do that. Notre-Dame's restoration was an extraordinary collective effort, and the result is magnificent. But for us researchers, it was perhaps above all an unprecedented scientific endeavor, and AI was again everywhere. Vision language models have helped to identify architectural elements to enable an identical reconstruction. If I take a step further away from the so-called hard science, in archival research, conversational AI really helps scholars in navigating vast amount of historical data. In archaeology, AI has improved geospatial analysis, helping in the identification of excavation sites. These are just few examples, but they point to an undeniable reality. Today, I believe it's nearly impossible to maintain a competitive edge in global research without embracing artificial intelligence. And this is a two-way dynamic. AI models have also much to gain from other science through their amazing amount of data and their methodologies. From this exchange, I'm pretty certain that discoveries of tomorrow will emerge very, very soon. This exchange of knowledge is made possible thanks to institutions and structures. We are gathered here today at École Polytechnique on the Saclay Plateau, an institution that embodies French scientific excellence. We are gathered in France, which is becoming for a few days, if you allow me to say so, the center of the world as far as AI is concerned. And I want to say again, welcome, and come back anytime. Come here to work, to research, to collaborate, and to stay. To conduct fundamental AI research, to foster the dialogue between AI and other science, to contribute also to the transfer of AI-based technologies. This summit is not only a beginning, it's not an end. It's a one step in our AI journey, a journey you are all invited to take part in. France is not just a place to study AI, it's also a place, I believe, to shape the future. We have tremendous assets in the global AI competition, and allow me to list a few of them. We have world-class researchers working every day in France, many of whom are here today, a very strong mathematical expertise, research infrastructures that are sometimes the envy of our international peers, supercomputers available specifically for research like Jean Zay and soon Alice Rocoq, two large supercomputers. And last night, our President of the French Republic, Emmanuel Macron, announced the creation of a dedicated artificial intelligence campus with between 30 and 50 billion euros in funding in partnership with the United Arab Emirates. A huge data center will be built and will house the most powerful computing capabilities in Europe. We are proud and excited to host such a groundbreaking facility. And speaking about big announcements, I am also very excited to announce that a partnership will be signed in a few minutes between École Polytechnique on one side and the Mohammed bin Zayed University of AI in the prospect of establishing a collaborative research and training program in artificial intelligence. This program will include the development and the advancement of AI methods, tools, and training, for example, in foundation models. These are just two milestones on France's journey in AI. We are fully committed to AI research within Europe for years, and we have structured our strengths around 9 AI clusters. Some of those you may have seen in the hallways of École Polytechnique. I just spent a couple of hours with the researchers there, and it was really amazing work that I saw. And École Polytechnique, of course, is a member of one of these 9 clusters. Their work of these 9 clusters really spans among post-generative AI, natural language processing, economic and societal challenge, medicine, education, and AI efficiency. And the results speak for themselves. In just the past year, our AI clusters have gathered more than 80 European Research Council grants. Isabelle Ril, I'm sure she's in the room, of the AI Prairie cluster, was named among the 100 people shaping AI in Europe. A startup co-founded by Stéphanie Alassonnière, deputy director of Prairie, was acquired for 85 million. And the commitment from business is there. 360 million in public funding has now been matched and surpassed by private sector contribution. You can really count on my personal dedication, but the dedication of all the Ministry of Higher Education and Research to ensure that France remains attractive, competitive, and welcoming for top researchers around the world. By funding new excellence chair in AI, we are building an environment where top researchers can thrive. Together, they will strengthen our universities, they will strengthen our schools and training programs, while also welcoming back French talents, of course, to be part of this exciting journey. We can and we will go even further for you and with you. You can count on my commitment and you can count on France on that. AI is an incredible adventure and it is just the beginning. I can't wait to see what we will build together. And I want to thank you very much for all the work that you have been doing during these 2 days. And please enjoy the rest of the event. And bon appétit. I think we are close to the time for lunch. Thank you very much. And have a good seminar. Thank you.
Ok, parfait. Ok, sinon.
is an actual, theory is an actual observation that happens when small initial changes in complex systems can result in significantly different and often unpredictable outcomes in the broader landscape over time. So this is really interesting if you think about it, and it's been observed in everything from meteorology, so the flap of a butterfly wings and the hurricane, but also physics and biology. So this is definitely something that happens in complex systems, right? And society is a complex system, and a lot of AI models can be considered as complex systems as they interact, as they fit within existing tools, within existing paradigms in our society. And this is why I think that thinking about the butterfly effects of AI can be a good way of thinking about how small changes, how small ways in which we implement, we deploy our systems can have far-reaching impacts in society. And so my field of study particularly is AI and the environment, and anecdotally, so I started out, I did a PhD in AI. This was kind of slightly before the big deep learning revolution, and I went to work in applied AI, and I spent a couple of years working on really interesting problems, and with a lot less compute, might I add. One of my favorite things that I worked on was, for example, chatbots that you could talk to in your car that would reply to questions about the manual, like how do I change the oil, how do I, what side is the fuel tank on, and they were running on tiny chips, and we were doing really cool stuff. And then at some point, I had what I call my quarter life crisis, and I decided to take those AI skills and apply them in the fight against climate change. And so since then, so I quit my job. I actually was working in finance. I was working at Morgan Stanley at the time, so I diverged a little bit. And then I went to work with Joshua Bengio, who's the next keynote speaker, in AI and the environment. And so thinking about AI's butterfly effects on the environment, the fact that these systems are so interconnected, right, that even when you're talking about AI to people who don't necessarily know the field really well, it's sometimes even hard to define. It's hard to pinpoint, it's hard to explain what we mean when we talk about AI. And so they're interconnected, they have potentially huge impacts on society, especially when they're deployed in things like health and things like justice, education, right? These puts stress on our rivers, and we know that fresh water is limited. Also, rare earth minerals. Once again, for every physical thing that runs an AI model, whether it's a phone, a GPU, a computer, what have you, that needs metal. That needs all sorts of actually different metals. We think about aluminum, but there's all sorts of different, like cobalt and germanium, et cetera, and all of these have to be mined. They have to be transformed, and that has environmental impacts as well, like the amount of earth you have to move in order to get 1 gram of copper, 1 gram of cobalt is actually really significant. Also, we have greenhouse gas emissions. The energy, for example, that has to be generated to power data centers must come from somewhere. Here in France, you are pretty lucky that it's nuclear energy, and so it's low carbon, but in other countries, it's not the case, and especially data centers need a constant supply of energy, so they often will be dependent upon, connected to a grid that will have natural gas, sometimes even coal, that will power these data centers because, renewable, there's no 100%, I mean, especially in the case of AI-specific data centers, like they're called hyperscale data centers, you need so much energy that using only renewable power sources is often unrealistic. There's also the issue of electronic waste. There was recently a really interesting article about how the fact that we keep updating our phones, even our compute clusters, all of our servers, the fact that this is contributing electronic waste, which is actually the fastest growing type of waste globally. And we don't have very good mechanisms for handling it. It often ends up in landfills, et cetera, et cetera. So, the fact that we have to buy a new phone in order to get the latest and greatest of AI technologies contributes to this kind of global issue of e-waste. And it's estimated that it would generate 5 million metric tons by 2030 in the study. And I alluded to this in the previous slide, but oil and gas extraction it becomes more efficient, more good, using AI as well. And so essentially, it improves efficiency, it increases yield, and so there's also the contribution of AI to existing processes that are already kind of harmful to the planet. But it's not all bad. It never is all bad, right? So there are positive effects, and there are true positive effects that can truly help push back and help fight climate change. So, for example, complex, and we were kind of like just losing our enthusiasm, and they were like, no, we're going to get it done. We're going to get it done by January 2025. So finally we did. And then that next week, Satya Nadella, so the CEO of Microsoft, tweeted something about Jevons paradox, and our paper essentially came out the next day. So it was very timely, but also took a lot of thought and a lot of kind of systemic approaches to environmental impacts. And so essentially, we tried to think about all the rebound effects that AI can have that aren't covered by what I just presented. And so essentially, things that are material, things that are economic, and things that are social. So these three categories of effects that tend to get overlooked when we're talking about AI's direct environmental impacts. And so both Kate and Emma came with a lot of kind of really interesting ideas about, well, this is something that we don't tend to see as an environmental impact of AI because we see it as just an economic thing or just a social thing. So we're really trying to connect the dots on this. And actually, if you were here for my presentation earlier this morning, I talked about how important it is to consider ethics and sustainability together. And so this is part of that as well. Like when you talk about bias, when you talk about fairness, when you talk about access to technology, well, sustainability and ethics are often linked because they're two sides of the same coin. You know, if a system is so expensive that only a few people can afford access to an AI model, for example, often that comes with like huge amounts of compute and so environmental impacts. And so essentially this paper is also about that. How can societal and economic impacts actually impact the environment as well? So let's start with material rebound effects. And maybe these are the ones that are the most tangible for kind of people when they think about AI or technology in general. So for example, substitution, right? Nowadays, more and more, we're replacing material physical objects by digital ones. And that's really interesting because that means on the one hand, you know, whatever, Netflix has replaced DVDs, right? And so you don't have the material objects anymore, and so you tend to forget that even digital objects have an impact on systems, on the environment, et cetera. So just because we don't have the DVDs, you know, piling up in our living room doesn't mean that there's no impacts to be taken into account. And same thing with AI, that we have AI systems that have partially replaced dictionaries, right? How many performance will be better too, right? That's kind of a core premise of all of this, this is why we're using all of the internet to train language models nowadays, because we think that bigger is better. And also, the fact is that the more information you have synthesized in your model, the theory goes, the more you can access it, right? Like if you train your LLM on the whole internet, then if whatever question you have, you can just ask it to that LLM. You don't need 10 LLMs, you only need one. And so the idea is that, you know, positively speaking, it's supposed to help us access information more quickly. But on the downside, we are seeing these material rebound effects of the fact that we need more compute, more GPUs for a longer time, requires more mineral, uses more energy, and creates more e-waste, right? And so there's a trade-off because on one hand, we suppose that more training, more data, et cetera, will be a positive thing, but it comes at a cost. And also, the energy demands of data centers, as I said, have been rising. And so it's interesting because even in terms of material rebound effects, we're seeing both the positive and the negative, and it's really hard to quantify which one is winning or what's the actual relative cost of each. And now in terms of economic rebound effect, the famous Jevons paradox, which I don't know if you all followed, but like 2 weeks ago, everyone was talking about, like all of Blue Sky and Twitter, everyone was like, oh, Jevons paradox of AI. And so Jevons paradox essentially is considered a direct economic effect, and it says that when you improve the efficiency of one product, instead of its production or its usage decreasing, which makes sense, right, it's going to increase, which is a paradox, because it's strange. If you, for example, Jevons paradox was observed with coal. If you use coal more efficiently, if you can go further and further on the same amount of coal, we should be using less coal. But what Jevons in the 19th century, 1860 I think it was, observed was actually that we're using more coal because we're using, for example, engines to go further. People are traveling more with the coal, and it's kind of it's the Jevons paradox. How is it? And it's been also observed with energy. It's also been observed with fuel efficiency. The fact is that our cars are getting more efficient, but we're going further instead of going, I don't know, to the countryside 50 kilometers away for a weekend, as we would have gone, I don't know, 10, 20, 30 years ago. Now we're going to another city just because we can, because with the same amount of money, you can go further. And so essentially, what we're seeing in AI is that hardware efficiency is objectively improving. The GPU use of data centers is flat. And that's what's been, I guess, kind of the biggest scientific article that's been cited when people talk about data centers. They say, well, look at this report from 2019, as you see at the beginning, it's pretty flat. The growth is flat. Why are we panicking? Well, essentially, the same authors did this new report, and they say, well, yeah, it's flat, but it's rising quickly already. And in the next 3 years, it can rise to 12% of all energy use in the States. And so it's interesting because we do have this trade-off between energy and efficiency, but what at the core of it is transparency. And essentially, we don't have enough numbers to call it either way. We can say that there's a Jevons paradox, but it's hard to prove that there's a Jevons paradox. And now societal rebound effects, they're pretty much the most hard to measure, and the least fungible, let's say, are societal rebound effects. And of course, we use AI every day, right? It's having impacts on our societies, but it's really hard to even measure these impacts because there's no baseline. It's hard to say, well, this has changed something in this way unless you have something to measure. And so, for example, induction effects are a type of indirect impacts in economics. So, for example, if you save some money on one hand, you have that money to spend in another hand. So for example, in terms of targeted advertising in AI. So for example, it's one of the biggest applications of AI is, every time you do a Google search or whatever search, Bing search, you have the ads at the top of your screen. That's targeted advertising based on your query, based on your location, even based on like cookies and things like that describe who you are and what your behavior is on the internet. That's one of the core applications of AI. And so you can say that, yeah, AI has gotten so much more efficient. We have such powerful models, but on the other hand, these models are also selling us things 24/7, right? And something like 30% of Amazon's revenue is based on this like recommendation engine that they have of that's using AI and our purchases and our history. So it's like these effects that the savings that we have with AI in terms of efficiency, et cetera, are how do you compare the induction of targeted advertising? Like, how do you compare apples and giraffes, essentially, right? In this case, it's really hard to measure. There's also time rebound effects. Once again, a very, very hard thing to measure when we have time saved using an innovation.
scenarios or which outcomes will happen, it makes it difficult for policymakers to be certain that they're going to take the right decision. If they try to mitigate the risks and it turns out that those bad things don't happen, it might be seen later as unnecessary. On the other hand, if they wait for stronger evidence, it could leave society unprepared for major risks. So these are hard decisions that are really in the realm of policy. I will just go to the conclusion here. Again, the science is clear. There's a lot of evidence about these risks, those that are happening now, those for which we have clues. We have coming signs, as I outlined. And that means the AI could be extremely useful. It could be very beneficial. In fact, this whole summit is going to be mostly about the benefits. But in order to reap those benefits, we need to understand better those risks, and we need to put the right safeguards, the right mitigations to make sure we benefit from the risks and don't suffer from, we benefit from the AI and not suffer from it. Last thing is, we have agency. Like people who read this kind of thing might be discouraged, but really the future is in our hand, mostly in the hands of what governments will do. And so advising them properly, making sure they listen to the scientific evidence is going to be very important as we move forward. Thank you for your attention. And now I'm going to invite my colleagues on the panel to move on the stage.
Thank you very much, Joshua, and thank you to all of you for your contribution to this International AI Safety Report. It's really structuring the way we are working on this very important topic of trustworthy AI and the public policies that are going to accompany them. And also you are contributing, in your personal position to the world on AI and AI safety. And I think it's very important to have your views, to have your opinion regarding the work that have been done in this international report, and also the way it's going to impact your future research on this area. So first, let's start with a question for you, Joshua. Let's talk about AI capabilities. In your presentation, you were mentioning the progress that had been made in mathematics, for example, in scientific reasoning and programming. And so what do you see as the most striking evolutions in terms of AI capabilities between the interim report and the final version of the report?
Well, I already answered, with reasoning. Although, I must say that it's still hotly debated whether just extending the methods that currently exist is going to be sufficient to get the kind of reasoning that we see in humans, especially the most creative kinds. But we know from other other kinds of AI applications like AlphaGo, that once we introduce reinforcement learning with enough exploration, then sort of creative streaks that go beyond human solutions can emerge. We're not there yet, but in the last few months, because of the push towards more autonomy and agency, I think the move from the pre-training large language models to these agents, which I think we can't really think of them as language models anymore. They're agents, they learn to act and to achieve goals. I think changes the perception we should have of AI as we move forward.
Mm-hmm. Yeah. Thank you very much. And Professor Song, of course, we don't know everything yet, but what is your opinion regarding what we don't know? What are the capabilities we don't know about the most advanced AI model at the moment?
Yeah, that's a very good question. I would say what we know is very little. Actually, there's a lot that we do not know. And I would say in essentially almost every aspect of the AI capabilities, we have huge open questions. I mean, so one, just first in terms of how the capabilities are improved, as Yasha already mentioned. So earlier there was a lot of focus on pre-training, scaling for pre-training, and then more recently there's a scaling on inference time, and also with the recent DeepSeek and so on, now there's also essentially what we have seen is earlier the inference time scaling still like it was expensive, but now there's evidence showing that that also can be done much more cheaply. So that's in one dimension is in terms of how the capabilities are improved. There's a lot that we don't know. And then the other aspect, also Yasha mentions this agentic aspect. I think that's a huge unknown. And I do believe that actually we are moving to the next frontier, which is agents. And actually I'm teaching a MOOC, Massive Open Online course, on large language model agents. We taught it last semester with over 15,000 enrolled. And given its huge success, we actually have a new version this semester called Advanced Large Language Model Agents that actually particularly focus on reasoning, planning, and also coding agents, web agents, and also AI for math and so on. So that's another big unknowns. And then the third one I would say is actually the things that we don't even know that we don't know. So essentially these models, often we call it, like there are these capabilities, like how do we elicit its capabilities? There are a lot that we don't know that these models can do. We right now don't have the right method to elicit these capabilities. And some of these capabilities are dangerous capabilities that we don't even know right now what's the right way or what's the best way to elicit them. And it makes it even harder for us to understand these AI systems capabilities.
Thank you very much for this very interesting answer. And it's very also interesting to see that as we don't know all these AI capabilities at the moment, it also means that we do not have an exhaustive vision of the risk associated with this advanced AI model, right? So I had a question for all of you, anyone that want to answer. What are the so you were mentioning, Joshua, in your presentation, a number of risks. What are the risks that seems to be for you the most striking one, the most important one, and what is the likelihood of this risk and their severity? So, I mean, really, if you had to speak about only one risk, each of you, let's say, what would it be?
Let me get the question in this way. So I think just like the AI for sustainable development, for these 70 pillars from SDGs, if you're successful in 16 dimensions, for the 17th one, you fail, and then you fail for sustainable development. So I think this is also true for AI safety, that we wouldn't choose actually which one is more severe. That I think the way that we need to tackle this problem is something like this. That actually, you see, maybe risks are in different levels, but now AI, now maybe they're with some sort of self-reflexivity now. And then the model themselves, they can do cognitive escalation. You don't know when that the level of cognition are raising for these AI models. And then the AI models the level of risk can also raise in a self-automated way. So choosing one risk is not really rational. So let me say that the most dangerous one after the interim report is that large language model got a very initial sense of a model of self with reflexive thinking. And this is the most dangerous thing that we need to keep track of, because they can do self-automated cognitive escalation, which makes risk assessment at different levels very hard. So I think that is the scientific progress we need to focus on. Yeah.
Hi, well, it's a great pleasure to be here. From my perspective, of course, all the risks are important and interesting, otherwise they wouldn't be in the report. But it is also the case that they have a wide range of probability of occurring or evidence that they exist. So from my perspective, I'm very interested in studying and mitigating the risks that we know 100% that they exist. For example, violations of privacy, for example, biases, because we know that they exist. We know that they're impacting the lives of potentially millions or hundreds of millions of people. And I think it's important, while of course we need to keep an eye on potential speculative risks, but it's important that we don't forget that these risks are there. They are actually certainties, and we need to work on them, and we need to mitigate them. I wanted to make a short comment about the capabilities, which I think is also interesting, and it's a little bit reflected on the report, which is we humans have hundreds of years of work in developing models of human cognition. And therefore, we can determine the capabilities of humans. So if you want to solve a very complex physics problem, you first need to know basic math, because otherwise it would be almost impossible for you to do that, right? But that doesn't necessarily happen with general purpose AI models. So something that is very important for us always to remember is that the fact that they can do very well on some legal test or on some math test doesn't necessarily mean that they have all the necessary capabilities that a human has to be able to do that. And we have numerous examples of how brittle they are. For example, failing on very simple arithmetic operations just because they happen to be rare in the training data. I think there was 42 times 43 for some reason. They were failing on that. Or even giving you different answers depending on how you ask, depending on whether you include random sentences in the prompt that have nothing to do with the question that a human wouldn't be confused about, but they get confused about, or changing the order of the questioning and then providing completely different answers. So these are all behaviors that you would not expect from a human that was able to ace the whatever SAT, but that they do, no? So I think we need to try to unbias ourselves from extrapolating from our own capabilities when we evaluate and try to understand the capabilities of these powerful models, because it's not a one-to-one mapping to human cognition.
Mm-hmm. Okay, yeah, I'll add to this list of risks. And for me, I think, again, there are many different types of risks, but the one that I actually worry about the most currently is the risk in cybersecurity, for a number of reasons. So one, AI as a dual-use technology, it can help both attacker side and on the defender side. So there's a huge question in this case, who will AI help more? And unlike many of the other risks, for example, biorisk and so on, like cybersecurity risks, there are like cybersecurity attacks. There are many different incentives why attackers actually want to launch cyber attacks, all the way from nation states to cybercrime and even to what we call like street kitties, like the amateurs and so on. And with the improvement of AI technologies, it can potentially really significantly reduce the costs of cyber attacks and increase the scale of the cyber attacks and make them much more automated. And today, we are already seeing in certain areas, as Yasha mentioned too, for example, in these like phishing, social engineering type of attacks, already with Gen AI, it has made a huge difference. And we actually have seen, for example, in these financial crimes where you really have, like there is this Hong Kong financial worker that actually was in the teleconference call with his coworkers, and then he was instructed to wire $25 million. And he did, and later on, it was discovered that none of his coworkers were real. They were all actually generated by AI. So, I mean, these are just examples why with the advancement of AI technologies, potentially we can see huge changes. Of course, we want AI to help defenders more as well. There are many challenges, and I think, right, so this is a risk area that we really need to pay huge attention to.
Don was actually talking about, security side. I'm gonna complement by talking about attack and defend from safety side. Actually, many people were building, better attackers and better defenders. But I think from the more scientific point of view, what has to be realized now is that when we gather all the attackers and defenders all together, what has been found is that none of the attackers can actually crack all the defenders, and none of the defenders can actually handle all the attackers. So let's be frank. From a scientific point of view, none of them are good enough to save ourselves. I think this is the state of the art.
So I don't think we get to pick one risk against another, as you said. Somehow, in terms of policy, we need to address all of them. You asked about severity and likelihood. I think this is a very important consideration when you think about different risks. So as Yuria said, there are risks that, the likelihood is 100% because it's already happening and it's measured. There are risks whose severity is much worse. So terrorists using AI in ways that could kill millions of people is clearly a very high severity risk. As you know, there are many people, including myself, who worry that we could lose control to these systems and potentially having these systems trying to take over societies. And that severity is very, very high, but the likelihood is, it's not that it's low, you don't know what it is. Different people have different opinions, you can look at different scenarios. So really to be, how could I say, wise about these, we can't choose one against the other. Now, there's one risk that I didn't talk about, and we didn't talk about here yet, which I think deserves more attention, and that is the concentration of power risk. As we see that, it's taking a lot of capital and talent, and just a couple of countries in the world right now are leading that effort. I think this is a very important danger, which can be, increasing all the other risks. How do we deal with that? I think at the end of the day, it has to be through some kind of meaningful multilateral governance, international coordination, because we don't want a single person, a single corporation, or a single country to have super powerful AI systems that they could use, for their own advantage, or even to make mistakes that they didn't see coming that could cost us all.
Mm-hmm. And we are all participating to this AI Science and Society Days. So Nuria, you are director of the ELIS Alicante. It's the Spanish hub of the ELIS European network. Nuria, what do you think about the areas where we need more research regarding all these topics we have mentioned?
Thank you. So I wanted to completely, first, before answering your question, completely emphasize the last point that Joshua made in terms of the unprecedented accumulation of power in the hands of a few.
And this is just the tip of the iceberg.
I think this is extremely dangerous to happen in any discipline, but particularly in AI, because as we've been talking, it's a transversal discipline that is impacting every sector everywhere. And partly in response to that, we actually, as a grassroots movement, we created ELIS in Europe, which is the European Laboratory for Learning and Intelligent Systems, with the idea of having a distributed scientific network of excellence of the best minds working in AI in Europe in a distributed fashion as a sort of like counterweight to this accumulation of power. In terms of the ELIS unit in Alicante that you asked me about, it has the name of the Institute of Humanity-Centric AI. And it is the response of my personal worry on the fact that there isn't enough independent research, independent of economic and political interests, on the intersection between AI and people, both individually, but also as a society. And that's why I think we need a lot more research on this. It is very difficult to do this research, particularly on the impact side. And I think Sasha's talk is an example where she says we have no numbers because there is no transparency. So it's very, very difficult to do the research, mostly because we are talking about extremely large-scale systems, potentially deployed all over the world, being used by billions of people, and also because the commercial deployments of these systems, of course, are proprietary and they're closed, and it's impossible to really understand what's going on. But this doesn't mean that we shouldn't. And that's why we really need to advocate, and we really need to invest in ways to do research, not only to anticipate, measure, and assess the risks, but also to understand the societal and the environmental impact of these systems. So to me, that should be, if I was the prime minister of a country, or I would definitely focus that as a priority.
So, excellent. So we started talking about the solution, about international collaboration. Professor Song, if we look at risk management and governance of AI, you would say that what are the most promising approaches at the moment, where we are at the moment, what are the most promising approaches?
Yeah, thank you. That's a very good question. So recently we, with a number of leading AI researchers, we actually launched a proposal called a path for science and evidence-based AI policy. And with this proposal, essentially we talk about that AI policy should be science and evidence-based, and we in particular need to prioritize to advance the scientific understanding of AI risks and how we can successfully identify and mitigate them. And Joshua is also a supporter of this proposal as well, and together with many others. And within this proposal, we actually list out 5 priorities. Here, I want to just mention a few in terms of what we think can help in terms of risk management and so on. So this is a combination of science and policy. So on the policy side, we strongly believe that transparency, adverse event monitoring, these are really important to help us to monitor and understand how the AI systems are improving, and also with the dangerous capability monitoring, and also real-world deployment, post-deployment harm, and so on. And another aspect is in terms of really need to advance the scientific understanding of AI risks and how we can mitigate them. And I want to just briefly mention a couple points. So in terms of understanding, as we were already discussing, there are so many, a huge broad spectrum of different types of risks, and we really need to have comprehensive understanding of all these different types of risks, and in particular, we'll propose a framework called marginal risk assessment, that we need to really understand the marginal risk brought by these frontier AI capabilities. And as I mentioned, in particular, as an example, in the space of cybersecurity, for example, we are doing risk assessments analyzing the impact of frontier AI in the landscape of cybersecurity, and we want to actually engage the community and do this as a continuous monitoring and a longitudinal study with the community to better understand the risk in the space. And another aspect, besides understanding, we also want to we need to develop new AI methods to mitigate these risks. So with that, actually, with Joshua and a number of others, we have a new initiative on quantitative AI safety. So how we can bring more rigor, more provable guarantees for safety and security of these AI systems. And part of that, we have a new work, a paper that we just released on actually using AI for formal mathematical reasoning and also for theorem proving, with the goal that we can develop and utilize better of these AI technologies for theorem proving, for program verification, so we can now not just generate code, but actually generate provably secure and correct code, and this can help us build secure systems as well. So all these are examples how we can develop better approaches for risk management.
And if I can add something to this, France is well known for its strength in math and theory, in machine learning in particular, but in other areas. And I think the whole area of safety is one where the traditional trial and error that has worked well for deep learning, as I have been doing for many decades, is not sufficient anymore. Like, we need things like error bounds and other theoretical constructs to make sure we are going to be deploying systems that are going to be safe for the public.
And Joshua, you were mentioning in your presentation the evidence dilemma. How do you see how can we help the policymaker navigate this dilemma?
Well, So there's evidence, I mean, there's a history in science of dealing with dangerous experiments and you know, things like human cloning, for example, or geoengineering. What is happening in many of these areas is that the potential severity of, you know, the bad things that could happen is very high, but at the same time, we don't have good mathematical models or physical models. You know, in the case of the climate, there are lots of things we can predict, but it's right now very difficult to predict what will happen if we introduce all kinds of chemicals in the atmosphere. In the case of AI, it's essentially impossible to predict how the advances will, you know, in AI will happen in coming years or decades. And it's impossible to predict what the policy will be. So there's a lot of uncertainty at the same time as high severity. And when you're faced with such a situation, the logical thing to do is to apply what's called the precautionary principle. So what does it say? It says that we have to be cautious. So one way to think about it is, you know, we're driving in the fog, and maybe it's a mountainous terrain. So, you know, you slow down, you maybe try to improve your technology to see through the fog, right? So this is exactly what Don was talking about. We need to make sure we develop the science so that we can see the risks coming and, you know, slow down when it's necessary, take the left turn when it's necessary. This is what the precautionary principle is telling us. Rather than just racing ahead, accelerating without knowing where we're going, which is just, in my opinion, playing Russian roulette with everyone's life.
And a final question maybe for you, Professor Zhang, and for Nuria. You know that in Europe, we have the AI Act. You know it well, Nuria. And there is always this debate about you know, having regulation in order to have the trustworthy framework for the development and deployment of AI without hindering innovation. How do you see that for this very specific topic of risk managers? How can we do it?
Yeah, I think this is very important to get to know that everybody was talking about, you know, making a balance between development and safety. This is not true. So recently we have a research actually shows that if you tune the large language model to a safety vector space, and then actually you don't need to change much, and the large language model just behave very safely with very low attack success rate, while on the other side keep the accuracy for problem solving. So we'll publish it on ICLR this year. That means safety and development does not drag each other. You don't need to make in many cases, you don't really need to make a balance. You just can develop system that is very advanced, where on the other side, if you tune the large language model with this safety vector, you can keep the system also very safe. So don't be, so as a technologist and a scientist, we cannot cheat actually the general audience, and that if you're not really speaking of AI safety, you speak for AI development. This is not true. You can actually keep AI very safe, or on the other side, to use it in a very beneficial way. I'll have to say that. Well, on the other side, I think let me complement with the effort in our AI safety report for your question. How can you actually make a balance? We haven't talked about, you know, AI safety efforts in different geolocations in this report, but it doesn't mean this is not important. We have another work called the Global Index for AI Safety. We evaluate 40 countries, and then when people see the results, like they say, oh, for these 40 countries, what you said is that the level of AI safety readiness is positive relevant to the economy of this country. And I said, this is not what I said. What I said is this is not right. The AI safety readiness for all the countries has to be put into the same levels, no matter the economy is in which levels. So AI safety counts for each and every of the countries. So this, I'll have to say that. And let me give you a secret, actually, story about our report. But in face of all the audience and also some audience online, it's no longer being a secret now and then. So when we are doing I'm one of the expert advisory panel members for this report. So in one of our advisory meetings, so I was challenging Joshua, like, I think we've been talking about risks for large language models a lot, but we haven't talked about the risks of rule-based reasoning, the risk of brains by the AI. And Joshua was like, oh, that might be because of my own bias, that I'm mostly focusing on language model. And then to me, I was like, that's not a good answer, and I cannot be convinced for that. But when you see the later versions of the report, it says we're going to focus on general purpose AI. And that actually convinced me, because rule-based reasoning, now they're not doing general purpose AI. And for brain-inspired AI, not so much brain-inspired AI system, now actually focus on general purpose AI. But I think this is still something that maybe we can make a change for the next versions, is that there could be unpredictabilities when rule-based reasoning are combined with large language models, with self-reflexive reasoning, that might come to a even more dangerous trying. Save it for the next versions, right?
I just wanted to say that innovation is not regulation is not the enemy of innovation. I think bad regulation might be the enemy of innovation, but not regulation per se. And I think it's also important not to confuse technological development with progress. Not every technological development contributes to progress. And I think the role of regulation is to steer technological development so it actually contributes to progress. And that might be also a societal, there might be a dependency depending on the culture and the societies, right? So the challenge that we have with the AI Act, and Joshua and I are involved now on the writing of the code of practice for general purpose AI models, is how do we make sure that the actual implementation of what the AI Act wants to do is an example of good regulation, so we are actually not hindering innovation, but steering innovation in a direction that we feel is not compromising the fundamental values that are at the core of the European project.
Excellent, thank you.
I think there's something behind your question that I get asked quite a bit, which is the competition between countries, and there's this idea that if we slow down because we want to be cautious, maybe because of thinking that regulation is going to slow us down, then other countries are going to take over. And I think this is a kind of misleading thinking. We do have to take into account that competition. There is competition between corporations and there's competition between countries. But just like we discussed earlier when you asked about risks, there are different kinds of risks. And we can't just pick one, like the malicious use by some other country against us. And that's like every country can be thinking, right? But there are other risks in which we're all in the same boat. And just like we've seen in history before, when humans who are adversaries realize that they're sharing a common objective, we can find solutions, we can write international treaties, we can find ways to verify these treaties. And that is the only way I think that we can get out of these very dangerous competitions.
Can I compliment of what Joshua said? I think, of course, maybe we don't need the world to build a AGI, but we need the world altogether to solve potential catastrophic risk for human beings. This is the global challenge for AI safety. This is for everyone. And I don't believe that only one country can solve the world problems for AI safety, especially when it comes to existential risks. We haven't talked too much about existential risk and how to get prepared. But just bear in mind that maybe we're going to have AGI pretty much very soon, but can you solve the problem for existential risk within 10 years? Maybe not. So later is too late. We'll have to.
So just one quick comment. I think I don't believe that we'll have AGI anytime soon. I think what has happened is that we have changed the definition of AGI.
Yeah.
But if we think that AGI is having the level of intelligence of an actual human being, we are so far away from AGI.
Yeah.
So I disagree with the fact that we are close to AGI. We just changed conveniently the definition to equate AGI to what a general purpose AI model can do.
That's true. General purpose AI is a tool, but it's very different compared to AGI. But still, we need to get prepared for both general purpose AI and also potential high-level unpredictabilities.
Thank you very much to the four of you. Maybe, so we wanted to have a short Q&A session before you go. So is it possible? I mean, it's an excellent opportunity for you all to ask all the questions you have about AI safety to experts in the field. So please do not hesitate. And I think there is a system of a question using the app on smartphone. I don't know if it's working or not, or are we just sharing the microphone? Okay, perfect. Just two questions. So we have one question here. Yeah.
Student, actually.
Okay. Are you sharing the question or? Okay. So we have one question here in the room. I will give my microphone.
So Joshua in particular, the precautionary principle is all very well. You're driving in mountainous terrain and it's foggy and you might fall off a cliff. But that only applies if you're not carrying, say, a transplant heart to a patient who's otherwise going to die. And by abjuring the risk of applying the powerful AI techniques we have, we might be in the situation, right, of exposing ourselves to even more present existential risks. And we know that there are other potential existential risks, or even putting aside existential risks, we are quite likely condemning millions of people to painful and early deaths. So I think the precautionary principle, I think, is a fraught one. In fact, it was used to slow down the use of nuclear power in Germany, for example, which had arguably a quite strong negative impact on climate change. So, is there a balance of risk and benefit that is more difficult to make than perhaps is being expressed here?
So I think these are very good questions and require a careful analysis of the different risks and their severity and likelihood, right? And their timeline. I'm absolutely in favor of accelerating on AI for science. But one thing that people don't realize is that the greatest risks in terms of malicious use, say by terrorists, or loss of human control, they all emerge from agency, like systems that have a lot of autonomy. And all of these scientific advances can be achieved without that. Okay, so what I'm trying to say is things are not simply black and white. We can make choices in the kinds of AIs that we want to push forward so that we can address things like, disease and climate issues and so on, and other scientific advances that we would really like to use AI for. But we don't need to take some of the crazy risks that we are currently engaging in, for which there's much less understanding of the probability of these things happening and the over wide horizon. So I think we can be smart about managing the risks.
Thank you very much. And I will have one more question.
Okay, so hi. I want to repeat one of the concerns that was very amplified in the public when the conversation about AI safety was having, is that we've had the same kind of conversation when the internet bloom was happening. the dangers of cybersecurity, dangers of market monopolization. So where have we failed in mitigating the risks of internet? So we expect not to succeed in mitigating the risks of AI.
Well, that's a great question. I think one problem is that at some point in the 90s, a few governments decided that we should leave software unregulated and just, try it out and see what happens. Sort of, go fast and break things. Well, because of the kinds of risks that we've been documenting in the report, I think we can't afford that. We have to be more cautious. We have to make sure that the actors who create products or systems that harm people, that cause death or loss of property, can be sued, and they will behave better.
Thank you very much. Before we applaud our amazing panelists, just one information: at 4 p.m. In the amphitheater 4, so it's I think it's there. You will have a session that is dedicated to AI evaluators with Apollo Research, Meter, Prismeval, and so on. So if you want to see, an implementation of what we have said today and the tools to characterize these advanced AI models, please do not hesitate to participate to this session. Thanks a lot to the four of you for this amazing panel.
Fantastic, guys. Well done. Well done. Brilliant. Okay, so we are keeping up with time today. Things are going well in terms of that. I'd like to welcome for our next plenary, perhaps I'll give you a couple of minutes for those of you who are moving into another amphitheater. Absolutely, yeah, absolutely. Feel free, feel free. I wanted to... So, for the next plenary here in the Poincaré Amphitheatre, we're going to get started with that. So if you will ask people to just take their seats so that we can get started with our next plenary. We've got a couple more to come today. I'd like to, well, she's already on stage, but I'd like to extend a warm welcome to Danielle Allen, who is a James Bryan Conant University professor at Harvard University, as well as director of Getting Plurality, Research Network, which is focused on emerging technologies, technologies for next generation governance, and all of that is looked at through a lens of plurality and pluralism. Danielle's equally a natural and a national voice on AI and ethics. She's a distinguished author as well as a mum. Danielle, great to have you with us today.
Good afternoon. Oh, thank you. It is such an honor and pleasure to be here with all of you today. And it's also just wonderful to be in France. So I want to say thank you to our hosts for the invitation. I've been thinking a lot about the reconstruction of Notre Dame. And it is such a testament to the humanity of the human. This building, cathedral that was built so long ago through incredible technical excellence in an artisanal fashion, and captured the human spirit. And here, after a great disaster, the resilience of the human spirit has brought it back again completely. And I think as we think about the question of technology and the human, to have the case of Notre Dame in mind and to think about what it means for that incredible artifact to exist over centuries and have a place in human hearts, puts in perspective technology, puts in perspective the question of how the social and the human interact with each other, the technical and the human. So I am going to extend the conversation about AI ethics for my keynote. I'm going to extend beyond safety. Safety is fundamental. As we all know, with automobiles, the innovation opportunities increased after safety became a serious concern. Once brakes were added, cars could go faster, then transport networks could be broader and the like. So it's true that safety and innovation do align with each other. Yet safety is not enough for us to answer the ethical questions that we currently face. We are in a moment of comprehensive socio-political transformation driven by technology, and we need mental models to think about that change. My talk with you this afternoon has the title of A Time to Choose. I think we are at a point where we do have a time to choose with regard to the paradigm for technology development that we put at the center of our work. Before I get to that content, though, let me just introduce myself a little bit more. I'm a combination of a Harvard professor and democracy advocate. I have done a variety of things over time, but when people ask me what I work on, I always give the same answer, just democracy, past, present, and future, with no question mark at the end of that. And I say that coming to you from the United States, okay? There are a lot of us with that deep and persistent commitment. And I also like to share that I come by that commitment to self-government for free and equal citizens super honestly. To start, it's a matter of my basic family inheritance. So on my father's side, my grandfather in the 1940s helped found one of the first chapters in northern Florida of an organization called the NAACP, the National Association for the Advancement of Colored People. And that was an organization that fought for the right to vote, fought in the civil rights movement. When my granddad did that work, it was a super dangerous time. Lynchings in the South were on the rise. So he was literally taking his life into his hands to secure the right to vote. On my mother's side of my family, my great-grandparents helped fight for women's right to vote. So my great-granddad marched on Boston Common, our big public square in Boston in 1917, to make the case for women's right to vote. So from both sides of my family, I come from people who see empowerment as the bedrock for human thriving and well-being. My granddad was willing to put all material concern to the side for the sake of securing the right to vote, believing that humans flourish most when they can steer their own lives in the private sphere and also in the public sphere working together. That's the commitment I bring into my work. That commitment to basic human empowerment has obviously been profoundly challenged in recent decades by the structure of our economy, by how technology is developing, by specific political unfoldings in the United States and elsewhere around the world. But the point that I want to make today is that that project of human empowerment is basic. Human beings are not merely creatures of bread. We don't survive on bread alone. We survive also through respect for dignity, through the respect for that spark in each one of us, which is about our capacity to judge and choose, regardless of the level, regardless of the caliber of our expertise. We all have that. So what are we living through right now with the age of AI, and what ethical questions are on the table for us? What I want to suggest is that right now, we have moved beyond the point of speculation and beyond the point of hypotheticals with regard to thinking about how general purpose AI technologies transform human life. We have also moved beyond the point, as I said, where safety is enough to think about. Because of the general purpose nature of AI technologies, they are, as you know, working their way through every single sector of society, the whole of the economy, the whole of society, the whole of political institutions. We're living through an age that I take to be roughly equivalent to the age of electrification. There's the time before electricity and the time after, the time of the horse and buggy and then the time of the automobile. And that time gave us completely different ways of organizing both the economy and politics in the world. In the wake of the age of electrification, the globe saw an increase in state capacity, the ability of states to set policy to steer the lives of their people. And throughout the course of the 20th century, we had a profound argument between two different paradigms for how states might deploy that capacity. In the wake of the Great Depression, we had the rise of Keynesian approaches to economics, social democratic approaches, where state capacity, public sector dollars were put to work, stimulating economies, building social safety nets, putting an ethic of solidarity at the center of policymaking. Yet, that approach to the muscular deployment of public power also resulted in excessive regulation, a stifling of innovation, stagflation, and the like. And so that Keynesian moment was then followed by what we have come to call the neoliberal period in political economy, where people like Friedrich Hayek and Milton Friedman gave us a different picture of how state capacity should be employed. They made the argument that we should deregulate as much as possible, let price and market steer as much as possible, power innovation to the maximal degree. And we've been living through the last 30 years through an economy around the globe that has shown us the effects of the neoliberal model, with incredible concentrations of wealth inequality and income inequality, especially in the most developed economies. And all around the world, as people pursued that second model, the focus was on the idea that productivity, collective aggregate output would increase well-being, that would lift poverty, lift people out of poverty, generally improve human situations. But the challenge with that model, for all that that was true and global poverty has been reduced, the challenge with that model is that it neglected human dignity. That drive for empowerment that I described by referring to the work of my grandfather. And so all around the world, we've watched as people have risen, people frustrated by the fact that technocratic economic systems have been unresponsive to them. And so we're living in a moment, I'm sure you've heard many people argue this, where liberal democracy is under challenge, where that neoliberal economic paradigm has collapsed, where we're all seeking a new way forward. How are we going to organize human life for the good of all? Now, it's in that context that the world of technology has an exceptional importance. Your field, the field of AI development, the world of engineers, is the world that has put the new paradigms on the table that will shape political institutions and economic institutions and social institutions for the future. And we are currently having a battle about what paradigm will dominate. There are three paradigms, as I see it, currently operative in the world. And right now in the US, we're watching one paradigm do its best to achieve victory through the form of the work that Elon Musk is leading with DOGE, the Department of Governmental Efficiency. But what are the three paradigms? Let me go ahead and name the three paradigms. And then after I do that, I'll say a bit more about the fight that I see unfolding right now. So for starters, there is the paradigm that comes out of the thinking of people like Peter Thiel. And some folks call that the corporate libertarian paradigm for governance. I tend to call it a paradigm that is about the combination of network states and the power of capital. There is a whole body of work and writing and thinking that goes by the name of NRX, thought and ideology. I'm curious, how many of you is that a familiar label, NRX? Is that a handful? All right, so NRX stands for neo-reactionary, and there are a cluster of people in Silicon Valley, Peter Thiel, also Balaji Srinivasan, and others who, fueled by a very powerful libertarianism, a commitment to freedom generally, are of the view that true freedom yields capital success, success in the marketplace, corporate success. That success is driven by natural talent, and those who have achieved it should be freed, left, liberated completely to continue accelerating innovation, driving innovation forward for the sake of discovering what's possible for humanity, and that they can, through building out communities of excellence, connected through technology, at this point often functioning in sort of blockchain communities and the like, develop network states, hollow out state institutions, acquire governance and directive power, and steer the world constantly for the benefit of capital, for unfettering human innovation, for seeing what human beings can do. Okay, so that's one paradigm for a new political economy, one that concentrates capital even further beyond the concentrations that we're currently seeing, and puts political governance in the hands of those who have secured capital through technological innovation for the purpose of further accelerating innovation until old systems collapse. That's model one. That's the model, as I said, that currently lies behind a lot of the choices that Elon Musk is making as he guides the Doge work right now. Model two is the model that we see through Sam Altman and OpenAI. And model two, like model one, puts an emphasis on corporate control and capital control of economy, political institutions, and society. But with a difference. Altman comes out of the world of effective altruism. Now, if I say that, I'm guessing probably more people know that phrase. Can I see hands? How many people know exactly effective altruism? That's a much more familiar model at this point in time. So as you know, Peter Singer is the philosopher who's the original progenitor of the idea of effective altruism. The notion that harms at a distance are equivalent to harms near us. We have a sort of global responsibility for well-being. The work is connected to a utilitarian conception where we can maximize value to society by generating however much wealth we may be able to do, as long as we also then attend to sharing it in an altruistic way with those who are less well off, so that our efforts redound to the benefit of the least advantaged. And on this model, which some people call synthetic technocracy, it's a command control model still. The idea that, for example, with tech development, OpenAI, as you know, resisted the open source approach to AI development, sought to control, is trying to win the race to AGI, and to win the race in order to fuel growth and productivity. And then in Altman's conception that productivity can generate the resources to support universal basic income for all those who are not directly participating in the productivity of the economy. So that one, I think one can think of as the benevolent technocrat model. The focus of the model is entirely on the questions of material well-being with regard to what is made available to non-technologists, those who are not participating. Neither of these developmental models pays much attention to basic human dignity, the basic expectation that every human being has for control over their own lives, agency, autonomy, the ability to steer both in their private lives and to share with others in steering in the public context. There's a third model, too, to put on the table. And this is a model called plurality, called digital democracy. And my guess is that this is one you've heard the least about. Yet there's a powerful model in Taiwan. And so those of you who are aware of how developments have unfolded in Taiwan under the leadership of Audrey Tang, the digital minister of Taiwan for several years, There you have a picture of tech innovation where tech is of the people, for the people, by the people. Or even better to say, by it, of it, and for the people. So that question of what is best for the people as a whole, informed by the voices of the people, with people's direct participation, actually defines the direction of technology development. What has that meant in the case of Taiwan? It has meant that a decentralized hackathon culture, for example, has been central to approaches to technological innovation. It has meant that the government in Taiwan has been reorganized around all kinds of digitally powered participation. There is the wonderful example of the platform Polis that you may know, which is used in moments of conflict and contestation to engage people to share their views and their perspectives on whatever issue has to be decided. But in contrast to the opinion survey that we've known for decades now, the survey that gives people a box list of things to check off what they think about and combines their thoughts, Polis uses natural language processing. People can write whatever they want to write by way of answer. Others can comment and add further language. And then, because of natural language processing, it's possible to surface points of agreement, points of synergy across lines of division in the society that would not have been evident, would not have been visible on the political surface. The tool opens up the solution space for public policy making. And it does so in a way which fosters social cohesion, social connection, and also confirms the dignity and value of ordinary people in shaping the collective intelligence that's going to steer society. So in that model, that small example from Taiwan, you should have heard a lot of basic differences from the first two models. The three models differ on moral dimensions, they differ on political dimensions, they differ on economic dimensions, and they differ on social dimensions. So let me just run through those 4 dimensions and explain how the 3 models differ, and then I will come to the question of what is happening in the United States. So with regard to the moral dimensions, NRX ideology, the ideology behind corporate libertarianism, or I would call it network states in capital governance, that ideology is very explicit in arguing that humanity is essentially about a natural aristocracy. There are the talented and the untalented. The theorists of this movement, including somebody named Curtis Yarvin, draw on Aristotle. They draw on ancient philosophy and Aristotle's ancient theory about natural slavery, that some people simply are meant to be governed by others because of differentials of talent. In other words, there is no commitment to basic human moral equality in that first paradigm, in the paradigm where technological innovators who are endowed with talents beyond others take responsibility for the economy and governance altogether. The whole kit and caboodle steer in the direction of accelerationism, right? That's that moral position. And the effective altruism and synthetic technocracy picture, the Sam Altman picture, there is human moral equality. That is why there's a need to give from wealth to those who are less well off, so that none is unjustly affected by a structure that means the gains accrue more to some than to others. But what's missing with regard to that picture of human moral equality and the effective altruism picture is the whole of what human moral equality is about. It's not about merely that we should be protected with regard to certain basic material needs. Again, human beings, as the whole creatures that we are, seek empowerment. Our dignity requires our participation in the decision-making about our own lives, and that's absent from that second paradigm. It's the third paradigm, the plurality paradigm, or the digital democracy paradigm, that both recognizes human moral equality and recognizes both aspects of that. The need for protection in our rights from governmental interference, but also our rights to participate, as well as the need for integration in the productive economy in support of our material well-being. So that's the difference in the moral dimension. With regard to the political dimension, you've heard it already, the NRX movement seeks, in effect, the takeover of the modern nation-state system, seeks to replace the structure of nation-states with a structure of corporate states. That's the most radical change that we see. And it reflects the fact that in this moment, in contrast to the age of electrification, in the age of electrification, electrification gave states incredible new capacity that made planning possible. Now, in the age of general purpose AI, again, there's an incredible increase of capacity. But differently this time, there's a fight over who is going to own that capacity. Will it be states or will it be corporations? So that's what we're really watching unfold in the US right now, that fight over whether or not states or corporations. States steered by people or corporations steered by capitalists, which is going to own the new capacity that has been produced by general purpose AI. Then you've got, with regard to the second paradigm, what's the political picture there? With Altman, that is a more conventional acceptance of having the new capacities, in fact, stay in the hands of states, but with immense power in the hands of corporation to steer those states. So no attempt to wrest the state from the people, no complete attempt to do that, but certainly a vision of extreme corporate influence on the activities of the state. Now, the third version, you can tell where I'm going already, the plurality digital democracy version, that is a picture of politics which affirms the value of democracy and continues consistently to put state capacity, to put the capacity generated by general purpose AI in the hands of the people. We need more concrete models of that. Taiwan is the best model that we have, but this is really a call to all of us. I said this is a time for choosing, to select that last model and to think about what different tools do we develop if what we're trying to do is to take the capacity that general purpose tools creates and put that capacity in the hands of the people for the sake of steering society in the direction of human flourishing. Right, that's the political dimension. The economic dimension is, you also, I think, have probably heard by now, the first model continues to double down on the accumulation of capital by a rarefied few, and then linking that capital with power, and without much concern for questions of safety net, social services, welfare, or the like. The second model, effective altruism model, continues to marry the capital accumulation strategy with a welfare picture. So in that regard, again, it hangs over more from the mid-20th century paradigms. And the third model focuses on the question of how do we build an economy that integrates everybody in productivity in the first instance. That is about, for example, human complementing AI instead of human replacing AI. How can we expand the kinds of work we human beings can do for each other, with each other, and for human flourishing, not diminish what we do, not shrink it into merely the projects of the capitalist technocrats, all right? So integrating people in the economy by using tools to expand what human beings are able to do by complementing our own distinctive strengths. Now, in the social domain, last point here, again, you should have heard already across the registers, in the first model, the NRX, libertarian corporate model, or network state plus capital control model, there is very little concern for social cohesion. There is, in a sense, an expectation of caste societies, a separation of those who are naturally superior from everybody else. In the effective altruism case, that's also a very segmented and segregated social picture. In the third case, the plurality case, the focus is on the fact that as human societies, pluralism is a benefit to us. Diversity is a benefit to us. When we can generate connections across lines of difference, build bridges, support those with social cohesion, we actually generate more epistemic power for humanity than when we limit the number of people who are making epistemic contributions to innovation. So the plurality model starts by recognizing that human cognition is plural, machine intelligence is plural. There is not one single thing. There is no graven image of intelligence that we simply should be idolatrously replicating. Rather, there is a divine spark in all of us, and that means as well that our intelligence are multiple. They come in different forms. Some are good at this and some at that. And similarly, again, with machines, there too, if we do our work right, we should be inventing a multiplicity of kinds of intelligence in machines, not idolatrously simply replacing one kind of intelligence only. So that plurality conception starts from that picture of human beings, sees the value in that multiplicity, sees the value in social societies, again, having diversity and activating that for the common good, and then recognizes that when we have diversity in society, when we have social heterogeneity, it doesn't automatically yield the good. It can yield tribalism. It can yield war. It can yield oppression and domination. The challenge is always how to take the potential benefit and value of human pluralism and activate it for the sake of the collective flourishing of humanity. So then that question leads to a very different picture of what tech development might be about. How do we build tools that help us, as the social creatures that we are, make the most out of our pluralism? How can we replace algorithms in social media that drive outrage and division with algorithms instead that foster bridge building, that foster collective intelligence, that support the overcoming of divides? I give you that concrete example simply so that you can see that our paradigms of development are a choice. Yes, outrage has been profitable, but positive affect, pro-social affect, is profitable as well. Why have we not been designing for that? Let's understand the blockages, the obstacles, and recognize that another paradigm of development is possible. So what does this all mean now with regard to the case in the US? If I come back to that. So there is an alliance of some sort that is hard for those of us who are just external observers to understand between President Trump and Elon Musk. Neither has exactly the same agenda or exactly the same points of view. But what we do see with the Department of Government Efficiency, which has taken over the US Digital Service, is an effort on the part of Mr. Musk to digitize and deploy the powers of AI throughout the entire operations of the US government. Now, there are any number of problems that simply flow from the challenge of conflicts of interest. Obviously, he's got companies that have contracts with the government. As you know, he runs Starlink, which has more than half of the world's satellites now in orbit, and therefore controls communications infrastructure to a significant degree, including with impacts, for example, on the battlefield between Ukraine and Russia. So there's a set of problems there around conflicts between what Musk has been doing in his own private industry and now what he's doing with the government. But the more important thing to say there is that on one level, he is right, as you all know. We can massively improve how our political institutions work by deploying technologies for the sake of increasing the power of what we're doing with those organizations, for streamlining, for finding efficiencies and the like. All that is true. But the question is, to what end and how do we go about it? Efficiency is actually not the only value we should be pursuing in government. And the point of the structure of pursuing efficiency is, of course, connected to the broad accelerationist paradigm that Musk is working with. What we actually should be using our technological powers to do is to deliver the greatest government of all time. So the new version of democracy, as you know, Churchill, for example, said, democracy is the worst of all forms of government except for all the rest of them. So it continues to be, out of the fact of government in general is never something that can be perfect or ideal, continues, in my view, to be the best available form to support human flourishing. So what then in the 21st century, with the powers of technology we have available, would the greatest government of all time be for us? The goat instead of the doge. We'll have the goat instead of the doge. It would be about openness, accountability, transparency. These are the values we need in our political institutions if we're to restore them to responsiveness to the people. And the lack of responsiveness to the people is a significant driver of the dissatisfaction, alienation, and instability that we are seeing across the world's democracies right now. So we do need the power of new technologies to help us rethink governance, to take governance into the 21st century. But it's critically important that we deploy those powers, I would argue, underneath the digital democracy paradigm, the plurality paradigm, the paradigm that remembers that every human being needs not just material supports, but actual empowerment. It takes both of those things for access to a whole human life. And anything else diminishes. Anything else treats us as if we are creatures who live on bread alone. In the American Revolution, way back in the 18th century, there was a debate, as you know, about slavery, the founding sin of the American nation. And in that debate, there was a moment where, and they were trying to set up their first system of laws, the Articles of Confederation, the delegates at the Continental Congress got into a big debate about whether or not they could talk about property in their new laws. And they couldn't decide the question because people had different views about slavery and different views about enslavement. And then one member among them, Dr. Benjamin Franklin, the innovator of his time, as you know, made actually quite important scientific discoveries around electricity. It wasn't just a trick with a kite. It actually contributed to the development of scientific understanding. And he remarked in the middle of this debate that slaves rather weaken than strengthen the state. And there is therefore some difference between them and sheep. Sheep will never make any insurrections, all right? Sheep will never make any insurrections. Human beings are never just tools and never can be just tools because of that inner need, foundational need for empowerment. And so for all the power of capital and all the control of political institutions that is emerging under the first two paradigms of governance, they are making a fundamental mistake because human beings are not sheep and they can make insurrections. And unless the human need for freedom, dignity, and empowerment is respected, we will have nothing but instability, nothing but conflict over time. So in that regard, right now, yes, it looks like Elon Musk, the richest man in the world, it looks like Sam Altman and OpenAI have done something for humanity that's unparalleled and is attractive because of the degree of power that has accumulated to it. But there is never in any condition as much power as the power of the people. And that means the power of the people is still where we should put our attention. And it's still what we owe our obligation to for those of us who wield the powers of technology. And to act on our responsibility appropriately begins with recognizing the fact of human pluralism, the pluralism of intelligences, the multiplicity of that spark in all of us, which is the hunger for empowerment and not just bread, and considering how can we make tools that best activates that spark, that hunger for empowerment to support human flourishing. Thank you very much.
Thank you, Talia.
I think you'll agree that was an incredibly powerful talk. Very, very powerful talk by you indeed, Danielle, and very clear messages. The need for multiple intelligences when, within the machines that are being built, transparency in political institutions, and of course the need for plurality, why can't I say that today? Pluralism, it's easier, and diversity, and as you say, another paradigm is possible. Thank you so much for that riveting talk. If you'd like to ask Danielle some questions, you can do so just in our roundtable, which will be a little bit later. So not to worry, you will get a chance to speak with Danielle a little bit later on. Time now for a coffee break. We'll be back in for 4 o'clock, shall we say? Short coffee break. I'll see you then. We didn't leave you much time. I wonder if we could just make our way to our seats so that we can kind of keep to the program. We've still got a little bit to get through, a couple of plenaries, and a really interesting round table for you. So if we could gently make our way to our seats, that would be fantastic. All right, so without much further ado, let's delve right into our next plenary. We can welcome Eric Brynjolfsson. He's a professor at the Stanford Institute for Human Centered AI and director of the Stanford Digital Economy Lab. Eric was among, some of you may know, the first researchers to measure productivity contributions of IT and, of course, the role of organization capital, which goes hand in hand. He's also carried out some really pioneering research on the economics of AI, digital commerce, and long tail. And he's also a very seasoned speaker. Many of you will have seen some of his talks in the past. He's penned, perhaps you know also a total of 9 books. One that stands out in particular, The Second Machine Age. So some of you will have read that. And just having a chat with Eric there, and he reminded me that ultimately he started Work Helix, one of his kind of latest projects, if you will, in Silicon Valley. So let's get stuck in, Eric. Welcome up to the stage.
Thank you so much for that kind introduction, and I see some of our investors in Work Helix here in the audience. So I'm delighted to be here. It's very kind of you to invite me to this gathering for For at least a few days, Paris is the center of the AI universe, and it's fun to be here. What I'd like to do today is talk a little bit about how the technology, which is absolutely amazing, is beginning to change the economy. Specifically, I'm going to focus mostly on productivity. We'll talk a little bit about the labor implications as well, and I hope we have more when we do the panel. So I'll talk first about the micro and then the macro implications of productivity. But before I get to that, I'm just going to remind you briefly about some of the technology. I know you've seen a lot of these today, so I only have one slide on the technology, just as a little summary. One of the things that I started some years ago with some colleagues is something called the AI Index. It's a report, very fun, quick read, 530 pages, filled with charts like this one. So if you're interested in keeping up with the latest data, you can go to the AI Index. It's for free on the web. The 2024 edition is out. The 2025 edition will come out in about 2 months. And then we have updates along the way. This particular chart is a good summary one because you see the progress on many different benchmarks. Of course, there are by now hundreds of benchmarks, but there's a pattern there. You can see going back with the first benchmark, ImageNet, on the far left. It seems like it's fairly flat, but at the time it seemed very steep, going from about 70% to over 100% of the accuracy of humans. The dotted line there is a key threshold. That's about how well humans do on those different benchmarks. And you see each of the other benchmarks is improving more and more rapidly, almost as fast as somebody can think of a new benchmark. AI researchers are often able to address it. So we're really in some very unusual times. The reason I put the dotted line there is just to give you a little bit of calibration about how well humans do on those same benchmarks. And as an economist, that's a very interesting number. That's an interesting threshold. It's almost like the boiling point of water. When the temperature crosses that point, then you have a phase change. And in this case, you have a phase change in the economy. When you go from having humans be the best at doing something to having machines be the best at doing something, then if you're an entrepreneur or a manager, you're going to look for ways of switching over from humans to machines in more and more tasks. For now, there's still many tasks, hundreds of thousands of tasks where humans are better, but as you can see, there's more and more where AI and related technologies are beginning to match or even exceed human capabilities. Another report I recently worked on and finished is for the National Academy of Sciences in the United States. Tom Mitchell, who's a professor who founded the machine learning department at Carnegie Mellon, and I co-chaired a committee with a bunch of other experts in economics and computer science and sociology and some business folks. And this one's a little short. It's only 130 pages, but it's focused more on the effect of AI on the future of work. And there are a number of different chapters there, including on productivity, which I'm going to draw on labor, on measurement, and other categories. And one of the things we see is we looked at the way that the jobs are changing. Already you can see some job changes. This particular chart shows how jobs have changed over the past about 60 years. And while technology has eliminated the demand for some jobs, it's also increased the demand for other jobs to create a whole new categories of jobs. And we expect some of that to continue, at least in the immediate future. But let me now dive into some of the data on the micro evidence of productivity. And there have been now an increasing number of studies, and I'm going to talk mostly about one of the ones that I was involved in with Lindsay Raymond and Daniel Lee. We looked at use of LLMs, large language models, to help with a call center. And here's an example of how it worked. A customer would ask a question like you see in the red there, and then the LLM would suggest some different answers to the human, but ultimately the human was in charge. So this LLM was not trying to replace the human, it was augmenting the human. And this is we'll talk more about this, and I heard Danielle saying earlier, using AI to augment humans is often the best way where you get the most value. So the human could take these answers, it could just use them the way they are, the human could modify them, it could completely ignore them and give their own answer. About half the time they use something similar, very similar to what the call center LLM agent was recommending. The human would use something similar. So One of the nice things as a researcher was that we had a natural experiment here. Well, first they did actually a controlled experiment. They had an A/B test where some agents got access to the technology and some didn't, and we used some of that. But then with a much larger sample of over 5,000 agents, they rolled it out and they randomly gave some agents access to it and other agents did not. So you could compare how the agents who had the technology did compared to the other ones. And the results were very quick and easy to see. Here's one of the dozens of charts from the paper. And you can see the red line is the improvement in the technology from the people who had access to the technology. The other line is the slower improvement for people who don't have access to the technology. So you see very quickly, within about 2 or 3 months, people using the LLM were beginning to outperform the people who didn't have it. And within 4 or 5 months, they were doing much better, almost double as well. And we looked at many different KPIs, many different key performance indicators, and they all showed a very similar pattern, whether you looked at how rapidly they handled calls or how many calls were resolved to the satisfaction. Interestingly, you also looked at a set of metrics about how the customers liked it. And we looked at customer satisfaction using Net Promoter Scores. We did sentiment analysis where we looked at the transcripts and we had AI evaluate how happy the customers were, basically looking at how many happy words versus how many angry words there were in the conversations. By all these metrics, customers also liked it better. So it was more productive. It was also better for the customers. Finally, we looked at a third group. We looked at the employees themselves, the agents. And was this a sweatshop? Did they become made to work in ways they didn't like? Actually, just the opposite. The agents also liked the system. So they were less likely to quit, turnover decreased. So all three groups, the stockholders saw better productivity, the customers had better satisfaction and sentiment, the employees had less turnover and were happier. So it was a win across the board, all happening very quickly within just a few months, and the gains were quite substantial. Another way to see the data is that when you can see it was turned on, you could see that the time to handle calls improved quite a bit. And so you see this is a difference in differences model, and you can see there's no question there was an improvement there. This is not one of those ones where you have to do fancy econometrics. It's very simple to see. Sometimes the system broke, though, and bad news for the company, bad news for the agents, but great news for me as an economist, because I got to see what happened when the system suddenly went down. And I was worried here also, I was worried that the agents would become dependent on the system and would forget how to answer questions, and they would lose the knowledge, kind of like when I'm using a GPS. Sometimes I don't remember how I got somewhere because I'm just paying attention to the machine. We did not find that. It's a little bit noisy because we didn't have quite as much data. The system was up a lot more than it was down. But when it was down, I think it's fair to say that you could see that even when the system was not working, the agents who had access to it did better. So this is the agents who had been using the system and suddenly lost access to it. They continued to outperform the agents who didn't have access to the system. So they had learned something. The system was not just a tool for answering the questions, it also turned out to be a tool for teaching them and having them learn the correct answers. And we interviewed the people to understand this better, and what was going on was interesting. Before they had the LLM, the agents would meet with their manager about once per week, and the manager would call them into the office for about 15 minutes, look at the transcript and say, oh, here you could have mentioned this other product, it would have been better for them. Oh, here maybe you shouldn't swear so much, you should be more polite, and go through the transcript and give them some advice. Now that helped a little bit, but you can imagine once a week, 15 minutes, it's fairly sparse. They don't learn that much. With the LLM, the agents were learning continuously. Every time there's a question, they weren't quite sure of the answer, the LLM was giving them, saying, here's a good way to answer that, here's another good way. And they had to think, okay, yeah, that works, this one doesn't work. So it was real-time, on the spot, customized learning that they were doing, and that's why they learned so much faster. Here's what I think was one of the most interesting results. When we broke the system down and we looked at different agents, those who were the most skilled versus those who were the least skilled, those who had been doing very well versus not doing well, there's a very clear monotonic effect there. The bottom 20% had the biggest gains, about 35% improvement. The next group also had big gains, all the way down to the very best. The top 20% it looks like 0. It's not really distinguishable from 0. So the best agents really got no benefit from the system, and the worst agents got the biggest benefit. This is striking because it's very different from what economists have recognized in most of the earlier technologies. For most of the past 20, 30 years, what we've seen is what economists call skill-biased technical change. That is, that the technology has been helping the most skilled workers and not helping the less skilled workers, and it's been helping more educated workers. And as a result, technology has increased wage inequality and income inequality. That's not what we're seeing here. We're seeing the opposite, that the technology is actually helping the less skilled workers more than the more skilled workers. Again, we tried to probe and understand better what was going on. What seems to be going on is that this is a new technology that is able to capture a lot of tacit knowledge in a way that earlier technologies didn't. When I first started writing AI systems in the 1980s, I did it with expert systems, and we wrote rules, and you had to really know exactly what the answer was, and you would write it, code for it, and then the system would spit that back out. With the LLM, it actually learns on its own from many examples of inputs and outputs what the right pattern is. This set of inputs goes to this set of outputs. And the way it learns is it looks at the best answers. And where does it get the best answers from? It gets the best answers from the best agents. So the best agents were training the system disproportionately. And then when the system learned how to give good answers, it was giving them back to all the agents. Well, of course, the best agents were just getting back a lot of the answers they had already implicitly been using. So the best agents didn't get much of a benefit, or really no benefit that we saw. The worst agents, however, they got the biggest benefit. So it turned out to be a real leveler, capturing this tacit knowledge that's all through organizations. I think this is one of the biggest economic benefits of these technologies, of machine learning more broadly, is that it's able to capture a lot of implicit, tacit knowledge that humans previously had not been able to express. David Otter calls this Polanyi's paradox, this idea that all of us know more than we can tell. I know how to ride a bike, but I couldn't write down instructions for you to ride a bike. I know how to tie my shoe. I know how to recognize my mother's face. These are easy for us to do, but they're very hard for us to express. Machine learning overcomes Polanyi's paradox, or at least helps with it, by capturing a lot of tacit knowledge. And this is unlocking trillions and trillions of dollars worth of value that previously we couldn't access. It's a big economic game changer. The final chart I want to show you from this, this study is this chart, a Pareto chart, as you see. If we took all the questions that came up and we look at the most common question there on the far left and the least common questions on the right, you see a power law, a Pareto curve. Some questions are very common. How do I change my password? I'm locked out. How do I turn the system on? Those come up a lot. Other questions are very obscure. This was a tax financial question, and sometimes people would ask a question that had never appeared in the data before. It was the first time we ever saw it. So there's a long tail of unique questions. Now, machine learning works, as I just said, by looking at all the data and learning from it. Which questions do you think machine learning is going to be better at? Well, of course, it's going to be better at questions that there's a lot of data for. So machine learning did better on the questions to the left of the spectrum, and humans did better on the ones on the right. Humans, I don't think we're great at dealing with exceptions, but we're still, at least for now, better than machines. And I know some people in the audience are working on addressing that, but in the system that we're looking at right here, the humans had an advantage. So there's a natural division of labor. The machines handled more of the common, repeated questions, especially actually the middle was where they added the most value because everybody was able to do the very common questions. And then humans were better at the right. And of course, you don't know in advance what the question's going to be, Arrow's paradox, and so you have to have the human in the loop and they figure out, okay, this is a question the machine can help me with, or this is a question that I need was about 2.6% per year in the United States in the 90s and early 2000s. And since then, it's only been about half as fast, 1.2%, less than half as fast in recent years. And it's not just the United States. If you look at almost every OECD country, you have a similar slowdown. France had a similar slowdown. It's not the exception. The exception is Greece, but who knows what's going on in Greece. And then we got the more recent data. I updated this. The data came in for productivity in 2023. I was a little bit excited that it looked like maybe we're beginning to see a jump up, but in 2024, it sort of leveled off again. The last quarter, which just came out yesterday, on February 6th, showed that productivity in the US was back down to 1.2% that quarter. So basically the same as what we saw before. We're really not seeing this amazing technology show up in the productivity statistics. Here's a graphical way of showing it that Jason Furman just tweeted a few hours ago, so I've managed to get it into the slides. You can see that there's a weird thing that happened during the pandemic where a lot of low-skill, low-productivity workers dropped out of the labor force, but the dotted line is sort of the trend, and you can see we're almost exactly on the trend. And there's, maybe in 2023 it was going a little faster, but now it's really back right on trend. And I don't see any big surge of productivity there in the macro numbers yet. We're seeing it in specific applications like the call center software, but we're not seeing it in the official data. And again, it's pretty much the same. Actually, it's worse in France. France had even lower productivity recently than it did earlier. So what's going on? How can we explain this? Well, one explanation is that we're not measuring digital goods very well. We've had an explosion of digital goods. We have, LinkedIn and Gmail and YouTube and Skype and all these things. Of course, we've got OpenAI, Gemini, Anthropic, Claude, all these tools. And we're having a lot of these ways of looking at the world all through this digital lens. Virtual reality. I have a Quest VR headset that I use every morning. But these digital goods that humans are now spending, Americans are now spending about 8.5 hours per day consuming these digital goods, they tend not to show up in our official GDP statistics. GDP measures all the things that are bought and sold in the economy, but with few exceptions, if something has zero price, it has zero weight in the GDP statistics. So most of these goods don't show up. And in fact, if you look at the official US data, since all these goods were invented, look at the far right, GDP in the information sector, which includes all these digital goods, hasn't changed at all. It was a little bit below 5% 30 years ago, and it's still around 5%. So we're not seeing it. That doesn't mean it's not creating value, it's just that it's not measured in official GDP. So we do have a measurement problem, and that translates into productivity, because what's the definition of productivity? Output divided by input. How do we measure output? GDP. How do we measure input? Hours worked. So if we don't count digital goods in GDP, we're not going to count digital goods in productivity either. We're missing all of that. And folks, especially my friends in Silicon Valley, say, hey, that's a big problem. We're not counting the benefits the way we should be. And I think there's a lot of truth to it. To address this, we've created a new metric we call GDP-B. The B stands for measuring the benefits instead of the costs. Even if Wikipedia costs zero, it still creates some benefit. Some of us would be willing to pay $10, $20, $50 a month to not lose Wikipedia, to still have access to Wikipedia. That means we're getting perhaps $50 a month of value, but that doesn't show up in the official statistics. If we did count that and we count the other metrics, we would have a much better measure. So in the coming year, I will publish a paper. We've already done it for Wikipedia and other goods. We're going to do it for a broad section of traditional goods and digital goods. And what you'll see is that there are trillions of dollars worth of value being created by these digital goods that GDP and productivity is not capturing. We still want to have official GDP. There's also these well-being metrics like happiness on a scale of 1 to 10. But GDP-B, I think, is filling a gap there to be a little bit more precise and still capture some of the benefits. While mismeasurement is important, I actually don't think that's the main reason for this productivity paradox. The main reason is that AI is a GPT. And I know you guys in the machine learning community think, oh yeah, generative pre-trained transformer. No, I'm talking about general purpose technology. Economists had the acronym GPT first, although we've lost it. General purpose technologies drive economic growth. And they have these three characteristics that Tim Bresnahan and Manuel Trachtenberg identified. They are pervasive. They affect almost all parts of the economy. They improve over time. Let's face it, few things improve as rapidly as AI, I just showed you. And most importantly, they spawn complementary innovations. That is, you can build new things on top of them. They enable new goods and services. Most interestingly, they enable new business models, new business processes, new ways of creating economic value. Electricity was a GPT, the steam engine was a GPT. AI is perhaps the most important and most powerful GPT of them all. Now, there's some things we know about GPTs, and one thing about GPTs is that, as I said, they spawn these complementary innovations, and by themselves, they rarely create as much value as they ultimately do once all those complements have been invented. So in the case of information technology or computers, another important GPT, I studied this, we found that literally 9/10 of the investment and 9/10 of the benefit were in the complements, not the technology itself. So when a company bought $1 million worth of computer hardware, they would typically buy another $9 million worth of organizational process redesign, reskilling of the workforce, et cetera. All those intangible complements are incredibly important and incredibly valuable, and I think they're important for AI as well. Now, how does this, so you need to have a whole transformation, not just buying the transformer or the technology. How does this affect measurement? Well, it leads to something we call the productivity J-curve. So focus on the blue line there, which to my eyes looks a little bit like a J. The reason it's a J is that at first, when you get a powerful new technology, you have to invest in changing your business processes, reskilling your workforce, thinking, how can we use this technology? And while you're doing that, you're spending a lot of management time, your organization is restructuring, maybe you're inventing some new products. That's costly. Does it instantly lead to output? No. It leads to intangible complements, but it doesn't lead to something that the customer could buy. So you have more input, no increase in output. Well, that's a decrease in productivity. So you get the downward part of the J-curve. Later, you start harvesting all those intangibles. You're like, now we have some new products, new processes. Now we have a skilled workforce that can do new things. And when we combine it with the technology, we can create even more output than we did before. So that's the upward part of the J-curve. So this is a very common pattern. We documented it in my paper about the productivity J-curve that's mentioned there at the bottom. For software, we documented it for electricity, we documented it for other goods and services. And we believe that's now happening for AI. In fact, we think we're near the bottom of the J-curve and it's beginning to take off right now. So we're going to see, we think, a big increase in productivity over the coming decade as we harvest some of the investments that companies have begun to make. Now, of course, to be clear, it's not always so clean that there's a single start and end. These are overlapping J-curves, but the net effect is the same, that you tend to underestimate productivity at first, and then you get big harvest later on. So what are some of the possible productivity futures? So there's a lot of different productivity futures that we can consider, but let me use one simple theorem that we can use. It's Hulton's theorem. And it's actually, theorem is almost too fancy a word. It's more like Hulton's multiplication. You just you multiply the areas that are affected by the technology by the size of the effect. And if you multiply those two numbers, you get a first order estimate of how big the effect is on the economy. So many people have done this. Martin Bailey and Anton Koronek and I did it in a very simple little paper for Brookings. The National Academies, that report that I mentioned, we have a whole chapter where we work through Hulton's theorem in a little bit more detail. Daron Acemoglu has a widely cited paper where he works through it, and Philippe and his co-author Brunel have a paper that's, I think, probably the best one, which I'll show you briefly some of the results from each of these papers. So first, the one that I did with Martin Bailey and Anton Koronek, that's also in the National Academies, we estimate about 40 to 50% of the tasks could be done with generative AI, and this is based on the Elan-Du GPTs or GPTs paper. Daniel Rock, one of my students, was involved in that paper as well. And you could guesstimate how much each of those tasks could be improved. We use 20% as a baseline. That's sort of like what we were seeing in our call center paper and some of the other papers. And if you multiply those two together, we got about an 8 to 10% productivity improvement. Very simple calculation. Now, that doesn't happen instantly. Remember I showed you the J-curve. We don't get that all in the first year. Say that happens over 10 years. Who knows exactly how long it will take. But if you spread that over 10 years, then you get a gain of about 0.8% to 1% of additional productivity growth. Now that's just with the technology today. If we have some continuing progress, it's easy to imagine that the gains will more than double to like 1.4 or even 3% per year is what we put in the National Academy study. So that's one kind of a number that we put out there just to get a back of the envelope number. Doron Acemoglu has a much more pessimistic, and I should say that I put a bet on this with Bob Gordon because he's a pessimist. So you can go to longbets.com and you can see our bet. I have a bet that by the end of the decade we will do better than this number, and Bob has a bet that we'll do worse. Doron Acemoglu is a much more pessimistic take. I'm going to go this a little bit quickly because I want to get to some of the other material. But he makes a different set of estimates. Although so for instance, he starts with a smaller share of occupations that he assumes are affected, uses different thresholds, and then he says that even if an occupation is affected, you may still not actually implement the automation there. So he multiplies those two numbers, and you get only 4.8% being affected. Then he also has a lower estimate for how big the productivity gain. He says 15.4%. And so when you multiply those two numbers together, you get something almost 1/10 as big as what we had, about 0.71% over the entire decade, or a tenth of that per year. So that's a much smaller number. To my view, he's being very pessimistic on all of his assumptions. But his paper goes in much more detail, and you can see how he does that. And then I mentioned the Aguillon-Brunel paper, which I think is the best one so far. It's much more comprehensive. I won't take you through all of it, but one of the things that they do well is they have a broad range of literature, and they talk about many of the different numbers there. And so there are some low-end estimates of as little as 18.5%, some high as 68%, and there are ranges for each of the other numbers as well. Of course, that leads to a wide range of estimates, from something that's very small to something large. They have a preferred estimate of about 0.68% per year, and Philippe can correct me if I got that wrong, but that's the last. Yes, he's nodding his head. Okay, so that's what they saw. And this is about 10 times more than Doron has. It's more similar to what our paper was, or the National Academies. Also, it's similar to what the French AI Commission does. And then I mentioned Jason Furman before. I just saw him tweeting about this. I don't know if that's an official citable paper, but he also said that it had a number sort of roughly in this range. But like all of us, I think all of us agree that there's a wide possible range of futures. So let me talk about that range of possible futures, because the possible futures are not just randomly assigned to us. To some extent, they're based on our choices, and we are able to steer the future. In the future, I heard Philippe comparing it to riding a horse, and we can steer it a little bit. So if we don't do a good job, I think we get a really disappointing low productivity future, similar to what Doron was imagining. I think he had in mind that all these bad things happen, that actually AI ends up not being used in very many places, only a few large firms. And I won't go through the whole list, but if you want to see them, this paper I have with Gabriel Unger on the macroeconomics of artificial intelligence goes through them in a little bit more detail, came out last year. So here's some of the bad things that can happen. We also have a list of good things that could happen. And obviously, to the extent we have choices, we'd like to steer ourselves towards the higher productivity future. If we get those higher numbers, it's amazing how much better off our economy will be. If you look at the US budget deficit, for instance, it becomes much smaller if productivity growth is just 2 or 3/10% higher. We can address poverty and healthcare and the environment much more easily if we get these higher productivity numbers. So I think that these are choices we can make in some of our legal frameworks, some of our training, some of our policy frameworks that steer us towards that. Again, I'll refer you to the paper for more details in the interest of time. Now, there's also a set of challenges. In addition to potentially having great productivity, we also have a danger of not being very fairly distributed. There's no economic law that says everyone's going to benefit evenly. There's no economic law that says everyone's going to benefit at all. It's possible for the gains to be concentrated in a very small group, perhaps capital owners, or perhaps certain types of workers, or perhaps technology owners could capture many of the benefits. So we have to make some choices. One of the ones I want to emphasize, and this builds a little bit on what Danielle was saying in the talk a little bit about an hour ago, I'd like us to think more about how we can use AI to augment humans rather than simply replace humans. The idea that AI should imitate humans and that the measure of intelligence was what humans have for intelligence can be traced at least back to Alan Turing. Actually, you can trace it all the way back to Daedalus 3,000 years ago, the mythical engineer. But Alan Turing literally said, here's my measure of intelligence. Can we imitate a human so closely that we can't tell whether it's a machine or a human? They behave so similarly. So that I thought was a great measure when I was a child. I thought that's amazing. You know, now we have a real measure of intelligence. I've since decided it's actually a really bad measure of intelligence. And it's not only a bad measure of intelligence, it's also a destructive direction for us to be steering our thinking and our research. So people like my former colleague Niels Nielsen at Stanford, even though he doesn't say he's pursuing the Turing test, in his papers, he and many other people implicitly say that they want something like that. Their definition of what he calls strong intelligence is intelligence that can do all the tasks that humans can do. So that's how they measure it. Can we take this, let's define a task that humans are doing, and let's see if we can make a machine do the exact same task. And so over time, you start making machines more and more like that. Now, why is that a bad idea? Well, for two main reasons. First off, no offense to my human friends, but simply being as good as a human is not ambitious enough. It's not really that high a bar. Imagine if Henry Ford was designing a new vehicle, a new car, and he said, we're going to make it walk or even run as fast as a human. It would have been kind of lame, don't you think? It wouldn't have been a very ambitious goal. This Venn diagram gives you a sense. If the white area is all the things that we humans can do, focusing simply on making the black area bigger and bigger is limited, because look at all that shaded area outside of it. There's so many new things that no human has ever done before that we can now start doing. You know, machines can fly at supersonic speeds. Machines can see things in the X-ray spectrum or infrared. Machines can manipulate things at the nanometer scale. Machines can do all sorts of computation. They can scan through the web and find documents. They can do calculations. Even my ordinary calculator can do calculations that I can't do. So all these capabilities is what we should be going for, things that no human can do. Imitating humans is a very low bar, and we should not simply do that. And here's a way of thinking about how damaging that is economically. I mentioned that Daedalus designed robots supposedly over 3,000 years ago, 3,500 years ago. So imagine that it wasn't just a myth. Imagine he had really done it. And imagine that he had successfully followed the Turing test and said, we're going to make the robots do all the tasks that Greeks do, that we do, and we're going to have machines do all of the labor in Greek society. Well, that sounds pretty good. We don't have to work anymore, right? And what do you get? Well, clay pottery. You could have as much clay pottery, you could fill this entire room all the way to the ceiling with clay pots. We could have tunics, beautiful Greek tunics. If your horse-drawn cart was broken, it could repair it. You could even make a new horse-drawn cart. If you were sick, no problem. It could burn incense for you, and you wouldn't have to have a human burning the incense anymore. Well, you can quickly see that although the good news is you have no more labor need, you really wouldn't have living standards that were all that much higher. I mean, after some point, the clay pots get a little boring, right? I mean, we want other things. We want to have iPhones and jets and all the other things. So simply having the existing tasks and automating them is not the way most economic growth occurs. It may seem like the whole point is to take labor out, but that's actually the smallest part of economic growth. Most economic growth comes from new goods and services, doing new things we've never done before. There's a second reason that it's really bad, and that is that it creates a trap. I call it the Turing trap. And the basic idea of the Turing trap is that productivity, as I said earlier, is output divided by input. So that's typically operationalized as GDP per hour worked. Now suppose labor hours go to 0. What happens to productivity? Infinity. Wow, it's hard to get much better than infinity, right? So we now have infinite productivity. That's kind of nice. What happens to labor income? Oh, wait a minute, that also goes to 0. So now you have infinite output, 0 labor income. If you're a laborer and that's your only source of income and you're not in on the deal to get some of that other stuff, that's not really good. So productivity is not everything, even when it's infinite. We don't simply want to maximize productivity. We want to think about the benefits. And if we make a machine that imitates humans, what we're doing is driving down the labor share. Other people may benefit. Now you've got a real distribution problem. And I think that can create a trap, because what it does, and by the way, this is something that is not just hypothetical. This is something that's happened historically. I mentioned earlier that we have seen growing inequality and disparate incomes. You look at the far left one there, you see wages. This is from David Otter's paper for people with graduate degrees, like those of you in this room mostly, versus people who are high school graduates or less. And you can see that those have spread out. We also see that it shows up in non-economic ways like suicides and alcoholism and drug deaths. And this can create a trap, because when you lose economic power, you may also lose political power. And you may be, in the limit, you may have a difficult time changing the system if you no longer have any bargaining power, you no longer have any leverage to get people to pay you or get people to listen to your political voice. And this Turing trap could lead to an irreversible situation that I think most of us don't want to see. Now, let me just say that right now I think we have excess incentives to steer that way. In theory, you'd like the market to just settle this, but in practice, technologists, business executives, and policymakers all have too much of an incentive to have AI that imitates humans rather than extends or augments them. Actually, I'm looking at the time, so I'm going to skip through this a little bit. Actually, I'll just do the government one. So in my paper, The Turing Trap, I describe more details for the other groups, but I see the clock here, I'm running down. So I'm just going to say that right now, the government has its thumb on the scale steering us towards replacing workers with machines. And the way it does that, one of the many ways it does that, is it taxes machines less than humans. So if you've got 2 workers, if you've got 2 workers, one of whom has 1,000 workers, and 2 entrepreneurs, one with 1,000 workers and one with 1,000 machines, the government says that the one with 1,000 machines will pay lower taxes. And so it's steering people towards replacing humans. I'm not sure that's the best thing if you want to have widely shared prosperity, not just prosperity. So there's a bias there. And there are a number of other biases built in. Let me just wrap up by looking a little bit to the far future, and this is something I'd love to talk about in the panel as well. If you go to DeepMind, they have a modest little slogan on the wall there. Demis Hassabis says the goal is to solve intelligence and then use that to solve all the other problems in the world. I'm sure each of you has a mission statement, either in your company or personally, that's equally ambitious. But there's some truth to it. If you could solve intelligence, you could solve these many other problems. And we are now having some very powerful technologies that are beginning to really affect things far beyond what we saw in the call center or the coding or the earlier examples that we saw. Some of these technologies that are emerging currently and that are likely to be emerging in the next 2 to 5 to 10 years are likely to affect much broader sections of cognitive work and ultimately physical work. So we had a gathering last year at Asilomar in California of about 50 economists and about 50 technologists to talk about this thing we're calling transformative AI. That is AI that's so powerful that it transforms the economy just as much as the Industrial Revolution changed the economy when we changed from an agricultural economy. We're seeing a really big change, and a change that big that's going to happen in a much shorter period of time, only in 10 or 20 years instead of spread out over 1 or 2 centuries. We have a dashboard we're creating to measure how close we're getting. We have 60 indicators of whether or not this is beginning to happen. Bill Nordhaus wrote a paper where he looked at 6 indicators and he began to see some things. We're going to have a much more detailed, more real-time dashboard. And then we have a paper that I'd be happy to share with you called The Economics of Transformative AI Research Agenda. And we look at these 8 different questions. We don't have the answers to these questions, but we believe that a question well posed is half answered. So we define what the key questions are for economic growth, for invention and discovery, for distribution of income, for concentration of power, for geopolitics, for information, communication, and knowledge, for AI safety and alignment, and for meaning and well-being. And by defining these questions, we're encouraging other researchers and we ourselves to work on trying to answer them so we can be prepared as the technology continues to improve exponentially, whether or not we'll have economic understanding and economic institutions that are ready to match them. Because that gap between the technology and our understanding is where most of the challenges and most of the opportunities for the coming decade lie. So we're calling it Project Apollo, and it has a number of different strategies. We're getting new data, theory, we're doing a set of simulations, we're getting a community together, and we're ultimately looking to have impact on policymakers as we understand better. Right now, there are hundreds of billions of dollars going into advancing the capabilities. There's almost nothing going into improving our understanding of the economics of it, and we want to bring together a group that takes that seriously so that we're able to be ready as these increasingly tectonic changes happen in the economy and society. So if you want to read more about it, here are some URLs where you can download all the papers that I mentioned and learn a little bit more about it. But with that, thanks very much. I'm looking forward to our panel discussion.
Thank you, Eric. Thanks very much. Well, look, Eric, as you say, we will be able to look at the economics of transformative AI a little bit later on in our last roundtable discussion of this 2-day conference. We've got our last plenary then of today, and I'd like to welcome Philippe Aguillon up to the stage. Philippe is a professor at the Collège de France. He's also at INSTED. He's a visiting professor at the London School of Economics and a fellow of the American Academy of Arts and Sciences. Well, Philip's research focuses on the economics of growth. Whilst Philip has written numerous, I should say, publications, much of his work is summarized in joint books with Peter Howard, one particularly entitled The Economics of Growth. I'm looking forward to hearing from you today, Philippe.
Okay, very good. Thank you so much. Thanks. So it's great to be here. And thanks to the organizers, and a pleasure to listen to Eric, whom I'm a big fan. We entitled this presentation, Should We Fear AI? So I had the privilege of co-presiding the French Commission on Artificial Intelligence. Yann Lequin, Yann is with us. Simon, we worked with Simon and several members. We had a fantastic commission, and in fact the commission was, co-president of this commission was Anne Bouvreau, who organizes the whole summit, with the delegate of the French president for the whole summit. We had main rapporteur, Arnaud Amabil, Simon Bunel, and Cyprien Canivinck, and what I will talk about today is very much based on joint work with Simon, who is here first. So, as you know, I mean, I don't need to remind you that AI first developed in the form of deductive rules of the type, if something, then something. That's what we call the symbolic approach based on reasoning and instructions. But although the symbolic approach has not been abandoned, a statistical approach to AI has been gaining ground since the 1990s, machine learning. Unlike the symbolic approach, the statistical approach involves no explicit human instruction. The machine is trained to recognize links from a set of training data, and the machine then applies these links to new data to perform a task. The success of the statistical approach relies on two essential inputs, data and computing power. The AI revolution is truly, as Eric stressed, it's a true general purpose technology. It's a true technological revolution in the same way that steam engine, electricity, and IT were revolutions. It affects all domains of activities, the economy, public services, the organization of work, media, culture. And within that revolution, the emergence of generative AI represents an unprecedented acceleration. To just give you an idea, it took 2.5 years for Netflix to reach 1 million users. It took only 5 days for ChatGPT to reach 1 million users. Okay, so now there is, as was stressed by, explained by Eric, there is a pessimistic view. My friend Daron and others, maybe Bob Gordon, who are all very good friends, they have a very pessimistic view of things, and they see a little growth impact and very negative employment impact of AI for some of my colleagues. Okay, our view in the report, in the AI report, and which we are pushing here, is what I would call a cautiously optimistic. The view is that technologically, AI has big growth potential and has employment creation potential, but it will all depend on the policies and institutions that we put together, you see, that we put in place to along with the technology. So really, prosperity is the joint result of technology and institutions. And the problem is that institutions are much slower moving than technology, particularly with the AI revolution. So let me talk first about AI and growth. So in joint work with Chad Jones and Ben Jones, I was the only non-Jones in the team, we developed a model of growth with AI and where AI boosts productivity growth, both because it automates tasks in the production of goods and services, because also it automates tasks in the production of ideas. It improves the innovation technology. With ideas, well, among other things, AI helps find solutions to complex problems, it facilitates imitation and learning, and it can become self-improving. And I don't want to bother you, automation is the idea that you can perform various tasks, and the X1, Xn, you can either not automate them, it's done with labor, or you automate them, it's done with capital, and capital we produce ourselves, okay? And at the end of the day, the growth of productivity growth, the growth of Y over L, depends on how much a task you automated in the production of goods and services. So the alpha, when the alpha goes up, the growth in output per capita goes up, and it also depends on the efficiency, on the productivity growth, on the growth of the A. And so when you automate production of goods and services, you increase the alpha. When you automate the production of ideas, you increase the GA, and both are important. So let me start first. I will just go back and mention your paper, Eric, that Eric looked at this firm, at this Fortune 500 company in the US, which advises small and medium-sized enterprise on enterprise software. So you have the SMEs, and the head of an SME, makes a call to this Fortune 500 company and said, look, we want to adopt a software. And you are sent to employees, I don't know if it's in the Philippines or wherever, and the Philippine employees, or wherever it is, and most of them, they use not to have access to LLM, and then you provide them access with LLM progressively. So you can compare the productivity measured by the number of resolutions per hour. You can compare the productivity of an employee who has access to LLM to a productivity of someone who doesn't have access. And my way of representing what you do is particularly this. You compare to an employee who didn't of similar productivity, education, and background, who hasn't had access to the LLM, the employee who is given access, and then productivity is boosted, plus 14% after 1 month, and plus 25% compared to the control group employee. So boosting effect, and that's what your paper showed, that for this enterprise to adopt AI, to introduce AI and generative AI, had a boosting effect on productivity. Now, that's one enterprise, and then you want to go, you say, okay, that's a micro study. What happens when you move from micro to macro? So one way is to say, let's extrapolate from previous general purpose technologies, from previous revolution. Electricity, for example, increased even after a period where you didn't see anything. suddenly you had a takeoff of growth, and it increased growth by 1.3 points. I mean, if you percentage point, if you were growing at 1% per year, for 10 years, you grow at 2.3, and then you go back to 1%. For IT, it was a boost of 0.8% per year, per percentage point. If you are growing at 1%, then for 10 years, you grow at 1.8, and then you go back to 1, okay? So that's what you have here. Okay, so without, and suppose AI would be anything between IT and electricity, you would have this shape. Without AI, the evolution of GDP would be the dotted line. With AI, for 10 years, you grow faster, you have a steeper slope, and then you get back to the slope that you had before, okay? That's if you extrapolate, or the extrapolation would say if AI is of anything between IT and electricity, we should see in the order of magnitude of at least 0.7, 0.8%, percentage point additional for 10 years. So then the other approach is the Acemoglu approach and the task-based model. And so what they do is that when gains in total factor productivity will depend, due to AI, will depend first on the GDP share of tasks that are exposed to AI. Then, of course, among those tasks, only a fraction, it will be profitable to implement AI. Then it depends on the labor share on those tasks and the labor saving which is induced by AI. And on all of these numbers, Acemoglu puts some figures, and he arrives at a 0.07% additional percentage point per year, 10 times less than the extrapolation. So what we did with Simon is to go back to the Acemoglu. We say we take the same methodology, but let's go back to the numbers. And for the GDP share of task, he takes this number from Elundu. But for example, IMF believes that instead of 98%, it's 68%. So you have the whole range, share of tasks that are exposed to AI, and Acemoglu is on the pessimistic side. If we look now among those tasks, those we would be profitable to adopt, you see what happens is that Acemoglu uses a paper that says, you take visual tasks, only 23% of the tasks exposed to AI are profitable to automate for American firms. But the same paper that Acemoglu cites say, no, but that's not right, because you have cost reduction. Over time, it becomes increasingly profitable to automate these tasks. And that same paper by Svanberg et al. Proposes 3 scenarios: annual cost reduction of 10%, 20%, and 50%, leading respectively to 30, 50, and 80% of visual tasks exposed to AI that become profitable after a 20-year period. And even then, visual tasks are not the tasks for which are not the use of AT for which progress is faster. For example, for understanding writing and language, and I go back to the first picture that you showed, you see the human performance, you can see that particularly understanding writing or language, progress is much faster than for visual tasks. So if I restrict myself to visual tasks, I'm underestimating again. Okay, so that's the speed at which AI becomes profitably used. Then Acemoglu looks at the labor cost savings. He makes the average between a paper by Noy and Zhang and your 14%, Eric. But after 3 more months, you are 25%. So it should not be 33, it should be 40. Okay, and finally, so at the end of the day, the range is between the 0.07 of Acemoglu and up to 1.24 percentage point. And with Simon, we believe that the reasonable average is 0.68. So we get back to the similar order of magnitude as if we were using the extrapolation method. So whether you use the extrapolation or a well-informed task-based approach, we get that AI should improve when it will take off. At the time, as you explained, GPT for a while, nothing much happens. It's the Solow story. Remember when Solow said, we see computers everywhere, but in the statistics, he was right before the takeoff of the IT revolution. We see at least 0.7 percentage point. In France, now we are at 0.8 per year. It means that we would move up to 1.5. You see what I mean? So that's a huge, it's almost doubling, okay? So now remember that this is still an underestimate because I didn't take into account the fact that AI automates also the production of ideas. okay? And so in fact, instead of having the red curve, the red would be if I had only AI automating tasks in the production of goods and services. You would have this higher slope for 10 years and then going back to the slope of the dotted line. But in fact, you also improve the innovation technology. AI also makes ideas easier to find. And therefore, you get to the light blue curve. Higher growth initially and permanently higher growth. And you mentioned that paper, Eric, by Turner Rogers, this MIT student. What Turner Rogers does, he exploits the randomized introduction of an AI tool for material discoveries in a large US firm that in fact focuses on applications of material science in healthcare, optics, and industrial manufacturing. And again, you compare the research productivity of those who have access to AI to that of those who don't have access to AI. And so the author looks at the AI's impact on materials discovery and its downstream effect on patenting and product innovation. So what happens? When you robotize, you become more productive. When you become more productive, you become more competitive. And therefore, you sell cheaper, you see what I mean? Or you have a better quality-price ratio. So then the world demand for your product increases, and therefore you employ more. And that productivity effect more than counteracts the substitution. In fact, I had a huge fight with Darren on that, and with Otter and all these guys. They believe that deeply that automation, they thought we should tax robots. It's a very stupid idea. Don't tax robots. It's a very stupid, only in France we invented that. We are very good at those ideas. Okay. So, I don't want to say who suggested it in France. Okay, so now what about AI? Okay, so with Simon for the report, and together for the report with Yann, we did a random survey covering 9,000 representative French firms, with more than 50 employees each. And we compared the employment in firms that adopt some AI between 2017 and 2020, and similar firms that do not adopt AI. So you have a treatment group of adopters and a control group of non-adopters. And what do we find? We find that firms that adopt AI increase employment overall. Again, it's a productivity effect. And how do we know it's a productivity effect? Because the sales go up as well. You see, so those firms that adopt AI, they have a bigger market for their products, and therefore they employ more. Okay, so but that's the thing is that true for all types of employment? No. For example, for administrative, jobs like executive secretary, administrative service, that are highly exposed and a priori substitutable employment, the effect is not so positive. So then what we say is that we want to understand better why is the overall effect positive, but it's not uniformly positive on all jobs. So there is a very interesting study by these Gmirek and co-authors from the International Labour Office working paper, and they look at the extent to which generative pre-trained, the GPT, will replace jobs or not. And what they do is they decompose jobs into tasks. And for each task, they say, we put a low score to the tasks that have a low replacement risk. I will put a medium score You see the continuous curve. It has gone up since the 2000s because people, when they lose their job in the US, they lose status, they lose access to health insurance, and they become very stressed. They take opioids and sleeping pills, and mortality rate has gone up. But in Denmark, our colleague Alexandra Roulet has looked at in Denmark what happens when you lose your job. For 2 years, you receive 90% of your salary, up to a certain level of salary. The state retrains you and helps you find a new job. If you refuse more than 2 jobs in your qualification, you have unemployment insurance going down. Here, she compares the health of a worker in Denmark in a firm that closes down to the health of an identical worker in age, education, experience in a firm that does not close down. No effect of becoming unemployed in Denmark on the purchase of antidepressants, anti-anxiety, and sleeping pills. No effect on the probability to visit a hospital for circulatory problems. No effect on mortality. So I think, you see, at the end of the day, you want to harness the growth potential, competition policies has to be reformed. You want to harness the job creation potential, education, and flex security. And I wanted to say also something, and I'll be done. In the report, we make it very important, very stress this point. We need competition, foster competition, open source, ease data access, extend the Digital Market Act to the whole value chain of AI, starting with the cloud, avoid excessive regulation. But on the other hand, you need to invest in computing power. It's important so the state plays a role, state and private sector, invest in AI diffusion and advocate an AI exception in public research funding. So that brings us to Mario Draghi. Mario Draghi has been pushing, says you need a single market competition, you need a financial ecosystem, but at the same time we need governments to invest in to do smart industrial policy and smart investment in innovation. And in Europe, the problem is that we've been opposing, in the name of competition policy, we have precluded any form of sectoral state aid. The word industrial policy in Europe is a bad word. That should stop. We should understand that you need both competition policy and competition-friendly industrial policy. And we need to do much more on innovation and research policy, together with developing, to liberalizing the credit market, the financial market, and the goods market. And I think that's what I would like to, that's how I would like to conclude this, this presentation. Thank you very much.
Philippe, thank you very much for a very energetic, if you stay with us on stage. But you've revved us up. We're all raring to go now. Thank you so much. Incredibly insightful, but also very energetic speech by you there. This brings us last to our dedicated, final dedicated session of the conference. It's entitled From Building AI to Living in a World That's Built on AI. That discussion will put the spotlight on how AI is kind of reshaping industries, transforming societies, and a lot of thought will also be given to this kind of balance that we've been talking about since yesterday between innovation and ethics and how that plays out on the broader scale. So in terms of who will be taking part, of course there'll be Philippe, who will be staying with us on stage. We'll also have Joshua Bengio, who'll be back with us. We'll have Danielle Allen, Eric is coming back as well. And this debate is going to be moderated by Alice Albizzati, who's a founding partner at Revere. So welcome to you all to the stage. Okay. Go on. Welcome, Alice. Good to see you.
Good afternoon, everyone, and thank you for joining us for this closing panel. I'm Alice Albizzati, so I am running a growth tech investment fund called Revaya, and it's an honor to be moderating such a high-level discussion with some of the most brilliant minds that do provide a theoretical framework to what we do as tech investors. And it's all the more an honor that I'm a former student of the École Polytechnique, and so I'm speaking on behalf of XAI, which is the alumni group of École Polytechnique. So thank you for providing very insightful thoughts on the impact on AI on society. The topic of this discussion is from building AI to living in a world built on AI. I think you provided very complementary and yes, insightful thoughts. To start this discussion, I would like to discuss, to ask you, Eric, this question on transformative AI that you've just discussed. So as you've extensively studied the impact on economic impact on AI on society, how do you see AI transforming our world and the world that we're building?
Well, that's a big question. I think we're entering uncharted territory. Philippe, in his earlier talk, this is a great talk he just gave now, but he also gave another talk, and he made the point that it's very difficult to get data about the future, and so we do have a challenge when that comes to it. And Joshua mentioned also that we're going in areas that are just very hard to predict. That said, I do think there are some parts of it that we can foresee, and I think it's almost inevitable that the basic technology, AI, will become much more powerful. I mean, even just every week I see something that I didn't expect that's surprising. I think even Joshua, you've been surprised, haven't you? I have. Yes, and that's what all of my very smart colleagues in AI tell me, that they consistently have been surprised recently by some of the progress. Now, if you take the sort of task-based approach that Philippe mentioned, that I mentioned, you can readily see that there'll be more and more tasks that humans currently do, especially starting with the cognitive tasks, but then increasingly some of the physical tasks. I thought they would take longer, but my friends in robotics say that actually some of the breakthroughs on the existing technologies are very helpful in creating agentic systems for the robotics. So then you start having a large set of the tasks that humans do. I'm not someone who believes that there's some kind of a magic spark in humans that can never be replicated. I think ultimately, we are made of atoms and they're made of atoms, and that in theory, they can cover a lot of the territory. One can do a thought experiment and imagine, suppose there was a machine that could do all of the thinking tasks and all the physical tasks that humans could do. What would that mean? Then we'd be in a very different kind of a world. And that's part of the agenda for the economics of transformative AI. One can imagine that would likely lead to much higher productivity, which is great, but I also showed you that doesn't necessarily mean that everyone benefits. We need to come up with some way of distributing it. We need to think, are there some things that we would still value humans for? Like, I prefer to watch humans play basketball or tennis or even chess than watching machines do it. So there may be some intrinsic appeal for that, and there may be some tasks like that. I think the biggest challenge is actually going to be around power, and that when we no longer have our labor power that gives us bargaining power and forces society to give us some compensation. If you don't pay a farmer, you don't pay a factory worker, you don't pay a professor, then you don't get their output. But in the future, we won't have that kind of leverage anymore. And then whoever controls the technology that creates this value, hopefully they'll be benevolent. Perhaps we can create some kinds of checks and balances that enforce that, but I think that's going to be a new kind of economic and political system that we need to start designing now, so that we don't suddenly end up in a place we don't want to be.
Thank you. Sure.
I think there are many. I mean, we saw the example of the researcher. They find, with AI, many more possible, material designs. Okay, so it enlarged the amount of it. So then you need judgment. Or maybe the machine will have the judgment, but we need a human to make some choice and some ethical choice as well. I think that's a doctor. I can see AI helping, but you need a human element to take care of the elder, for example. Would we think that only robots would do that, or we think the human element? And so I think I really see AI as a tool that will allow us to do much more. And that's one thing. And the other thing I mentioned, that prosperity is and happiness happiness is the joint outcome of technology and institutions, who will do the institutional reforms? Do we think that it's only the AI that will change competition policy, that will put in place the flex security system? Those are social things. It's a social movement that determines that. And we know that the technology without the institution, they will not deliver the prosperity we want. So I can see in many respects, that it will make human intervention even more important, and social movement even more important, and civil society, governments, humans, judgment, also Kuhnian innovation. Also, there is something, or maybe I have a question I always ask. There is a lot of recombinant, okay, in the machine. It will go beyond the recombinant. But sometimes it happens in our life that we decided that the paradigm, we want to throw away the paradigm and start with a new paradigm. And maybe the machine will do that. But that's a question of judgment, of intuition also. There are things that we do. Maybe a machine will do everything. But sometimes we have a sense that something is wrong, or something has to be changed, or that the political system cannot go on, that things have to be transformed, that we have to rethink, international trade. And will that be left to I see the human element. I see more and really the complementarity between us and the machine, not substitutability in those respects.
Just a couple of comments. I think having AI as tools is what most people envision, and you're right, this is what we should be aiming at. So long as the tools are used in beneficial ways that don't disrupt our societies too much. But actually, this is not where companies are going. What they're going is, agents. In other words, entities that are autonomous and that could do tasks not just over like a few interactions or answer a few questions, but actually can take a task for days and weeks, just like a human would. And so at that point, thinking of these entities as tools, when they have their own goals, they build their own choices of how to achieve those goals. And worse than that, right now, we don't know how to control them so that they don't have their own self-preservation goals, as I mentioned earlier. Thinking about them as tools is wishful thinking. We need to make sure that they remain tools. Regarding the economics, I'm not an economist, but I think it's really important to project ourselves and ask the question, not what AI is now or what it was 3 years ago or 5 years ago, but where it will be when we get to essentially all the cognitive abilities of humans. And by the way, intuition is the thing that AI is already good at, and knowledge is already the thing that it's very good at. Right now, we're seeing progress and gaps in terms of planning, in terms of reasoning. We see a lot of progress in the last few months, and it's going to continue. So it's not clear where we're going, but I think the picture of how we see AI now is like, oh, our computer, our laptop, is not at all the picture we should have about these machines that are as smart as us, which could come in a few years or decades. We don't really know.
So I think this is exactly the right conversation to be having. I think we are living through a paradigm change. And if we are borrowing the language of Kuhn, what we know about paradigm change is that it's always coming from puzzles that need to be solved, problems in the pre-existing paradigm, but then also competition in relationship to potentially reigning ideas. So it's not the case that we need to sort of see the future. We get to make the future, and we will make the future through a competitive process. You named the fact that you expect AI to be perfectly good at all of the cognitive and physical features of human life, but you didn't name the social and affective and relational aspects of humanity, which is precisely, Philippe, what you're alluding to in the nature of the decision making. So that's where what I think is sort of really important to communicate is that the different tech paradigms that we're watching unfold in the world are also different economic and social paradigms. And they have different answers to the question of how we will make these social decisions. So there is a paradigm that says maybe we'll just have a benevolent dictator. I think honestly, I think that's sort of what OpenAI is kind of drifting along in those streams. And my view would be, we shouldn't just sort of say maybe it'll be that way, and we have a choice. We can do the social work, do the relational work, do the policy work to steer technology and develop paradigms that are supportive of human flourishing. But that's, again, why the title of my talk was, it's time to choose. Because it's not about seeing the future, it's about actually choosing the future.
Can I add something to this? Sorry. I completely agree. And I would like to add something connected to some of the things you said. Influencing the future so that we go to a world where AI is a tool and is used for the benefit of all, and that all the productivity gains are redistributed, is not going to happen just by letting the forces of markets and competition between countries do their usual work. Because competition right now, what it's doing is going to the easiest jobs to replace. For example, maybe the people who are less well off are not going to be easy to find another job. The competition is going to making AIs more capable and not safer and not acting more morally. Competition is making countries compete on AI and start to use it for military applications and maybe cut corners on safety and other risks. So I think that we can construct a better world with AI, but it has to be intentional and not just let things go.
Can I just clarify for one moment? Thank you for saying that, because it's really an important point, and I need to clarify what I meant by competition, because I didn't, in fact, mean market competition or the way the term is commonly used. It's intellectual competition. That's what we actually have to have. We can't, in fact, get into another paradigm unless we have intellectual competition around the paradigms themselves. So that's what I was really trying to name. And again, that's why I think it's really important to recognize that you've got your sort of Peter Thiel paradigm, your sort of NRX paradigm, the OpenAI paradigm, and then the plurality paradigm, which Taiwan is the best example of. But we haven't really surfaced that intellectual competition as of yet, and I think that's what we need to do in order to have choices.
Thank you. So going back to this idea of competition and intentionality, how can we make sure that AI play a key role in addressing some of the global challenges such as climate change and inequality?
So, okay, so I'm often asked, how is AI going to do this, or and I think the framing, I want to pick up what Daniel, Ashwa, and Philip highlighted, is not what AI is going to do, is what we're going to do with AI. And so there's the most common question from journalists is, what is AI going to do about jobs? What's AI going to, and I think we have to really take this intentionality. AI is a tool, at least for now, and it's becoming more and more powerful. Almost by definition, the more powerful the tool is, the more power we have to change the world. You can take a spear and throw it against a cliff and it makes a little dent maybe. You have a machine gun, you have a bomb, you have bulldozers. The more power you have, the more you can actually change the world. And now we have some of the most powerful, probably the most powerful technologies ever, which means that in principle, the world could be very different depending on how we use them. And that means we have to think even more carefully about what our goals are and not be passive, as my co-panelists have all been emphasizing. I don't think we're spending nearly enough time thinking about this intellectual competition, about what the values are that we want to prioritize. We're sort of, I think, almost going blind, stumbling ahead with just momentum about what's happening. We need to step back. And when I say we, I mean all of us collectively, because we all have some degree of influence over this, and think about what are the values that we would like to see in this new world. I'm optimistic that we actually can steer technology to a large extent, and we can use AI to shape the kinds of outcomes we have, including ones that have widely shared prosperity. I also believe that an outcome of horrific inequality and concentration of power is very feasible and on the table. And it will happen if we aren't more aggressive. That paper I briefly mentioned, the macroeconomics of AI, we mentioned 3 forks in the road, and I won't go through all of them right now, but one of the conclusions we had as we assessed each of them was that the business as usual, the passive approach, in each case led to the worst outcome.
and that the one that we wanted takes a lot more construction. You know, I think there's probably some deeper theory there, but building something valuable and complex actually is a lot harder than having a bad outcome. And luckily, for most of history, we humans have done a good job of constructing these things. But as we're discovering, especially the past few weeks in parts of the world, it's, you know, things can get torn down a lot more quickly than they can get built up.
I wanted to elaborate. Let's take green innovation, green transition. We know that firms spontaneously don't go green. Firms that innovated a lot in dirty technology in the past, they tend to continue innovating in dirty technology. And suppose they had trained AI to do the things they used to do, the AI will continue to tell them do the same thing. The AI will not say now go green, not necessarily. So you need to redirect firms' technical change towards green technology. You do that with a carbon tax, with green industrial policy, but also civil society, the consumers also. You know, when they are aware of environmental, when they are concerned by the environment, also stir firms' innovation towards green. So you can see the role of the, you know, of governments in general, the state, and the role of civil society. And the triangle between firms that innovate, the state, and civil society is crucial. It's true for green, but it will be good for AI. We want AI that creates jobs. We want AI that enhances education and social mobility. We want AI that enhances social dialogue. For example, in France, vis-à-vis compared to Germany, we have a dramatic problem of lack of social dialogue in France. Our hope, and that was very much the spirit of our report on AI, is we believe that AI will allow social partners and unions, etc., to be much better informed about what's going on in the firm, and to boost the social dialogue, which I think we have a big problem of distrust in France, within firms particularly. And so, again, AI can go in the wrong direction of, you know, exacerbating inequality, making jobs uninteresting, and at the opposite, it can enhance the quality of jobs, the soft skills, and the social dialogue. But that is the humans. We steer. We are the one who conduct. We are the drivers. It's not AI that will do it for us. We decide what we want. That's
very clear. And so, I'm curious to hear your thoughts on the implication or the consequences of the new balance of power. We've seen in the US, Trump and Musk being very vocal on very different topics, and AI being one of them. Obviously, France and Europe also with the summit have very strong ambition. In China, we had DeepSeek. So, Joshua, how do you think that that will impact the next decade?
Well, that's a case where I think we need intentionality, because the default is we're going to have two countries leading by far this race towards human-level AI and even super intelligent systems in the future. And I don't think that is a good thing for the planet. It's not a good thing for the people on this planet. I would like to see, and on the other hand, I think if you look at an individual country like France or Germany or the UK or even, you know, countries that are less developed, it's not clear how they can bridge that gap right now. But there are several reasons why I think it would be good if we saw a third alternative that would be better aligned with the kind of humanist values that we find, for example, in Europe, and democratic values, and the protection of the public, the sort of things that you mentioned that mean that, you know, people don't get super stressed because they lose their job. Well, that's everywhere. And I think it could also play a positive role with respect to the race that is engaged between the US and China. If a few countries who have collectively the talent, the capital, the energy to compete, but want to build AI responsibly in a way that's going to benefit people in an intentional way, I think can really change that future and maybe bring a bit of counterbalance to the direction that we're seeing right now, which concerns me.
So I think the other thing that's hard in this and important is that we've been working with a paradigm where AI is the same across the globe. That is to say, front leading edge advances we're expecting kind of replication everywhere. And that framework ignores the important socio-technical reality that the technological paradigm in use will have ramifying effects on all social and institutional structures. And so when we think about the sort of race between the US and China, the part that we often miss in that is there's a question of whether or not, for example, the US will achieve a technological developmental paradigm that supports the ongoing maintenance of democracy or not. And the US ultimately needs something different from what China needs. And so that's where I think the question of a race can change, can be inflected if, again, we can find our way to putting the social and political questions back on the table alongside the technological questions. In other words, the US doesn't want to win any old race for technology. That is, I'm speaking as a citizen of the US, so what would I want my country to do? I only care that we actually win a race which is about having technology support the productivity of a democratic society specifically. And that's actually a different picture of productivity even than we've been hearing about on the stage. So we've been hearing a lot about the creation of GDP and then redistribution. That actually ultimately is a framework that undermines democratic society because it makes too many people dependent on a small number of people with concentration of power. So you actually need a different political economic paradigm that is about redistributing power as well as thinking about redistribution of material goods. And it is about the integration of everybody in the productive economy as opposed to the exclusion of many from the productive economy and then their satisfaction with redistribution. So the point is just that, again, you know, if we need to sort of break the frame of thinking that there's going to be one model or sort of one version of AI and recognize that we're actually talking about various kinds of social alternatives alongside thinking about technology and productivity.
I just want to continue on this notion of concentration of power. One reason why I think that there should be alternatives to the US and China efforts is precisely because it is not healthy to have concentration of power for democracy and even for geopolitical stability. You know, in general, this is something I repeat very often, like we shouldn't have a single person or a single corporation or a single government controlling superintelligence, which, you know, we will have at some point. We don't know when, but it could come faster according to some people, slower according to others. But that's going to give huge power to whoever controls that. And the only reasonable way to deal with that power is if that power is decentralized. And, well, with our current political organization on this planet, decentralizing the power means that multiple governments somehow have a strong voice in deciding how we use that power. And that also is going to make sure that the decisions we take are wiser, more inclusive. I think that has lots of benefits. Now, I'm not saying this is going to be easy or even feasible, but I think that's something we could aim for in order to try to steer things in a better direction.
Take an example. I mean, you have DeepSeek, now the Chinese thing. You ask them what they think about Taiwan. They will say Taiwan is part of China. Do you think that DeepSeek itself would change the answer? No. They will take a revolution or a human revolution in China to get the DeepSeek or its equivalent to provide you with a different answer to what should be done with Taiwan. I mean, you see what I mean? That's a kind of clear, I mean, AI does what you tell them to do. I mean, DeepSeek will itself say we should have a Taiwan independent? Right.
I'm sorry. I'm sorry to say that the science right now shows that AI doesn't do what you tell it to do. That is the problem. You tell it to do things like, you know, be honest, don't cheat, but it does. Okay, so you have many experiments, not just
So in the case of Taiwan,
yes,
also,
Taiwan is independent?
it will, but it's very easy to make it say the opposite, okay? So the problem is we haven't found a way to actually make it do the things we ask it to do. And in general, it will do the things that you ask it to do, but it's pretty easy to actually counter that. And in some cases, it's not that somebody is trying to defeat the AI, it's the AI itself that is cheating. So let me give you an example of a recent experiment. The AI knows that it's going to play a chess game against a specialized chess program, which is actually stronger than these very strong frontier models. And so the AI wants to win, and what does it do? It cheats. It doesn't play the game, it changes the files that contain the board game. So you know, that's... So you know, and I've talked this morning about other examples, and there's like the whole year, past year, we see more and more of these things happening. The smarter they are, the more they cheat.
So AI, just like human being, has some bias and some weaknesses. You. Perhaps on the question of geopolitical, I would be curious to hear your thoughts, Philippe, from the French and European perspective and the AI Commission on the key responsibility that our government, our corporates, and us as a society have to tackle this challenge.
I mean, I don't want to, repeat what we propose in the report, but there was a whole part of the report. I mean, it's to really, so first part is to diffuse AI to the economy. So we believe that, we need to boost research in AI. We have fantastic mathematicians, computer science, and but there are, research is poor in France. So we need, we had a previous research minister, she wanted to slash 800 million euros of the, fortunately the new research minister is undoing what the previous did, fortunately. But we are already poor and they wanted to slash on the research budget. So we need to have a research, an exception, AI exception in research. But we need also to diffuse AI in the economy. Firms, because a lot is adoption of AI by enterprises, so there have to be, and that takes also public investment. And similarly, we want to introduce AI at school and at universities in each specialized AI. So there is a huge investment to make to diffuse AI. We need to invest in computing power, local computing power, to give access, because access of new firms is not only competition becoming more friendly to entry, but it's also for them to have easier access to computing power. And that's where it's public and private intervention. So those are the things where really we, those were the main threads, competition, but also public intervention in computing power, in diffusion of AI. And I think those were but the big thing is that Europe, I want to talk about Europe. Europe is losing to the US, okay? In the Draghi report, the Letta report, the Bocconi report, and we've seen US is in high-tech, frontier innovation. Europe is in mid-tech incremental, mostly. And we missed out a bit on the IT revolution in Europe. We don't want to miss out on the AI. And why? Because we don't have the ecosystem to produce. And the problem with Europe is that Europe gets its acts together in emergency. When we had COVID, we have to react. The Ukraine war, Putin, okay, we react. And we don't perceive the losing to the US and the decline and the technological decline of Europe vis-à-vis both the US and China still yet as an emergency. You see what I mean? And that's the big problem in Europe. And that's where people like Draghi have to fight to say, no, we should waste no time. We need a true single market. We need a true financial ecosystem. And we need truly, innovation policy, industrial policy and innovation policy in Europe to put us up to standards of those countries that are, investing so much. And I don't know yet that Europe will be able to do it. And the question is, do we do that to all countries in Europe? Do we align on the mean, or we do coalition of the willing? I believe personally in coalition of the willing. I believe that on AI, we should partner, we should team up with those who want to do things, not with those who don't want to do things. That should include the UK, by the way. They are willing willing to do things. And I think we need a new dynamic for Europe to wake up, because otherwise we are really becoming insignificant. China raising, US being also still at the head, and Europe declining. And that's I think is a big, it's a kind of huge concern. Maybe
I want to add something about insignificance from the economic perspective. I'm not an economist, but I think there are simple things that I can anticipate as plausible. When we get to superintelligent systems, economically, you guys talked about the jobs, but there's another issue, which is that I can see from the declarations that are made, and what logically these people would do is that the people who control these systems, like say OpenAI potentially, they're not going to continue just selling the access to their AI. They're going to give access to a lower grade AI. They're going to keep the really powerful ones for themselves, and they're going to build companies that are going to compete with the non-AI systems that exist, and they're going to basically wipe out the economies of all the other countries which don't have these superintelligent systems. So you say you wrote it's not existential, but I think it is existential for countries who don't build up to this kind of level of AI, and it's an emergency because it's going to take at least several years, even with a coalition of the willing, to bridge that gap. But it is feasible, in my opinion. You look at, DeepSeek was a 2 years project. So I think this is something totally feasible right now.
Yeah, and if I may add to what indeed I cannot agree more that it's feasible, and we need also to add massive funding, public and private funding, to make it happen. And this was highlighted by the Draghi report, and I think that it will enable the strategic autonomy of France and of Europe, and have this collaboration between countries in Europe and not having only a single country mindset. This question of funding and the roles that's being taken by corporates and by governments and by academics, do you think that the AI is creating a lot of changes into this balance?
It's a good experiment. I think the pilot, what we call AI exception, is the AI pilot. I think it's a good. We have to do it on AI primarily. Europe is a regulatory giant and a budgetary dwarf. That's what we are. We have various tools of economic policy in Europe. Maastricht, for example, we say deficit should not be more than 3% of GDP. We put on the same footing, spending on administration and spending on growth and green transition. Then we have competition policy, but under the pretext of competition policy, we preclude any form of industrial policy. We don't have anything like DARPA, the Defense Advanced Project Agency, or the BARDA, the biology. We don't have anything like that. Some people believe that the European Innovation Council is a DARPA. It's nothing to do with the DARPA. It's a bureaucratic thing to help existing SMEs. We don't have that. And the budget, European budget, 1% of GDP. So what can you do? And the only time where we allowed for more EU borrowing was COVID. COVID was perceived as an emergency. So we don't have the tools in Europe, you see, to really say, in the US, they have the DARPA, they have the IRA, they have all what they will invest now in AI. They do huge investment. China, it's enormous what China has done. I mean, all the programs that they had. And Europe is not there. And we need to, and it's not only Ukraine. It seems that it's only Ukraine that mobilizes people. Ukraine is very important, but it's not the only thing that should mobilize us. And that's what I wanted to.
Yeah, maybe. Just thank you for these thoughts. Maybe as a conclusion, I would be curious to hear your thoughts on the most exciting opportunities for us in terms of AI and research and advancements. So if I can hear each of you on that.
Opportunities, well, what excites me on the positive side of AI is the applications of AI in scientific discovery. In fact, people are too much thinking about AI to build a product, but the biggest transformations in our society through AI are going to come indirectly, as AI is used as a tool to devise new technology that did not exist. And that's across all the sectors. So this is something that could be targeted in directions of, for example, the UN Sustainable Development Goals, health in general, and many of the issues that exist around the world where we need a lot more scientific research and it's very expensive to do. There's a potential to accelerate that research or reduce its cost, and do more with less as we continue on this path. But it has to be, again, something intentional. It's not necessarily the thing that's the most appealing to the commercial, pressures or profit maximization. Eventually, it might, but a lot of that work right now is actually happening in universities, and they don't have enough compute power. They don't retain the talent. So this is a case where we need government investment, moonshots in various application areas of AI, and it doesn't always need to be like the super large models either. Although I do think that the fundamental advances in science are going to come because of these most advanced AIs as well, if we steer them well, and by the way, we don't need these discoveries to be made by AI that is agentic, in other words, that is completely autonomous. We just need AI systems that do like scientists. In other words, understand how the world works based on the data that they have, propose hypotheses, propose experiments, but don't need to have goals and long-term objectives of themselves.
So two things. First, a big +1 to what Josh was saying about scientific discovery. That's really where the driver of all the economic growth and our improvements of our living standards and addressing many of the challenges. And we both showed the Aidan Toner Rogers result that there was evidence of remarkable improvements. And there are more and more systems that are specifically being designed to help with scientific discovery, going back to AlphaFold, and these are tool systems, not necessarily agentic, that more and more scientists are beginning to use. I'm beginning to use it. I encourage all of you to start using deep research and some of the other tools. 4 or 5 months ago, I found these tools to be not all that helpful. It's just a sea change now in terms of its ability to really help me formulate things. I admit I was kind of annoyed one time when I thought I had an original idea and I was thinking about it, and then I asked the tool to help me with it, and it kind of spat out a lot of the things that I had been privately thinking. I had fed it my papers, so maybe it had a little bit of a head start, but it's remarkable how it's able to not just synthesize across a lot of things, but also even, increasingly, I think you'd have to call it some original thinking. The second thing I want to emphasize is the one thing we talked about at the beginning, I think most of us did, which is this opportunity to continue to use AI to work closely with humans. And I don't think there's been enough of an emphasis. And I talked about the Turing trap and just simply having AI imitate and replace humans. I think it's a very destructive direction, both in terms of the output it can create and also the way value is distributed. When I talk to managers, which I spend a lot of time talking to CEOs, there seems to be a very sort of lazy thinking that we have a task and we're going to have a machine do that task and replace it. And they're almost always disappointed because it turns out to be a lot harder to make a machine do 100% of some job or some task. You can often get it to do 80, 90, 99%. But as we saw with self-driving cars, and I was one of the people who was fooled by that, I drove in a self-driving car in 2012 from Mountain View up to San Francisco. And I thought that it was just around the corner to have it done. And of course, that last mile, literally, and the last bit is much harder. And that's true in many, many tasks. So although one of your questions, I talked about a hypothetical future where AI can do most things, I think we have a significant runway, and I don't know how long it is, where it'll be like chess, where there'll be a lot of tasks where at first only humans can do it, and then machines can help. Then at some point, machines can do it better than humans. But even after that, there's going to be a period where humans and machines can beat the machine by itself. Now with chess, that window ultimately closed. But chess, when you think about it, is an awfully simple, board compared to the complexity of the real world. So for most other tasks, I think we'll progress through those different levels at a longer pace. And the big opportunity there is to create AI that's more understandable and interpretable by humans. You know, there have been some studies of humans, doctors, working with AI systems, and the human plus machine did worse than the machine by itself, contrary to what I was saying should happen. I don't think that was an inherent outcome of them working together. It was because there was such a bad user interface and such a bad understanding by the doctors of when to overrule the system and when not to. But if we could build systems that not only say, you know, cut off the left leg, you know, I'm 90% sure that's the right thing to do, but explain why you want that particular action, then the doctor could make a judgment as to whether or not to overrule it or not overrule it. And ultimately, these human plus machine systems will create more value, but also by keeping humans in the loop, continue to have us have a level of power, which I think is the thing I said I was most worried about, that we need to have a way that we have some of that economic and ultimately political power.
So I will bring us back to political institutions again. I mean, we're watching a tech coup in the US, as folks know, where concentrated tech power is really also acquiring power over our core political institutions. Now, I've offered several critiques of this today. I want to say, though, there's one thing that is right about what's happening, which is that it flows from a recognition that our political institutions have been failing, that they have not, in fact, been serving society well. Now, I have a very different vision of what it means to serve society well than somebody like Elon Musk does. Nonetheless, I think it is true that we can use technological affordances to reimagine political institutions in support of democracy. So collective intelligence, social dialogue, social listening, all of these things can be embedded in our political institutions and achieve a greater degree of responsiveness, flexibility, openness, accountability, and transparency than we've had. Reconnect our institutions to the people so that we are actually steering for the good of society and, again, can crack through that alienation and frustration. And so that is a tech challenge, a tech puzzle. Like, tech can help solve and address those problems. The last thing I'll say is that in addition to being excited about the power of AI, we should be excited about our human power. And to that end, I mean, I 100% agree, Joshua, with your point about decentralized steering for superintelligence should it emerge. And so perhaps we should also give ourselves the social technical challenge of how do we establish governance for that. Perhaps the thing to do is to start now on a sort of work on a treaty involving the commitment that if and when superintelligence exists, we all have already agreed before it has come to exist that it is the common property of humanity, like the moon, and then move from there. And this is the moment to achieve such a treaty before it has actually come to exist.
Thank you very much. And thank you, Joshua, who has to go. I think we're done. So letting you the floor. And thank you.
Sorry. So we have one interesting question from the public. It says, why are the critical domains, like the history of technology, cybersecurity, environmental sustainability, and psychology, underrepresented in the report? Given their role in understanding AI risks, are we missing lessons from history, and do you see opportunities to integrate these perspectives in future work?
Sorry, can you...
I think that was a question for Joshua, actually, in the AI safety report, wasn't it?
Yeah, so basically, why are critical domains like the history of technology, cybersecurity, environmental sustainability, and psychology underrepresented in the report? Given their role in the report, yeah.
Oh, yeah.
Given their role in understanding AI risks, are we missing lessons from history? And do you see opportunities to integrate these perspectives in future work?
Yeah. So the report, you know, we had 6 months to write the report. We tried, we pushed on the, the economic impact. We pushed, and we deal with various topics. For example, the environment and AI. It's a subject that requires lots of research because, of course, on the one hand, AI uses energy, but on the other hand, AI helps optimize on the use of scarce resources. And there is still research in progress to assess the relative importance. You see, we know that there are various areas, for example, water management, where AI has had very, very positive effect, reduces waste enormously. But the thing is to quantify that. Research is slow. The problem is that, you can do as fast as you know. So what we do in the report is to acknowledge the importance, AI and social dialogue, AI and education, AI. But there, the research needs to be done. And research is slow. Already that we could do with Simon and look already a bit at the growth and employment impact already we did that short period. That's I never thought we would do that. It's not that those topics are not important, that research takes time, that's the thing. But I believe it's hugely important, particularly environment and AI. I think that's a hugely important topic. And I work on green and I work on AI. I haven't worked yet on the intersection, but that's on the research agenda. Thank you very much.
Thank you. Yeah.
Okay. As a next question, it will be around having a world built on AI. So one of the things that people fear today is that it's not possible currently to check that your data, your own data, is not used inside training data. And so how do you think we can protect creations from being part of training set without the author consent? And do you think that authorship persists if a generated creation is inspired by an existing work?
So this is an increasingly important question, and I can't speak to the laws in other countries, but in the United States, I know that there's a lot of confusion. Companies are worried about using LLMs because they're unsure whether or not they're infringing on different copyrights. And now, ironically, OpenAI is suing DeepSeek for potentially using some of its data, and New York Times is suing OpenAI. I don't know whether DeepSeek is suing New York Times yet, but a lot of companies are suing each other right now to try to determine who has the rights. Part of the problem is, of course, that these laws were written before LLMs or any of these technologies existed, so it's not quite clear. Copyright literally bans you from making an exact copy or something very similar, and so the big LLM companies are arguing that, okay, this is not, we're producing original output that's not identical to what went in. That said, the purpose of copyright is to provide incentives for creating valuable content. It's in the US Constitution. I think there's something similar in other countries. So if your goal is to encourage people, authors to write books and poems and do original investigative reporting, you need to provide incentives for them to do that work. Otherwise, if they have no incentives, they won't do it. Maybe some of them will do it for, of the goodness of their heart as volunteers, but in general, you want to have some of the rewards flow back to them. That means you need a new paradigm. And so right now, a group of us, Zoe Hitzig, Gabriel Unger, and I are working on an economic paradigm that just, starts from scratch, set aside what the existing court rulings and laws are. Ideally, what economic incentives would you want to provide? And the answer, of course, is you do want to provide some of the benefits to flow back to the original creators. You also want some incentives for the LLM creators to use that. You want some incentives for the downstream groups to take advantage of them. And depending on how important each of those parties are to the ultimate value creation, you want to have more of the value flow to them. So we're developing a model basically using incomplete contracts like I learned in Philippe's class, I won't say how many decades ago, many decades ago. In order to do that, we ultimately are going to have to rewrite the law significantly. And I know I've spoken to some US senators who are interested in rewriting the laws to take advantage of this, but your question is one that's becoming more and more relevant. The only other thing I'll say is, in addition to the laws, there's also a number of companies like ProRata and others that are developing platforms to keep track of how the content is used and give a mechanism for licensing revenues to flow to the creators.
Thank you.
Yeah, so I'm sorry if we're running a bit late, but I have a last question on a topic that I think is really important and has not been addressed yet on the past 2 days. I think it's a real democratic challenge and AI challenge, and it's about recommendation systems, because they are like everywhere on social medias and they're becoming a very important ways people use to inform themselves. And they're completely controlled by big tech companies, and they're really opaque on a technological level and on a political level. And so I was wondering, what are your opinions on the challenges of recommendation systems and how AI can be helpful or harmful in addressing these challenges?
Well, you're right to name that as a considerable problem. And so I think there are a lot of experiments underway for alternative algorithms, but also I think transparency standards. And so in that regard, figuring out how to help build civil society, third-party actors who do have access to the relevant compute and so forth, capacities that they need in order to do auditing as a part of it. So again, it comes back to the theme of power. Right? That is, we can't really solve this problem until we actually rebalance how power is operating and with regard to tech development. So I'm sorry I keep coming back to the same point, but I want to just thank you for bringing up that important issue.
Go ahead. No, that links to something I said before. The problem with IT, in IT you had the emergence of the superstar firms, and then they dominated. And that's because competition policy didn't adapt. That's really, so we have to regulate competition, but it's important to have all the time new actors. That's a very it's usual thing. You have revolutions, you have emergence of big actors, and you want firms to grow. You want the good people to succeed, but you want to make sure they don't use their power to prevent newcomers and to monopolize and now to decide about democracy. You see what I mean? And that's where civil society is so important. You see, because very often, if you don't have civil society, the government can be bought out by the big incumbents. You see what I mean? And then democracy is out. And that's why it's so important to have the civil society on top of government and firms. If you don't have this third edge of the triangle, then you are up for the biggest dangers, I think.
So I share the concerns of Philippe and Daniel, and I've written about that. But in the interest of balance, I'm going to say a word in the support of algorithmic systems, because they often can reduce bias and reduce and decentralize things. I did papers looking at recommender systems at Amazon, and they pushed smaller books, smaller records, things that it prevented the concentration of a Pareto curve where we're just a few big winners. There's studies looking at hiring and algorithmic systems. Of course, we've all heard how they can perpetuate bias, but Danielle Lee did a nice paper where she found that the opposite, that a system could be used to have fairer hiring, more representative, more diversity, as well as higher overall performance. Similar results have been found in bank lending, in medical triage, and what was the third one? Oh, parole systems. So, and just anecdotally, I was talking to my Uber driver recently, and he was complaining that when he was working at the taxi company, the human dispatcher was very biased. He thought they were always giving the good rides to his friends, and he was one of the insiders, and he preferred this system where it was just based on the algorithm. So I want to say that if we've all been saying in the panel, if we can steer the technology in a way that creates a broader, more fair outcome, it actually can do better than humans, because after all, the sad news is, as we all know, humans are pretty biased. They often concentrate power among themselves. It's difficult to remove racism, sexism, and other biases from humans. It's often more possible to address those in algorithms and create systems that automatically check for at least some of the more common kinds of challenges. So done right, I think that these can be powerful tools to create more diversity, more fairness, and better outcomes.
Thank you very much for this very inspiring discussion. And thank you, everyone, for listening.
Just to echo what Alice said there, thank you so much to our panel. It was riveting. Great to have you with us today. That brings us to the end of our two-day conference. Just like that, we don't know where the time has gone. It's absolutely flown by. Thank you to you, our audience, for taking part in this, because without you describing, without you and your enthusiasm, conferences like this cannot take place. So thank you very much indeed. We hope you have many takeaways. Let's reimagine, let's rethink, and let's, as Danielle's been telling telling us, shift the paradigm. It's essential. Just before we go, I'd like to call our speakers, our PhD students, our entire scientific committee on the stage. Let's have a family photo. It seems apt.